microfoon handig.
One, two, 1, 2. Fickle my heart and how oozy my eyes. I struggle to find any truth in your lies. And now my heart stumbles on things I don't know. My weakness I feel I must finally show. Let me your hand and we'll conquer them all. But let me your heart and I'll just let you fall. Let me your eyes, I can change what you see. But your soul you must keep totally free. Ah, 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 ah. Awake my soul. Awake my soul. I fickle my heart and how oozy my eyes. I struggle to find any truth in your lies. But now my heart stumbles on things I don't know. My weakness I feel I must finally show. Ah, 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 ah. In these bodies we will live, in these bodies we will die. Where you invest your love, you invest your life. In these bodies we will live, in these bodies we will die. Where you invest your love, you invest your life. Away, my soul. Away, my soul. Away, my soul. 'Cause you were made to meet your maker. Away, my soul. Away, my soul. Away, my soul. 'Cause you were made to meet your maker. I've been trying to do it right. I've been living a lonely life. I've been sleeping here instead. I've been sleeping in my bed. Sleeping in my bed. So show me family, all the blood that I would bleed. I don't know where I belong. I don't know where I went wrong. I could write a song. I belong with you, you belong with me. You're my sweetheart. I belong with you, you belong with me. You're my sweetheart. I don't think you're right for him. Think of what it might have been if you took a bus to Chinatown. I'd be standing on Canal and Bowery. She'd be standing next to me. I belong with you, you belong with me. You're my sweetheart. I belong with you, you belong with me. You're my sweetheart. And love, we need it now. Let's hope for some. 'Cause oh, we're bleeding out. I belong with you, you belong with me. You're my sweetheart. I belong with you, you belong with me. You're my sweetheart. 'Cause you're a sky, 'cause you're a sky full of stars. I'm gonna give you my heart. Because you're a sky, 'cause you're a sky full of stars. Because you light up the path. I don't care, go on and tear me apart. I don't care if you do. Ooh, ooh. 'Cause in a sky, 'cause in a sky full of stars, I think I saw you. I think I saw you. 'Cause you're a sky, 'cause you're a sky full of stars. I wanna die in your arms. Because you get light the more it gets dark. I wanna give you my heart. I don't care, go on and tear me apart. I don't care if you do. Ooh, ooh. Because in a sky, 'cause in a sky full of stars, I think I saw you. I think I saw you. Cause you're a sky, 'cause you're a sky full of stars. I wanna die in your arms. 'Cause you get light the more it gets dark. I wanna die in your arms. Lights will guide you home and ignite your bones, and I will try to fix you. Try your best, but you don't succeed. When you get what you want, but not what you need. When you feel so tired, but you can't sleep. Stuck in reverse. And the tears come streaming down your face. When you lose something you can't replace. When you love someone but it goes to waste. Could it be worse? Lights will guide you home and ignite your bones, and I will try to fix you. High up above or down below, when you're too in love to let it go. But if you never try, you'll never know. Just watch your world. Lights will guide you home and ignite your bones, and I will try to fix you. Tears stream down your face when you lose something you cannot replace. Tears stream down your face, and lights will guide you home and ignite your bones, and I will try to fix you. If this is to end in fire, then we should all burn together. Watch the flames climb high into the night, calling out, Father, oh, stand by and we will watch the flames burn open on the mountainside. Ah. And if we die tonight, and we should all die together, raise a glass of wine for the last time, calling out, Father, oh, stand by as we will watch the flames burn open on the mountainside. Desolation comes upon the sky. Now I see fire inside the mountain. I see fire burning the trees. I see fire hollowing souls. I see fire, blood in the breeze. And I hope that you remember me. Should my people fall, then surely I'll do the same. Confined in mountain halls, we got too close to the flame, calling out, Father, oh, hold fast as we will watch the flames burn open on the mountainside. Desolation comes upon the sky. Now I see fire Inside the mountain I see fire, burning the trees I see fire, hollowing souls I see fire, blood in the breeze, and I hope that you remember me. Look at the stars, look how they shine for you, and everything that you do. They were all yellow. I came along, I wrote a song for you, and all the things that you do, and it was all yellow. So then I took my turn. Oh, what a thing to have done. And it was all yellow. Your skin, oh yeah, your skin and bones turned into something beautiful. You know, for you I love you so. You know I love you so. I jumped across for you. Oh, what a thing to do. 'Cause you were all yellow. I drew a line, I wrote a song for you. Oh, what a thing to do. And it was all yellow. Your skin, oh yeah, your skin and bones turn into something beautiful. You know I love you so. You know I love you so. It's true. Look how they shine for you. Look how they shine for you. Look how they shine for. Oh, it's true. Look how they shine for you. Look how they shine for you. Look how they shine for. Look at the stars. Look how they shine for you. And all the things that you do. And it was all yellow.
Good morning, everyone, and welcome for you watching at home. Welcome to Kotlin Dev Day. We're super excited to have you all here, and we're immediately going to start off with a banger, designing a DSL with Kotlin. Take it home, Nicolas. Fränkel. I don't think you need this mic. Go ahead.
No, it's good.
Yeah.
Everybody hears me? Well, probably you hear me. Studio says everything is fine. Perfect, thanks a lot. Thanks to be here. I guess that was not easy for you. It hasn't been an easy ride for me either. But I'm very happy to be here in person and to have the first slots, the slots just after the coffee, which is a bit dangerous. So I hope I will be entertaining enough. I'm Nicolas Fränkel. I've been doing development for 20 years. Now I'm a developer advocate, so I don't know if I'm still a developer or not. I leave it up to you. And since a couple of years, I've been a Kotlin fanboy. I work for a company called Hazelcost, and though this talk won't be about Hazelcost, I need to justify my salary, so it's just a slide for Hazelcost, and everything will be said afterwards. So Hazelcost is a product. Who here works on the JVM already? Yeah, quite a few people. Who knows about Hazelcost already? Okay. So I won't repeat it because you already know it, but you might not know that in the latest version of Hazelcost 5.0, we have added streaming capabilities. So you can not only store data as you used to, but you can read from like a data store, transform it through Hazelcost and put it in another data store, which could be Hazelcost or not. Anyway, domain-specific language. Anybody has ever written a domain-specific language? Yeah, real engineers always try to write a DSL at one point or not. Now, you should always try to create your own library, create your own framework, your DSL, or even your own language. Otherwise, you fail your life. If at 40 you never tried, and I failed my life. But anyway, so the idea of a domain-specific language is that you let go of some of the capabilities of like a general purpose language, but you adapt the language to a very specific focus area. And actually, probably, even if you never try to write a DSL, you probably have been exposed to DSLs. We have XML, which can be considered a language or not. I leave it up to experts. But anyway, if you have XML, it has a lot of capabilities. You can reduce the capabilities to have SVG, to create graphics, or to create mathematical formula with MathML. In Java, as we will see, it's a bit harder because Java doesn't lend itself to DSLs, but especially in assertions. In assertions libraries, you will find a lot of DSLs available. And in Kotlin, well, there was Unco. Rest in peace, Unco. It's deprecated, right? Yeah. That's what I remember. And I've written my own, which is called Coroutines, and it was just like a proof of concept. And I will try to write one with you. So I assume that a lot of you know about Java. And actually, if you want to write a DSL in Java, you are quite limited. The features available are quite limited to create DSLs. The first is, of course, you can like order the methods, you call them in order, and can be thought as a beginning. Then you can chain methods. That's actually what you do all the time. You do Fluent APIs, so even when you have got setters, you return this, and you can call set, one after another. And afterwards, it gets not so great. So with like method calls and lambdas. So here is an example for asset4g. And you can see that we are using like method chaining quite a lot. And it's good, but with the second example with lambdas, then it doesn't read as much Fluent as we would like. So for a DSL, in my opinion, I have two goals. It should look declarative, but it's still code. So I can still use like conditions, and I can still use loops and whatever. And the rest I will be coding. Well, trying to, because live coding is always fun. Oh, could be interesting stuff with the glass. I will put it here. Better. So I make Sebastian happy, I think, using IntelliJ. So here is a Vardin code. Who knows about Vardin? Quite a few already. Well, okay. So Vardin is the way to write graphical user interface that generates HTML, JavaScript, even CSS without writing a single line of them, which is good if you are a backend developer like me and you want to have something nice and shiny like me and you don't want to learn JavaScript at all. And even if I assume that even if you never dabbled into Vardin, you can probably understand this stuff if you have done any swing. Here you set the theme, here you create a vertical layout, you create a component, a labeled component, text field component, you add them, you set the margin, and then you set the content of the UI to the layout. And the problem with this code is that actually you can swap some of the lines without any effects on the rendering. And depending actually on what you want to achieve, here I've swapped a few lines and it doesn't change anything. The real places where I want to see stuff is here. Do I want to add the field first or do I want to add the label first? And a DSL could help tremendously here. So what I want to do is I want to create a DSL for Vardin. And because I've got no imagination, I will call it Cardin. So first thing first, I will create my Kotlin UI. And I will first make it a bit bigger. And then, because I'm super lazy, I will just use IntelliJ to transform the Java code into Kotlin code, which is great. So the first thing that I'm leveraging here, and I'm not leveraging it even, like I let IntelliJ do it for me, is actually I'm using this kind of stuff. So instead of writing set theme, and I put it here, valo, not value, and those two are interchangeable. And even IntelliJ tells me, hey, you can change it, you can use the property. That's pretty nice. So makes it a bit nicer to read. Of course, that's just only the beginning. Now what I want to do is I want to create a function that creates a vertical layout. So in Java, you would probably use a static method. Right? Okay. And in Kotlin, we can do the same with companion objects. So let's create such a function. A function, we will call it vlayouts, and it will, let's say at the beginning, create a vertical layout. Now we can say here, vlayout. That's nice, but actually that's because we have been tainted with Java. The problem with this approach is that in Java, everything must belong to a class. Static methods? What for? So you know about the math class. You've got all those nice static methods inside. And in that case, the class is just an additional namespace. Doesn't make any sense. So I could easily do the same. And if you've got static methods in Java and you copy paste them in IntelliJ in a class, you will have a companion object. But yeah, first thing first, just remove this additional namespace. It doesn't make any sense. If you want to hide it, if you want to make it only available here, you can say it's a private one. But just, I mean, so far I've never used a use case. I've never seen a use case for a companion object that was really compelling. Unless, of course, you want to make it compatible with Java. Then it's better. But in that case, we are in the Kotlin world, so we don't care that much. So I want to create the vertical layout, and now I will be doing my stuff. So I want to have all those lines together. So I want now everything like this vertical layout. I want to do it like this. So I will change it to block body, and I can create it like this. If at any point you've got questions, don't be shy, just ask them, and I will be happy to have some interaction, because for 1.5 years I was sitting at home talking to my screen, and that's not the most interesting interactions I've ever seen. So yeah, you are here, we can talk, no worries. And here I need to set the content of the UI. So here I would probably need to pass the UI, and here I would like set the UI here and say, hey, UI.content equals layout. Looks good to you? Yeah? Yeah, so far so good. Again, if it's live coding, so I might do some bad stuff, just let me know. Okay, and that's where, you know, a lot of people say, hey, we come for Kotlin for the null safety. And of course, null safety is very nice, but what I really, really love is extensions. So extension functions and extension properties. Instead of passing the parameter here, what we can do is we can, like here, say, hey, we will make believe that now UI like as an additional method. In the end, it's compiled to like a static method would be in Java, but it's very nice. And here we can say content.layout. Okay? Great. Now what I would like to do is to make this a bit perhaps nicer. So what I could probably do is I could use the apply stuff. So I would just do like this. So here I would say this, and here I this, and here. And now because I return the layout that I've just created, you can write something like that. And because I'm super lazy, I can write something like that. Nice? Yep. The thing is, this apply stuff, I use it a lot, especially when I design DSLs, because then I have this master view detail. Like I am only interested in the big picture, and if I'm interested in the detail, I can always say, oh, okay, what happens here? But for most of the port, I'm interested in big picture. I can have a quick read at the code and understand what it does. Great. So here I set the margin to true, and as the provider of the DSL, I would like to provide some more flexibility. So I would probably say here I have the margin and a margin, and it's a Boolean, and there is another thing in Kotlin called spacing, and here it's also a Boolean. So what I want to do is I want to set the margin to margin, and to set the spacing to spacing. Yep. Yep. And here it tells me, hey, you didn't pass any value. Okay. So from Java, what I would do probably something like that. I would create another method without any parameter, and I would call it like vLayout, and I would pass true. And I would probably need also an intermediate method, or two, one for margin with the default value and one for spacing. And if I do the same, no, I will do it like this. I can say here margin Boolean, and here I would say margin, and here I would say spacing, Boolean, and here I would say true and spacing. Oops, doesn't work that well. because now we've got the same method with the exact same signature, a Boolean in parameter. That's a bit sad. So in Java, this is how we would do it, and as a DSL designer, you would have to choose whether to value more margin or spacing by default. Choose one of the two. Which one? Wow. Sorry? Margin. Margin is a very good choice. Okay, perfect. And then the people who want to set spacing, hey, they need to call the one with the two parameters, which is not great. So instead, in Kotlin, what you can do is you can pass default. So I said the default was true. Well, if I put a big T, it doesn't work that much. What did I do wrong? What am I doing wrong? Yes. Okay. And now it compiles, and now by default everything is true. And now the good thing is I can call a vlayout like this. I can call a vlayout saying, hey, here I want to have margin equals true. So I will say margin false. False, sorry. And then spacing by default will be true. But you tell me, hey, now I want the margin, the spacing to be false. So I need to do something like that. So I'm overriding with the default value, which doesn't make any sense. Don't worry. Use named parameters. And now you've got you're covered. Good. Then we can continue. And what I want to do is here I use apply. Everybody is okay with apply? Yep. So I want to do the same here. I want to apply it, what I did here. Again, I want to have a master view detail, a master detail view, and here I don't need to set the vlayout anymore here. So I want to add a vlayout. But for DSLs, it would actually be much, much better to have something like that. Would looks much nicer. Yeah, forget the red stuff. So we can do it. So what we can do is actually we can create a so-called lambda with receiver. And the lambda with receiver, and I mustn't forget it's vertical layout dot vertical layout dot nothing, and it returns unit. And with that, we can apply here what happens here, and we say apply init. And now we can just say, hey, and look, we can remove the parents if we don't need them. So this code will actually be executed here. Now, as a language designer, you need just to have, to make the following decision. First, do you want to apply the init and then to override it with your own stuff, or to let the client code have the last word? There is no right or wrong decision, it depends on your use case, but you must think about it. What is the most important to you? That's pretty nice. But now imagine we want to have vertical layout for whatever reason without any code inside. Oops. Oops. Too fast. Tells me, hey, you must pass something for the init. And I say, okay, then the default value will be empty. So now we can have both empty vlayout or something with layout. Something that I didn't mention is actually we can write that because normally the syntax will be something like this. But in Kotlin, if your lambda is the last parameter of a function, you can move it outside of the parents. Okay. Well, the trick, now you know it, I will do the same with the fields. So I can do the same with the fields. I would say, hey, vertical layout dot field, or let's call it text. And I will pass in the text, I pass a caption, string. Then I can create text fields with the string, with the caption. Oops, caption. And then I can apply. I need to also to pass this init stuff. So I'm lazy, I will copy paste it. It won't work because it's the wrong signature. So here I say, hey, it's a text field. And now I will say init. Apply init. Okay. So, hey, I forgot something very important. Here I'm setting the content. Here I need again to apply, to add. So this is not fun. This is actually quite sneaky. So this add text is the vertical layout. Who here is a JavaScript developer? Wow. Sorry for that. Yeah. So I'm not a JavaScript developer, so I can say a lot of bad stuff about JavaScript, but I know this. And perhaps it's not true anymore, but at some point, this in JavaScript referred to the current object. And if you add a level of nesting, an additional level of nesting, this pointed to the current object, so you lost the reference to the parent object. And you had this trick to say that equals this, so you could still keep the reference inside. And Kotlin has it better. It's not super great, but it's much better. And I don't know how better it could be, so it's not great, but I think it's the best. We can reference like the vertical layout with this dot text, and then we can say, hey, add component this. I like when it's a line like this. And now we can like change this stuff, and we can say instead of this, we can say I called it text and words. And because I have added this lambda with receiver, we can do stuff on the text if we need to. Pretty good. Now let's continue because, well, we found how we did it. I will create the label now. And the label as it's called a text. And here it's a label. Yeah, the hardest part is to copy paste. No? And here we say texts, and we say this text label. Okay, and perhaps also here we need to set the contents mode. So I have an additional content mode. Content modes dot. No, here contents mode dot text. Yuppie. If you also do a lot of copy pastes, I think here it doesn't work because I'm in the old Kotlin version, but in the latest Kotlin version you can add trailing commas without issues. It's always nice. Yeah, something I didn't mention, I'm using a super old version of Kotlin. Ooh, not great. But this is to show you that even in the old version of Kotlin, you can write this kind of stuff. Doesn't change a thing. You don't need to have the latest and greatest. So here label and here contents modes. And now I can have finally the label. And here I can have this stuff. And look how nice it looks. And here, what you see is what you get. You want to change the order? Done. You cannot make a mistake. Well, you can make mistakes, but it's seen. It will be seen. Now we can do a bit better. Notice that here I am using the label, and I said, hey, by default it's text, but here I want to override it with HTML because I'm setting HTML. Now imagine that in your DSL, you've got a lot of HTML. The client code uses a lot of HTML. You can say, oh, then in that case, we could have here something like HTML for a step. But actually, we can do better. We can create a dedicated function, because you don't need to map one-to-one. You can add additional features. So here we can say, I will copy-paste, because again, I'm lazy. Here we say, hey, here we have something called HTML, and here it will be like this. And we will call HTML, oh, whoopsie, HTML label. And we will pass the texts, contents modes, HTML, and init. Now we can say HTML. So even if you start with an API that can be improved, let's say, you can improve it by yourself. And it depends a lot on the client codes. What do you want the clients to write? Sounds nice to you? Any questions so far? Good.
A minor thing I was thinking is why, because applying these labels is what you say also quite ugly. You also could use also, right?
Yes, that's true. But with this version, I'm not sure the also stdlib is already available. But you're right. Yeah, now you can use also, but you know I started a bit earlier, and I'm old. It's hard to change my ways, but you're right. You should use also. And now imagine we do that for all the Vaadin library. No, you have it in your head? Good. And here it is. This is what I did. So again, here is the result. Button, native button, link, progress bar, whatever. Here is just for the documentation, because I'm using skdoc, so it's just not important. And if we run it, so here I have two modules. The core is the DSL designer, the core is how I design the DSL, and this one is what I call the sampler, is actually the usage. And now I can show you how it works. Not like this. Oh no, no, no. Oh no, not my demo. Did I make a mistake? Ah, I know. I need to be connected to the internet. Is there any Xebia guests? Yeah, but wait. I need the password. Probably you don't want to tell the whole world your password. So I will use my own. No worries. Everything is fine. That's really live coding. So share internet connection. Now everybody knows my phone. No, you don't know. Ah, it works already. That was fast. And yeah, so here, the buttons. All the nice little buttons, they are nicely aligned, and here we can see how I created them. Button, Okay, with nothing, button with a caption, button with a caption and an icon, button with a caption and an item listener that I call onClick, and here with everything. And this is here, doesn't do anything. Here I have an item listener. I mean, I really had a lot of fun. I have 10 minutes, which is good because I'm nearly finished. Really nice stuff. So the table, the grid and the tree, I don't even remember how I did them. Not this. Here. I have code inside. So it looks declarative, but actually I can do pretty fun stuff inside. And because I only have 10 minutes and I want to have some room for questions, I will finish now. So, now the question, yeah, we are at a Kotlin conference, but still, we need, because you are at the Kotlin conference, but perhaps you are a Groovy programmer. You say, why not Groovy? Because I love compile time checks. I mean, I started my journey with coding with Java, and I really couldn't, I have a very hard time launching my program to check if it works. I want to fail fast. So Groovy, before Kotlin, was the language on the JVM where you could create DSL. But actually, you had to run it to check that if it worked. Why not Scala? It's a good question. Actually, a lot of Kotlin's ideas and concepts come from Scala. Yes? No. In my opinion, a lot of them. But in my opinion, also, Kotlin is very pragmatic. What I disliked, I tried to learn Scala before. I was a consultant for 18 years, and the thing is, I try every time when I talk with a customer to make everything explicit. Now, Scala has an implicit keyword, which for me is very hard because, yeah, some magic happens and it's very hard to trace. So yes, you could use Scala, and probably you will get the same result as I shown, but the foundations, the fundamentals of the language are quite different. Perhaps with Scala 3 it will change, but let's see. So in this talk, I've shown you several features of Kotlin that you could use to create your own DSL. So first, 100% Java interoperability. I've used Vardin seamlessly. You could use properties. You can use extension functions. Again, for me, this is the killer feature. Named parameters and default values are very, very nice. Lambda with receiver, very great. What I didn't show here, because I didn't need to, was in Kotlin, you can do operator overloading. Not operator overloading like in Scala, where you could have a bang, bang, hash, whatever. You can have anything, but you have a limited set of operators where the meaning is well understood by everybody, like plus, everybody understands. Hash, hash, bang, bang, I don't know if anybody has an implicit understanding of it. I didn't use reified generics either, but you can do really a lot of good stuff. Anybody here is a Spring developer? Yeah. So you know that with Spring Framework 5, there is a route DSL in Kotlin and a bean DSL, and the bean DSL use reified generics. So you could just say, hey, I just set the dependency that it requires using just a function called ref, and it will inject the bean with the right type, just because of reified generics, and it compiles. Also, you can use the infix operator. If you've got one single parameter on your function, you can just say, hey, this function is infixed, then you don't need the parents around it. So you can read my blog, you can follow me on Twitter. If you are interested in the demo, well, here there is this bit.ly link here. And though the talk was not about Hazelcast, you can join the Hazelcast Slack or get some free training. And now we've got 5 minutes for questions. Wow, just on time. Thanks. No question. Yeah. I'm afraid already.
Let me get the boomstick.
You will get the boomstick, or I will need to repeat, and since I'm lazy, I prefer that you
Okay.
tell it once.
Is there a particular reason why you didn't use the property accessor syntax for the set margin and set padding?
Yeah, I think there is an issue with that. That's a good question. You've got an eagle eye. Yes, there is a reason. It's because I can use it on one, but not on the others. And let me show you. Kotlin DSL, here, this one. So here, it tells me, hey, use it. Great. But here it tells me, hey, no, you cannot use it. Because I think I need to do something like this. And I think it's margin info that I need to pass, something like that. No. Yeah, something like this. Yeah, something like this. And if I do this margin, yeah, it doesn't work. So I remember well it's margin info. So it doesn't look that nice. I need to be careful with you next time. But it's a good catch. So I in that case, I preferred to have both the same so that we don't get into this trouble. Then it's a little less nice, but at least, I mean, it's consistent. No more questions. I guess you will get one more coffee. And thanks a lot for your attention and enjoy the rest of the conference.
For the people waiting in the stream at home, we're going to start at 9:15, so be there. All right, welcome back everyone. Have a seat, get comfy. We're going to start off with coroutines and what to do and what not to do with Gerard Klijs. If you have any questions, save them until the end, because if you do them in between, they might already be covered later on in the talk. So save them for the end. We'll have some space there. Also in the chat, if you have any questions, put them in and I'll moderate them. Give me 1 second because I'll run over with the boomstick and you'll be audible for everyone as well. All right, have fun.
Yes, thanks for the introduction. So the subtitle is how to use Java APIs in coroutines without messing things up, because there's a lot of things that can go wrong. Basically, what you should not do in coroutine is blocking unnecessary, but yeah, how do you prevent that you're unnecessary blocking? Who am I? I'm Gerard Klijs. This is like my kind of profile website, where you can find the link to my Twitter and the LinkedIn stuff. So that's not, if you want to know more, a bit more about me, then that's there. I'm working for Open Web, which is basically a consultancy company. So I go to different clients to do stuff, and sometimes I get to do things with Kotlin, which I like. I've never been any Android developing stuff, so it could be that I'm saying things related to coroutines that might be a bit different with Android, and then you can ask my colleague there, Wessel, that has some experience with using coroutines with Android development. Currently, I'm working with Mendex. For people that don't know, it's a low-code platform, and the team I'm currently for is working for a solution for business events. And a small part of that solution is a bit of Kotlin code that's then calling into some Java code. So from the Java code, the Kotlin code is executed. One of the problems we kind of encountered, or that
I found out before it went live, so that was nice, was that there was basically a method that would just start and just keep blocking and then run basically till the end of the application, which is all fine if you just start 1 or 2, because it was using the default context. But of course, if you want to do it more than you have backing up threads in your default context, then at some point it won't get started at all. So I was a bit frustrated by that, and then I submitted for this conference, and then I got picked out, and then went more into coroutines and how they work. So now I maybe could solve it with coroutines, but back then I solved it just with a good old thread pool, because I was more confident with that it would work. So what I will be doing, I will do a quick introduction to coroutines. Of course, it's so large and wide that I can never explain everything about coroutines, but then at least if you're unfamiliar with coroutines, you have some idea. Some problems with blocking, why you don't want to block, especially not with using coroutines. Then something about a CLI I built to investigate coroutines, also other solutions like using a thread pool or from the main, with some clever stuff to still do a lot of work, but from Java. And then some different kind of patterns you can use with the CLI and how you can work around that with coroutines to make it not block. So if you, So introduction to the coroutines. A coroutine is an instance of a suspended computation. That's what's also in the Kotlin guide, and that's like a bit of fake. So basically, if you want to do things asynchronously, like the example I'm now using is doing the laundry, then you have to put your wash in the washing machine, wait for some time, and then when the machine is done, you can hang it up to dry. But basically, once the machine is working, you want to do other work. But once the washing machine is done, you kind of want to, so you can see me like as one of the real threads, and I want to do work for Mendex. Once I put it in the washing machine, and once the washing machine is done, I want to kind of get some kind of signal, put the wash out of the washing machine and hang it to dry before it gets smelly or something. So, and basically, if it's a coroutine, then there are easy ways around that to switch from that context. But if you use just the regular Java threads, it's a lot harder. So this is some from an article about coroutines that goes much deeper than I go into it now. But basically, it's you can think of it coroutines as an abstraction above threads. So there's continuation and a coroutine dispatcher, and eventually it's still run on a thread. So it's also not, you're still working with threads, and you still can handle as much as you have threads. So it's not magically give you more computing power. So some differences between a job, so that's from the coroutine stuff, and runnables that are the main Java units when you're asynchronously doing things. So with Java, if you have a runnable, you can do a thread sleep if you have to wait for some time, but then the whole thread is not doing anything and it might need to do something in the background, but it can't. And you're really blocking that OS thread you have running. Well, if you have a coroutine and you have a job, you can use delay, and that won't block the thread. So then the backing thread is free to do some additional work. With Java, you basically always have a very flat structure. So you just have tasks, you just fire them to an executor, and then you can just wait till it's done. And with coroutines, you can have them hierarchical, which is nice if you want to cancel them. You can, for example, also cancel the children of the job. And also with error handling, it's also a lot nicer than with Java, because then you have to build some things around. So with Java, you're working directly on the thread, so that's also causing some of those problems. And with the coroutines, you're working via dispatcher that can help you with some of those things. So it can make it like the delay and then put something else on the thread again. So the problem with blocking is, of course, that once the thread is busy, then it can do anything else. So, for example, even if you use thread sleep, then it can also not do anything else. So if you do blocking with coroutines, you might saturate the underlying thread pool. So, for example, here is an example of the delay call that blocks for a certain amount of time before it returns. And then if your coroutine context you're using has 2 backing threads, then once you want to start a third, you first have to wait till one of the other ones is finished. So if you want starting a lot of them at the same time, then the wait time will become higher and higher. And that's just comparable to like the washing machine. If you're like blocking for 8 hours of work and you can't get any signal in between, then by the end, the wash is still in the washing machine and becomes smelly, and you have to run the wash again. So to investigate into what I can do with coroutines, what not, and how they run, I built a CLI. This you can reach from that URL. That will go to a GitHub repository. I will show some things of with the CLI. I recorded that Sunday, so I won't do any live coding like Nicolas, so I'm not that confident about it. So I just run some code, and if you really want to see the code, you have to go to the project, so I won't show any code because of time and stuff. But if you're interested in it, you can also always go to repository. The basic idea of the project is that there's a bunch of Java code that should be seen as kind of like an external API, so that just as it is, and we can change it. And then from the Kotlin code, we actually call the Java code and try to make it efficient. So what we basically want is just handle everything we do in the Java from one thread and not having a lot of threads, or even like for every task start up a new thread, because that's limited. So in the CLI there are different actions and different run types, and I will show a demo of it running if internet's well and it's well. So I used a library that makes it very easy to use CLI. So you see here this output that explains what's there. So there's a lot of things you can configure and set and play around with. And now we'll run it without any configuration. So then it will use this delay of 1 second just on the main thread. So then each time it will take 1 second till it outputs an integer and then the next one. And this is using a thread pool, which will fail because I want to try it with 10,000, and it can't create a thread pool with 10,000 threads. So then it fails. So if you want to do a lot of computations, then with the thread pool it will fail. And the nice thing with coroutines is you can do that, since it abstracts over the actual threads. So there are different kind of run types. So there's one is the same thread, so that will just run it synchronously in the same thread, each after another one. Then there's the same thread complicated. Then I do some kind of clever things to keep it in the same threads, but still do much more work. So for example, with futures, I would just first create all the futures, and only after I created them all, do a get on all the futures to really know once I'm completed. Then there's the thread pool, like I also saw in the demo, but which is kind of nice because you can do a lot of things in parallel. But if you have very much things in parallel, then it will break, because then it just can't get those threads from the OS. Then suspended, that will just use the suspend functions. So then there are some clever ways, in this case mostly using the delay with some other stuff to make it efficient run with coroutines. And also the suspended default, using the default context. So then you have the backing threads, in my case, of 12 threads, which can cause problems if you have thread safety. Because then, for example, the same kind of function might at some parts land on another backing thread, and that might cause problems, which was one of the reasons at Mendex why we used one big blocking method, And there's a few others that are experimental, like the max parallel thing that they just added in 1.6.0. So it's currently the whole CLI is in 1.6.0, so it's the latest. So when we run the CLI and we combine the run type and the action types, we get a particular behavior. So like when we run it synchronously and it's waiting for 1 second, then the whole program takes 10 seconds and you can see how it's running. But if you use it with coroutines, it becomes something different. So one of the first pattern I will talk about is just a call, which is a single call that eventually returns an int, and you can set a delay. But of course, in the real world, you can't set a delay. So for example, there might be some networking involved, and then you probably want to set some time out and handle the error. And there's not really a way with coroutines around this, because it's just a single call. So it's basically like if we use the analogy of the washing machine, it's basically like doing really the wash yourself, because you can't run away from it. So you really have to do the work yourself and wait till it's done, and then you can hang it out to dry. So this is from the first run. So this is just the default running on the main thread, and then each time it will initiate the delay call, print out the message, then initiate the second delay call, print out the message, and so on and so on. So there's not anything parallel going on there. But with coroutines, we can do some stuff like, so this is first on a thread pool, so then it's with 10, and then it's done within a bit more than a second. So that's in this way, but like I said, if it becomes a lot of work, then you can't get all of those threads, and then it won't work. And then with coroutines, we can switch context and then use more threads if we want to. So in this case, it's run with 2. So you can see, if you look closely, that each time it's getting two of those ints every second. Since they are from the main thread, it's dispatched to another context that has 2 threads. And of course, you can increase that, and then you can do more work in the same amount of time, but still you need more backing threads. So that's this picture, yeah. So here we, so from since it's suspended still on the main thread, so it's still run also on the main thread, but then the delay call is called into the separate context that has, in this case, 2 threads. So therefore it can do more work than you would expect. And also because of this, the main thread is never really blocked, which is also nice. Then some other patterns is a feature that's, I guess most people are familiar with features from Java. So basically it's, you get something, but you're not sure once you get it. And you basically, most times in Java, you would just call a get, and then you block till you have it, and then you can do something with it, and it might also be cancelled. So this is just running it with on the main thread with features, and then it will indeed, like I said, just wait for each get till it runs the next one. And then with coroutines, we can do nicer things. Yes. So basically with coroutines, we could check if the feature is completed or not, and then do a delay. And because the delay is not blocking, we can access or walk through all the features in the same amount of time. And then what I also did, yeah, suspended. So this is all locked from the main. Yeah, so there's also the complex one is creating all the features in advance, then going by them, getting them all, and making sure the work is done. But of course, this is getting more complex, which is also some of the advantages with coroutines. Like sometimes you can do the same with the same threads just from the Java way, but then probably your code will get more complex and more complex than if you would do it with coroutines. So here, indeed, so this is like just running it from Java in a complicated way, first creating all the futures, then awaiting all the futures, and then getting them and printing them. Yeah, and this is from the in the coroutine way where we suspend and then still check if it's completed or not, and only if it's completed we get it and we print the message. Sometimes with Java APIs you can also provide a callback. So for example, if you use the Kafka API to produce something, and that's like a lambda that's executed once it's succeeding, and then we can use a suspended coroutine, which is even nicer, because now we are just checking each time and then having a delay, a check and having a delay. And with suspend function, we can just get the signal from the callback and continue with our computation. That's, well, in the execution time, it will kind of behave the same, but the code behind it is much nicer and much readable than just keep checking and keep delaying. So that's nice if the API offers to have a callback. Yeah, so basically so this is what I said in the diagram. So it's creating the suspended coroutine, and just from the Java thread, it will be completed, and then it will just continue with the computation without having to check each time if the future is resolved already or not. Then the consumer, that's kind of that's the one that was actually giving the issues with the Mendex one. It's pretty Kafka specific, but I kind of recreated it just in Java, just an abstraction with just the problems that it would give. So it's a kind of stateful class that's not thread safe. And then on the consumer, there's a poll method, and you can give it a delay in milliseconds, and then you have kind of the guarantee that it will never block longer than that amount of milliseconds. And of course you can call it with 0, but it's not supposed to be called with poll 0, poll 0, poll 0. So then with coroutines, of course, you can use a delay again, and then call a poll 0, and then it will work. And this might also give problems if you use the default context, because then the computation might continue on another thread, and then since it's not thread safe, that will give you an exception. So that was some of the things here. So I'm just running it now that each consumer just consumes 3 items and then exits. And of course, in a real application with Kafka, you probably start the consumer and then you just want to have it keep consuming for the rest of the application. So then it will keep locking. And you can see in the unsafe, yes. And now it's using the default context, and then it will fill. Yeah, so now you get an exception because it's using the default context, and then it's can end up on another default dispatcher worker, and then you get an exception because it's not thread safe. So this is the diagram with just running it in the main thread. So that of course will take a long time, because then you create a consumer, keep polling till the goal, and then create your other consumer. And of course there's a way around this, but I implemented with the main thread complicated one, but then you have to write quite some code and do some state management to keep check that once each consumer is done. So it's not really nice, and with coroutines the code is much nicer. Yeah, so this is with the coroutines. Then I'm creating the consumers. I'm polling and then delaying. And because I'm using poll with 0, it will never really block. So it will also not block the underlying threads. So that's really nice. But then, of course, thread safety comes into play. So one way to do is use it on a context that just has one thread, because then you're sure you're not walking against thread safety issue. So just using it with the default scope will not work, because then you get the exception that we saw. Now I can show, this is like what happened with the Mendix thing. So I'm starting 13 consumers, but because my on my local I have 12 vCPUs, so the 13th one will be executed later. So you can see from the times, like the last 3 ones, they're all a second behind, because it's first busy with the other ones. So to summarize, coroutine offer more options to make most of your threads, but and most of the times if you have, because this is not even really a complicated thing, because this is just printing out an integer, but especially if you also want to use the results of a suspended function again in another suspended function, then if you would want to do kind of the same with the Java code, you would basically begin to write your own coroutine dispatcher or something like Eric's Java stuff kind of code, which quickly becomes very brittle and hard to read, and coroutines offer much better readability, I think. So be wary of unnecessary blocking. So for example, if you do network stuff, it might be that something is unavailable, and you might want to set a timeout or something to prevent blocking your threads and then kind of halting the whole application without really knowing what's going wrong. And if all else fails, a good old thread pool might be best, but then of course there's the question which thread pool you might want to use, and how you might want to make sure that that's all the threads are closed again. But like in our Mendix case, then it was just a few times that the action would be called. So, and since I also was more confident with thread pools in that case, I think it was a good choice, at least at that time, to go for a thread pool. So thanks. Any questions?
Got one from the chat from Vincent Free. When you explain the consumer pattern, could it be even faster using an event loop?
I'm not sure about the event loop. So it could be.
Yeah. Any other questions, guys? Let me get the mic over.
Yeah, I was wondering, how does it compare to some third-party frameworks? For example, for listening to Kafka, you could also use Spring Kafka. Then you don't have to do the polling yourself.
That's a good question. In our case, we wanted to keep it light, so we don't use Spring. And indeed, I've used Spring. I don't think I used. Yeah, I did use it with Kotlin before. But then without coroutines. But then at least since it's abstracted away by Spring, you don't have any problems with it. I think it's backed up by thread pool. I don't really know what kind of Spring magic happens underneath with the Java consumer from and then into Spring. But at least then you also don't really have this problem.
Any other questions? No? How many minutes do we have left? 15. All right. Gerard, what made you passionate about Kotlin in the first place? What made you fall in love when you saw the language?
Well, to be fair, I'm not really falling in love with Kotlin. Like I also no,
You're exposed.
no, like I think about 5-6 years ago, then I was doing some concurrency things with Java, and I was thinking, God, this is quite hard. And then I came to look at Clojure, which I know it's a Lisp and it's like a long way from Java.
Yeah.
But still, I actually like Kotlin, or I like Clojure more than Kotlin. But I think Kotlin is like a nice alternative, especially since you can just easily combine Java and Kotlin code together. Also, there are things you need to be worried about, but it's much more easier than it would be with Clojure.
Yeah, that makes sense. Anyone in the audience want to share why they fell in love with Kotlin in the first place? No one wants to share. I'll bring the boomstick. Give me a sec. All right. Sorry.
So, given that we have some time, would you care to take us through some of this code? Because you mentioned it several times.
Yeah.
Like this code would be looks a lot nicer than the other code. I would love to see that.
Check. So the main stuff is in the util of the Kotlin code. So here, for instance, there's the kind of suspend on the polling consumer. So then it's keeping a variable for the consumed ones. And then it's doing the poll with 0. And then the delay is configurable from the constants. And those constants are configurable from the CLI parameters. And so for the feature, it's well, if I want to do it concurrently, then I made some. Oh, yeah, my own screen went blank, so I'm not sure. It should have enough power.
I think it's Oracle interfering.
Yeah, I don't know. Yeah. So without the code, that's a bit difficult. But at least, so if I want to do from a single thread, use the consumer one, then in the same thread, I have to really kind of keep track of every consumer that's happening, like especially because there's this abstraction is missing. Yeah, I'm not sure if that helps, since it was already at 80, so I'm not sure that's. Oh, apparently it helps. Yes, so I can see the dirty things I needed to do. Oh wait, that's in the run type. And then this is the complex. And then there's the consumer one. And then it has some messy things here. Yeah, I use several methods to abstract all the ugly code away, but you can get some kind of these. So here you have the run and next, and then it's really yeah, checking if it's already reached its goal or not, and then counting the consumed and stuff like that. So it's all a lot of kind of state management you don't want to write. And then I think I can also Yeah, so this is the with the feature. I'm still waiting while it's not done or not cancelled, and then still delaying. Well, if I have the callback, I can use the suspend coroutine, and like I said, I just get the signal back from the callback to continue. So that's also a bit nicer, I think, than just looping. Any other questions?
Cool. No further questions then. I guess we'll round it off here. We'll be back at 10:30. So head home, head to the canteen, get a little snack. No, don't head home. For the people at home, grab some snacks as well, and we'll be back at 10:30. See you in a bit. All right, and we're back. Welcome back, everyone. Also for you guys at home. Now we're going to have a session with Paulien van Alst about embracing the Kotlin ecosystem at the back end. Enjoy.
Thank you. Welcome, everyone. I'm Paulien van Alst, and I'm going to talk to you about the Kotlin ecosystem. Kotlin nowadays is not only a brand new, or not that brand new, but new JVM language, but it's also a growing ecosystem and with a very active community. So let's have a look. So first a bit about who I am. I'm Paulien van Alst. You can follow me on Twitter under this Twitter handle if you want to. I'm a software engineer at Open Value. We are based here in the Netherlands, but also abroad since a year. We help out companies to develop their software. I'm a co-host at the Barcoding podcast, which can be found under the very confusing Twitter handle coding_bar. Barcoding was already taken. I'm in love with programming. I really love to do that all the time. And I love to talk about it, which has been remarked to Google. So as of a year now, I'm a Google developer expert in Kotlin. So what are we going to talk about today? First of all, I guess I'm preaching to the choir here, but why build a backend in Kotlin? As I said, Kotlin is not only a language, so it's good to remind ourselves why we would even use Kotlin at the backend side, and then see what the upsides are from also using the ecosystem and not only the language. So what are the challenges coming from Java? So here in the crowd, who's started working with Java and then switched to Kotlin? So yes, exactly. So you might recognize those. Where to choose from? Because put yourself in a place that you're not going from Java to Kotlin, but you're in a starting up a new API, a new service at the back end, and that you have all the freedom to take your choices. Not all the companies are are this cooperative, to give you all the freedom, but there might be those situations that's possible. Or imagine you're doing this pet project at home, and maybe it's your new startup company, you know, so you have all the freedom. So you need to think about your application framework, for instance. HTTP libraries, because we're doing a lot of communication through HTTP. Dependency injection, if you want to, you can build application without dependency injection. I know it's surreal, but it's possible. If you want to do it, use dependency injection. There are some libraries that you can choose from. And of course, database libraries. Everything is about data, so databases are important as well. So why build a backend in Kotlin? Well, there are those obvious advantages that you will get from Kotlin, right? Kotlin has been designed for less boilerplate, nil safety, immutability, all those principles. If you're choosing for Kotlin, you're choosing for those. When you're coming from Java, that can feel awkward. But we want those advantages, right? Maybe we want to do some concurrent programming, because we've heard about coroutines, we have this challenge that we're faced to, that we really need that concurrent programming. Lightweight applications. We know that if we're using Spring, it's not always lightweight, right? Spring is very good. It's a very proven standard in the industry, so I will talk about Spring as well today. But sometimes it's good to have lightweight applications still. And that's possible in Kotlin. And using domain-specific languages, that might be a use case that you love them, you want to use them, or you want to use them so you can communicate with your business. I don't know, there are a lot of valuable use cases when you can use DSLs properly and take full advantage of them. And then, what would be then the challenges if you're coming from Java? Well, all those things that you like in Kotlin, that can be challenges if you remain in the Java ecosystem. You've chosen immutability. You don't choose reflection. You've chosen immutability because you like it, but then you're faced to reflection that are using Java frameworks. Proxying classes versus final classes. By default, everything is final in Kotlin. And we maybe want to stay that way. And nil safety. Like we know, everything in Java is by default nullable, so that can feel awkward if you stay in the Java ecosystem, which is a valuable use case, you will still have nullability all over the place, and you need to deal with your nullability all over the place. There are good ways to deal with it, no problem. But maybe if you go out there and discover the ecosystem, you will see that if you're using a Kotlin first library, you won't have to use it. So, where to choose from again? Dependency injection, that's the first one we will approach. Database libraries, HTTP libraries, and application frameworks. So, dependency injection. The first one would be Dagger. I haven't used it in production whatsoever, but Dagger is one that if you Google dependency injection in Kotlin, you will find it. You will also find it, I think it's widely used in the Android world, not so much in the backend side. Second one would be Coin, of course with a K, because it's full Kotlin. And the last one obviously would be Spring, because Spring is market leader there. So Dagger, what is it? Quick introduction. It's coming from Java EE. If you dive into the documentation, you will recognize a lot of the Java EE annotations. It does some code generation during compile time. You have some compile options to optimize that code generation. So much I will talk about Dagger today. Then about Coin. Coin has is building up onto interfaces. That's gives you the opportunity to choose from your implementation strategy depending on some configuration or other settings, where you would want to choose from one implementation of a bean or another. You can organize your code using modules. That means that you can really, compartmentalize and organize your dependencies in such a way. You can therefore also organize your dependency and then choose your implementation strategy depending on the module. So you're in control as a developer, and it knows the scopes, such as single, factory, and scoped that we're used to also with Spring or with Java EE. So some code examples on how it looks like with Coin. For instance, we have a recipe service where we want to access the recipes from a database. We can just declare it in such a way. It's not that obvious that my recipe repository here is a bean or is injected using dependency injection, because I can just use the constructor. But then I can, in my application configuration, create a module where, for instance, here I say I want it to be created at start. There are a few scenarios here that you can choose from. And I choose my repository to be a single scoped bean. And then using a get method, I can just inject it through the recipe service. So here I abstracted away my dependency injection. If I want to call my recipe service, which is using a recipe, which is using my repository, I'm using the by inject syntax to indicate that I'm injecting it here and then using it. So have a look at Spring. It will be, I guess, recognizable. It's annotation based. However, Spring Beans are not final. If you're using Kotlin in a Spring application and someone set it up for you, you won't notice it because there are some Maven dependencies that will do the trick for you, such as the Maven Open plugin. If you don't use that plugin, you can declare your beans to be open, for instance. The main advantage is that Spring is widely adopted, so your Spring beans are pretty well testable. A lot of testing frameworks will help you out with your dependency injection there. So those are some code examples. You can declare, for instance, a recipe handler in this case using an add component, but there are also lots of annotations, such as in the first example, where a lot of magic is done to spin up your application and set up everything properly based on the annotation that it will find throughout the code. As I said, you need to declare it open as it's not allowed to be final. And you have Spring Data, for instance, where you can declare a repository with an interface where you can then do everything, extending a Spring-based interface. So that's about application frameworks, or dependency injection, I'm sorry. So those are the three big players that you will find if you're looking for dependency injection in Kotlin. Then HTTP libraries, there are a few of them. I'm looking at the HTTP libraries that you might want to use when you're implementing your HTTP client in Kotlin. One of them is HTTP 4K. Another is the Ktor HTTP client. Ktor, we'll see it in the application frameworks part, is the application framework developed by JetBrains. And then Spring REST template, of course. So HTTP 4K came from the community. It's very lightweight. It will even allow you to spin up an application if you want to. So I'm not approaching it during the application framework part, but you can implement your HTTP clients, but also your applications with it. It's full Kotlin based. Oh, I'm going the wrong way or not? Oh, I expected a third point, I'm sorry. But it's full Kotlin based, which means that you can use also some Kotlin syntax that you would expect when you're using Kotlin. This is an example from a fetcher where I can just call my client with my request that I just declared above. And then I'm using a lens to serialize my recipe data here. Ktor HTTP client. So the Ktor HTTP client is coming from Ktor, so obviously it will work in your Ktor application. I haven't used it in other application frameworks and then integrated it. Again, it's full Kotlin as well. So there you will have a more, Kotlin-minded again a syntax where, for instance, here I can declare my method to be get with my code block, where I have this check on is success, for instance, where it checks all the response statuses that can be successful, so you don't have to check on a whole list. And there are much more examples when you're going through where it will feel more natural and more fluent if you're implementing your client. And of course, there's the Spring HTTP client, and that is a code fragment that you will actually recognize. It integrates, of course, with the rest of Spring. It has a solid deserialization and serialization of your request responses, and it will just look like this. For my deserialization, I still need to do a .java, of course. No blame there. So that was about HTTP libraries. Now let's have a look at the database libraries. There is Exposed, developed by JetBrains. Of course, they're here to make Kotlin grow in its ecosystem as well. There's Joke, I think you say. I never know how to say it. It's coming from the Java world, and of course there's Spring. Some points of attention though. If you're choosing your database library, you need to see if the query language that it will propose to you, if it's suitable for your needs. Not every database libraries out there are that mature and might not do everything for you that you need to. So investigate it pretty well. Do a proof of concept or challenge yourselves there. And if you're using coroutines, make sure that the library is also supporting that. And of course, your database needs to support it as well, having a reactive driver. So let's have a look at Expose. It's coming from JetBrains, as I said. It has a DSL to write down your queries. It supports a lot of database ILX, mostly in the relational sphere, so Postgres, MySQL, Oracle, and so on. I only use it with Postgres, to be honest. And then let's have a look at what it would look like. You can, for instance, initialize your database like this using Exposed. You connect with Hickory, and then you can use some kind of schema utils that will enable you to create your schema, your tables, and so on. I've chosen not to use that part of Exposed, I'm still using Flyway for my database migrations. But if you're parking, it's just doing a proof of concept is pretty awesome to just set it up like this. And then your database access objects will look like this. And this is where it gets maybe a bit awkward. You need to declare your table. That's the lower part of this piece of code where you declare all your columns and their types. There's some ID, which is an integer here and which is implicit because I'm extending the int ID table interface. And then I need to describe all the rows, how they look there in the table. So let's have a look at a query then. I can, for instance, declare this insert method where I declare my transaction. So my transaction starts at the beginning of the block and will end at the end of the block. And then I will do an insert of my table using the fields as stated here. To retrieve some values, I will do a find here on my DO. I want to find all the rows that are matching the equality here. Joke is coming from the Java world, and it supports Kotlin. But it has no DSL, so it will be more of a chaining of functions to declare your query. And then we have Spring. Spring will be annotation based, like we're used to with Spring, where you can declare your data class with an @table annotation, and then a repository. I think I showed this one already. Fun fact about Spring is that it's supporting coroutines, so it has a coroutine repository where you can retrieve your rows as a flow. Application frameworks then. Well, Ktor, developed by JetBrains, of course. Micronaut and Quarkus, they follow each other. One implements this, the other implements that. Both are supporting Kotlin. GraphQL, you can build your GraphQL application using Kotlin as well. And of course, Spring, well-known Spring. So Ktor, developed by JetBrains, so they will say it's awesome. Well, it is. It's a lightweight. You can do your configuration with DSL. And it can only be used with Kotlin because developed in Kotlin for Kotlin applications. So this is how it would look like. You will have a main function where you can connect to your database, initialize it with your tables and such, and then spin up a server, which is a Netty server in this case, on a port, running on a port. And Ktor will organize itself using modules. And the module will look like this. It's an extension function on the class application, where I can say how I want to serialize, for instance, my input and my output, and configure my endpoints. An endpoint would look like this, where you can declare your route, and then, for instance, a get endpoint, a post, or a put, or whatever you want. It's more of a pipeline there. Micronaut. Micronaut will help you to implement your functions. It runs on Graal VM if you want to. It has a Micronaut CLI where you can initialize your repository if you're starting Greenfield. And it's supporting Kotlin as well. However, the Kotlin code that's generated, this is how it looks like, one of them. And you need to, nullable types and such. It's not how you want it in Kotlin, so you need to change it a bit. This is the code that's generated by the CLI. You need to change it a bit to make it feel more like Kotlin. So don't go blind there. And then there is Spring, of course, where Spring and Webflux, Spring Webhub is going hand in hand very well with Kotlin actually, and where you can use those coroutines pretty well. It's an industry standard, of course, so your teammates won't be shocked too much if you come up with your brand new application with Kotlin. But yeah, we're still having Spring. And it's approaching Kotlin more and more. So don't bash too much on Spring. It's doing a great job there. So this is how it will look like. You will just spin up your application with a main method. Yeah, and I think this piece of code came through it a lot. GraphQL, HTTP 4K, which we saw in the client libraries, has a GraphQL module. But it's not the only one. The Xebia group developed a GraphQL module as well, application framework in Kotlin. Yeah, so that was about the application framework. So to summarize, what have we seen? Lots to choose from. So Kotlin is not only a JVM language. It's here to stay, and it has its ecosystem. Your code bases will change. It will not look like the same as it will in Java. And please embrace the Kotlin ecosystem as a whole. So, welcome all to the Kotlin ecosystem. Are there any questions? Any questions?
Oh, there's a lot of questions. Let's start here.
Oh, you're starting. I'm sorry.
What is your perfect stack? You talk about the different libraries, and if you could start a new project,
Yeah.
what do you choose then? Is it always Spring, or is it
No.
maybe, I don't know?
Yeah, it depends. For GraphQL, we've chosen the Xebia group library, and it was okay-ish. If I would redo it, I will investigate HTTP4K GraphQL. I'm pretty fan of HTTP4K. It's very lightweight and very declarative. It has a very active community where you can ask questions through Slack and even get an answer. So that's pretty awesome. Expose for the database integration, that feels awkward to me. I didn't really get used to how to write my queries. So I've chosen it. Not that proud of that choice. It's not mature enough. So I might use it and then maybe contribute to make it better. Yeah. Any other questions?
Yeah, so you talked about dependency injection frameworks. You named 3. Actually, at our team, when we write AWS lambdas in Kotlin, we just not use dependency injections.
Great. Don't do it.
Yeah.
You don't need it.
But another guy from another team used Dagger, and we were a bit like debating what is best. Because if you have just 4 services with each have a repository, you just instantiate it all from your main handler from your Lambda without any dependency injection. I think that's easier. What do you think?
Yeah, I would say that in a Lambda function you want it to have as lightweight as you want, and your time to live of your application pretty short, I guess. So don't use dependency injection then, I guess. Yeah, I'm a bit afraid if you make your Lambdas too complicated, they become very big Lambdas. So keep it simple. Would be my advice, but I'm not an expert on Lambda development.
Last question. So a lot of hands over here.
No worries.
Sorry, guys at home.
Right. So I'm a big fan of just SQL, and so which of these database libraries works best if I just want to write SQL?
Just SQL.
Yeah.
I have a colleague of mine who would say Joke because he really he knows us from the Java world. So that would be argument to choose it. If your colleagues want to remain in their bubble, and that's fine. It depends how complicated are your queries. Again, when I use Expose and I had to join few tables and select over those tables. I had some hard time to figure out how to do that. Can be also my skills that weren't that good enough. That felt not as easy as I wanted it to be. Yeah. And otherwise, Spring Data is always good. You know, it generates the queries for you. It's not that complicated. But you never know what it generates for you. So again, when your queries become complicated, you don't know what will happen. I like to use my batis, but that's a personal preference. I know that for sure. It works well with Kotlin as well. I haven't mentioned it here, but it works pretty well with Kotlin. That's all you use, I know.
I think that's it for the time that we have in this session. Again, give it up for Paulien.
Thank you all.
If you have any remaining questions, probably tag her on Twitter and she'll be happy to answer it there as well.
No problem.
Cool. So for the people at home, we'll be back at 11. So just a quick 5 minutes. For the audience here, we're going to have 2 sessions next at 11. One here, which is mainly going to be about testing, that sugar sweet rush of Kotlin in your tests. And then on the next stage, the one next door, is mainly going to be about exception handling, specifically with Arrow in Kotlin. and the simplicity there. So yeah, I'd say grab a drink, hit the toilet, and we'll see you in a bit. And we're back. Welcome back, everyone. We're going to start with this session with Mykola Gurov on the sweet, sweet sugar rush of Kotlin in your tests. Enjoy.
Yes, hello everyone. I think most of us do write tests sometimes. And also many of us read tests and maintain tests. And I think we can all agree that it's not always very easy. There is a certain skill and focus, and it's slightly different than the production code, even when we treat this the same way as production code. So the bad thing is that there is no silver bullet, and Kotlin will also not make your test perfect. But the good news is that there are two things. There are features of the language, in our case Kotlin, that can make some things a little bit smoother, a little bit better, and in the grand scheme, it can make a difference. So I would like to talk about why I find Kotlin very nice for particularly writing the tests, even sometimes more interesting for me than the production code, although there are some goodies in production code as well. So who am I? I am Mykola Gurov. I work now as a backend software engineer at iptq. It's an insurance company. We have a hub here in the Hofdorp and also in Zurich. Before that, and we are 100% Kotlin on the backend, which is nice. Before that, I worked at bol.com. This is where my experience with Kotlin started. And this is where, in the first service that we were extracting from a big monolith and decided to write it in Kotlin, I noticed that the tests are starting to get much nicer than I used to. Oh, I messed up my slides, but it doesn't matter because it will be all about the code. And I will switch to the code and we'll start looking at some simple examples. So for this presentation, I made some simple model. Let's say we have some data class, or in Java it would be just class, maybe annotated with Loom book. And we want to do some functionality with it and testing. It's relatively simple, couple of fields. On production, often you will, depending on your domain and use case, you might have much deeper and longer, but that's already good enough. Some payment, some user ID policies, amount and currencies, and we have some simple business logic. Let's say we want to do some sum up of total amounts by payments, and depending on the direction, we will do minus a plus. And we want to test it. Okay, nothing fancy here. How would we test it? If we were doing it very naively, and sometimes we do it at the beginning, we could say something like, okay, I have a test. I want to sum things up. I want to call my method with list of payments. I have 2 payments in this example. And I need to provide all the details for my payments because I have to construct them. And then at the end, I say, assert that the result is as I expect. It's not too dramatic here, but even in this simple, small example, we see that there is lots of noise. That's not important for us. We don't care about user IDs. We know that in the code, but when I'm reading this code, especially in the more complicated scenarios, I don't know whether user ID is important or not here. Maybe it is, maybe not. Is it important that they have the same user ID? So I don't know. Hopefully not. Same policy, amounts, and so on. It's good to have tests that are focused, that are saying this was given, these are the important things, and that's why they matter to us. Of course, we can work this around in various ways. The ultimate solution in Java would be a builder. We could have a test builder, for example, if we don't want to change the defaults in our production code, which is not always a good idea to have test defaults there. We'd have a simple builder which would basically mirror the fields that we have in our main object and provide some simple logic to build it. And then we can just say We have a list of our payments, and there we only deviate for the fields that are interesting to us. And then we have the same test, but much more focused. Builders are good. There are two slight problems with this. First of all, builders sometimes feels a little bit too heavy for simple objects. Second is that it's a little bit noisy. Still, it can be better. It can be more readable. We will look a little about readability a little bit later with DSL and type safe builders. But now I will focus on another option. We could also do the functions. So again, in Java and other languages, when we're testing something, we want to hide some irrelevant details. We'll say we have a function, payment with amount, just one, some big decimal. Internally, we can even use builder if we already have builder, or we can use something else. We can just construct the object with the defaults. That's fine. It can work. The problem is that when we're starting to add more variations, if we want to have, I want, for example, to test in the first example, I was only focusing on the currency, but now I say, well, depending on the direction, we can have different values. So if direction is incoming or outgoing, the payments will be deducted or subtracted. Fine, we could do this in Java with old functions that will either create eventually a maze of different functions with different parameters, with different names that are calling each other, or doing lots of repetitive logic, depending how you do it. Possible, but sometimes difficult to go through. What's nice in Kotlin, and I think those who are working with Kotlin already know this is not a surprise. We have those nice, beautiful functions where we can have variable names, parameter names, and the defaults. And that basically means that at any point I can say, you know what, I don't care about what was here currency in this function that provides us the payment. I will just fall back on default. I will not mention it. I will only mention what's important for my test. Amounts, direction. I can swap the amount in direction if I want, because in some other case, direction might be more important and amount is the secondary, and so on and so forth. And this is already on itself for simple flat objects is a huge benefit for me. So just by this, we had a very nice test suite in some, especially in my case, domain. Well, in some cases, let's not go into the details. There are two shortcomings of the functions for me. The first is when you have nested objects, because you can play a little bit with varargs or parameters, but it might become a little bit messy over the time. And another problem is reusability. It's difficult to reuse the same builder function in different contexts. And I will show the workarounds for that in a second. But before that, I would also like to point out yet another small syntax sugar that Kotlin adds us. It was already mentioned on the first presentation that we had today. It's the extension functions. So in this case, there are many great use for that. But in this case, the original total amount, production code, it was accepting lists, which is good. But for us, that means that if we want to use it as it is, we need to add a little bit of extra noise to our test. List off. We need to say that it's list off. And I'm using the more or less recent Kotlin, so I really like to add commas everywhere, but minor notes, very convenient, especially for Git diffs, very low. Not a big deal, but again, because in the test, especially when they grow, every extra bit of noise, it adds up. It adds to our scanning capability. It distracts us a little bit. It's very good that we can easily say, even without adjusting the original class, you know what, I just want to have a simple conversion from vararg to total amount. And it will be, now I can just pass objects without the unnecessary list. And if I don't have control over the class, maybe it's even a Java class, no problem, I can use it. If I don't want to push it there, because if we have a production code, I want also it to be focused on production use cases. I don't have to push it, I can have it in my test. It can be specific to my test, I can have a testing library. Works nicely. Questions so far on functions? Comments? Bart?
So with the introduction of this extension method, don't you run the risk that you lose the connection between the test and what production code it's actually testing?
Of course, there is a risk, and that's why you want to have it as simple and clean as possible to the original. In this example, you see all we do is minor conversion between one type input to the other. There is no functional, there is no logic or anything. So that's minimal. You might sometimes go a little bit fancier, depending on your situations, but with extension functions, I think probably you want to have it a little bit simpler. But depends. Depends on whether it's clear where the extension function comes. Again, here, because I am not adding anything, I'm using the same name as it was original, so it's total amount here or there. If I were doing some logic, I would be probably more explicit that it's not the original, it's not coming from there. Maybe I would even be it would be more appealing for me, maybe even not to do the extension function, but just a normal function, depending on how we're using it.
Yes, I was wondering why introduce a builder, because I think it quite introduces a maintainability problem in the sense that if you change, for instance, the variable name of your original payment, then your builder method won't change automatically. You have the default arguments with data classes, so why you have an additional builder? What does it add to it?
Well, first of all, in this case, the builder was just an example. Usually, if I go with function, I don't need a builder. I would have maybe in the same function, just with defaults, my data class constructed or something like that. Here, just that you can use it. But yeah, the builders can be useful. Sometimes we will look in a second about that. Okay. Oh, no. Yes.
Do you have experience using copy? So you could
yes.
make one
Thank
happy
you.
flow object.
I wanted this question. Yes. So yes, it's possible also, especially for simple objects, you can have like a template, and instead of pass the parameters to the function, you can start doing copying. Again, more or less, well, the main problem for me was that as soon as you start to want to adjust the nested objects, especially, then it quickly becomes a mess. Well, at least in my experience, maybe you have good experience with that. So that was one reason to look more onto the function, because it can hide it a little bit, and especially to the builders wrapped with DSLs. But yeah, I don't have a compiling. Don't have very strong reason why not to use copies except for that, even though I personally prefer to use just functions with defaults. Okay, so let's go to a little bit more different example. So say I have now slightly more complicated data structure. So I have a policy with some ID, some details, and there is one level of nesting. So we have payments within policy. And that's what I said, that it might be already a little bit messy with functions. I will not be demonstrating how to do this with functions. I will show how to use builders with DSLs to test some functions which we could have, for example, here in some logic, which says whether we should alert on due payment or not. It gets the policy. It starts to go, does some logic, and says whether we should or not. I will focus now on the testing of this bit. So again, if we were just to go the policy as it is, we have lots of extra noise. We might hide it. That's what we might hide some of this noise with the defaults of our data object. But again, those defaults might be not relevant for production code. That's where sometimes I had an issue where I don't want to have a default for production code, for example. I want to have something explicit. but if I have to, then it doesn't work with the test. Okay, we know that's not ideal, can work, but not very nice. Here is a good moment to start using builders, if we have builders. And we could use builders just from the Kotlin code. It says what's important for us, that the activation moment is some instant minus 10 seconds. We have payments, we have one payment with some details, and we have our test. And we have actually the builder here. Nothing really new to us, I guess. What is more interesting is that we can reduce a little bit of the noise of those builders. And that's where this great syntax sugar comes with receivers. How's it called again? I was forgetting. Something with receivers. Type-safe builders of Kotlin. So we can use the builder, even if it's outside of our control, and wrap it with a helper, with extension functions. Or we can extend the builder if it's in our control. And say, as it was demonstrated earlier today on the first presentation, you know what, I want to have the builder, but I don't want to have these details, how I'm building it, that I need to do a build. I just want to pass this adjust math block, which will be within the context of my builder, policy test builder. And it will adjust what it wants. So in the fact, I'm saying, given a policy, and within this block of the adjustment, I say, effectively this activated. So it will be activated of the post policy test builder. I will set this value. I can have the second level of the builder, so I can say I have a payment. In my experience, it was often like third level, some other details, and but I only can only have to put the important things. So I don't need to go to well, the verbosity basically very much decreased in comparison with non-builder way, and if I compare it with the builder, pure Java, it's also. Well, I think there is much less noise because I don't need builds, I don't need to chain methods. It's clear separately from each other. So that helps with the nested, more complicated objects. What is also nice is that it's very much reusable. Okay, this is part of the builder, but because we can use nicety of DSL, we can say, for example, what if I want to have what if I'm running an integration test where I want to have an entity already in my database or in some other store? So I want to say I want to have a persisted policy, and I would like to reuse the same way I'm building my policy. So here it's very easy to reuse the same concept. I can use the same builder. Actually, I don't even need to use a policy. I can just say a policy my policy, I can pass it adjust. Five minutes, good. I can pass it the adjuster. This is tricky thing that you need to get used a little bit. It's well, not complicated, but it's not straightforward. But then this adjuster, it will be working the same way as I was using it for just to give me a plain DTO. But at the end, in this case, I will also save it. So I know that, okay, I got the same object, it's saved in the database. I know that it will be, if I do some test that goes to database with this ID, it will be there. And what is nice here, and that's where it really works much better than copying and with functions. I cannot easily do this because I will need, I cannot have another function. If I have completely another function, like given a persistent policy, then I need to copy all the signature, all the possible variations to the, all the parameters to the new functions and repeat, and this will be growing, so I will be trying to minimize this. Or I need to have to use just wrapping of the functions in my test code. If I'm using copy, that it becomes also even more tricky because with the copy approach, where we're saying that we have data, some template, and then we're saying copy, it's difficult to control where you're copying before something, for example, was saved or after you saved. So that can be tricky with this composition, if you know what I mean. If you don't, you may ask it soon. And we have any questions so far on this, on typeset DSL?
You say that copy is a problem. You said that copy is a problem when you have nested structures, and that's definitely true when you just use bare bone copy. But for instance, if you use optics with arrow, then you really can change a deeply nested structure, and only this one, and arrow takes care of that. Have you also looked at this one, or because it's of course it's a bit more esoteric, but just curious.
Yeah, that's the other side. That's true. I heard about that. I'm not a huge fan of arrow. I mean, I like to play with this, and I know, but I worked in some production code with arrow, and it was too much of a different mental model for me to switch easily. So I would not go for arrow just for that, let me put it this way. If I am in the arrow, yes, it's a different story. But here I'm more, I think, what's also important for me is that I was switching from Java. And I don't want to go, even Paulien said, go all Kotlin. No, I don't want to go all Kotlin. I want to use Spring, I want to use JUnit, I want to use SRG as long as it works, because then the difference between what I already know is smaller. And I can later say, okay, yeah, I want to use arrow maybe, or maybe I want to use Kotlin, as some people are saying, look, this thing would be nicer. Maybe, but I don't have to do this big bang from the very beginning.
Yeah, I like your builder approach to really minimize what you have to give, but I would use a mock in this case and only return in the mock the 3 or 5 parameters I need, and the 50 others for the object.
Okay, now we're getting into very complicated subject of whether it's good to mock much or not mock much, and especially mock DTOs. I prefer not to mock DTO. Well, I prefer to mock as little as possible, but okay, that's already a little bit on the personal choice. You can do it both. But I think mocking DTOs, at least in my experience it was always the most confusing thing that I could ever find, because I expect, especially when I'm changing the code, I change something and suddenly like it returns me something that I didn't expect, because someone said, oh, even though you passed this object, we will just be returning completely different something because it's mocked. Well, yeah, you can probably use it if it's only for this reason, but if it works for you. For me, I don't like mocking details. Okay, our time is up. I will just quickly say that if you have any questions or comments, you can reach me out. And then Gurov, and together with Bart, who will be the next one, so I can steal 1 second from him. We're running friendly tech chats on the YouTube. Watch us, comment us. If you have ideas there, we can also discuss it with you. Thank you.
Give it up for Mykola. All right. Thanks, everyone. We'll be back in 5 with the bad side of Kotlin. Something like that. Ooh,
that was the sweet side.
The sweet side, and now the sour side.
Sour side, yes.
See you in a bit.
Oh, hello. Yes.
And
Excellent.
we're back. Welcome back, everyone. I think some people are still coming in on the back side. To the audience, welcome back as well. I think the camera is looking at Benjamin over there. I don't know why. Hey, man.
It's just not ready for me.
Yeah, the
like,
camera's
nope,
not ready.
nope.
But the screen share should work. So we're going to start off with this session
Yeah.
about the dangerous side of Kotlin.
Yeah!
Spooky. Bart Enkelaar, everyone. Enjoy.
All right. Hello, everyone. How are we liking Kotlin Dev Day so far? Yeah! All right. We're getting some energy here. All right. Let's go. So this is me and my wonderful sons across the eye here. My name is Bart Enkelaar. I work at bol.com. I work there as lead site reliability engineer. You can find me on Twitter, and if you have any questions after this presentation or after you've slept on it, you can always mail me at this email address. And all the slides and the code used in this presentation is on GitHub. You can find it right here. So yeah, I think most people will know what bol.com is. We're the largest online retailing platform in the Netherlands and Belgium. We're part of the Ahold Delhaize group, and we have a wonderful headquarters in Utrecht, where we work with about 2,500, I think, these days. Colleagues ask me next week, it's going to be more. Of which 600, 700 are in doing development on our back-end systems and front-end systems. Yeah, we sell anything from toys to pet stuff and anything else that's not food, because that's what Ahold does. I mean, Albert Heijn does, yeah. And we ship, like, particularly this week, particularly tomorrow, we ship thousands, 100,000 of packages out of our warehouses in Waalwijk, and there are some other locations, but most important ones are in Waalwijk. And you can imagine that that's a really exciting and interesting software landscape to work in, where we have easy 1,500 microservices, all interacting, all with all different kinds of programming languages, architectural models, collaborating, and it's a really fun place to work. So if you're looking for a job, come join us. Yeah, and as I said, tomorrow is Black Friday, so we've got everything's on, I would say high alert, but actually we try to organize it so that we have the most boring Black Friday attack every year. And last couple of years that's worked really surprisingly well. Right, let's talk about rockets. I love talking about rockets. And yesterday morning, 7:20 a.m., me and my son were looking at this wonderful rocket launch of a SpaceX Falcon 9 that was sending the DART mission into outer space, the Double Asteroid Redirect Test. And I really love this mission. I love SpaceX for the awesome innovation that they're doing in the rocket space. But this particular mission it's a NASA mission, and it is going out, and it's really going to try to see if we can do what the dinosaurs failed to do. As in, if an asteroid would be coming for the Earth, can we deflect it in such a way that it just whizzes right on by and we can get to live on instead of what the dinosaurs did. So yeah, I think this is an amazing example of forward thinking, which is something that not always gets enough room in our current society, especially with all the crises that we have right now. There's a tendency to look at the now and stay in the now, and this is one of those particular things that is looking at the future and preparing for it. So I love this mission, and I'm going to be coming back to why it's in any way, shape, or form relevant to my presentation. Besides, of course, that it's awesome. Right, so let's talk about Kotlin. That's why we're here, right? And we have been talking about Kotlin, and we've heard all kinds of awesome stuff about it. So right now, let's talk about dangerous Kotlin. Where you go? Here, there's a dangerous fella over there. So when I say dangerous Kotlin, I of course don't mean like running with the bulls, risking your life, and I also don't mean like hacking and going illegal and stuff like that, because you could probably do that with Kotlin, but please don't, you know. So what I want to talk about when I say the dangerous side of Kotlin, so the dangerous side of Kotlin. What I really mean much more is in the nature of programming languages, because over the last 40, 50 years, programming languages have like successively grown in abstraction and grown in power, and I really think that Kotlin is a really interesting next step when you compare it to something like Java. And if you look at fundamentally what we need from a programming language, so code, Kotlin code, awesome. So fundamentally what we need from a programming language is, I think it's three things, right? It needs to fix our problem for us, which, I mean, that's basic. Any Turing-complete language can do this for you. But then the other thing is that it also needs to be easy to write, because we don't just want to fix our problems, we want to fix our problems fast and efficiently. And then even more vital, because all code gets read like thousands times more than it gets written, is that it should be easy to read. And I really think that in this last aspect, Kotlin has shown itself to be like the superhero of the JVM world, where it has really found this interesting balance between powerful features, but optimizing like the pragmatic use case that keeps it simple and easy to read, mostly. Like, you know, things from Tony Hoare's $1 billion mistake, you know, that they've baked that into the type system. That's absolutely awesome. And things like data classes, but of course Java has that these days, but still it works great. And the operator overloads, there is type aliases, functions as a first-class citizen of the type system, great. And other things like type reifications, extension methods, all kinds of cool, powerful features that give you the ability to make expressive code that is just easier to read. So that's why we love Kotlin, right? But with all these different tools that we get from Kotlin, there comes a risk, because, you know, we had Spider-Man up there, like, with great power comes great responsibility. I mean, it's true. It's a cliche because it's true. And all these different tools might make it hard to select the right one, because the more choices you have, the harder that choice is to make. And that's why Kotlin is better than Scala, because Scala had just too many options. So let's talk about a couple of them and see how they can sometimes hinder more than help. So let's talk about extension functions. By the way, I'm going to be talking about a couple different features, and then I'm going to be wrapping up why I think it's dangerous, and after each one there is room for questions, so I'll throw that in there. So we all know what extension functions are. We've seen them a couple times already in presentations. You can do stuff like, for example, this. If you want to convert a string into a URL, you can do that like, okay, do this as URL, and then you get a URL. But if you do that, maybe somebody else does this somewhere else in your code base. And maybe in a third place in the code base, you have this one, which actually silently swallows malformed URL exceptions. And now you have like the same functionality in 3 URLs, and you might actually, that somebody else calls as URL, well, he's thinking that he's calling to URL, and you get like hidden different types of behavior, all kinds of, over your code base. While what you want is, you want your code to be easier to understand. But now you have duplication. Maybe. So this is a risk from extension functions, and I've even seen a team do this, where you have like a data class, and then basically all methods on that data class are extension functions, and it's like, I guess you get some form of like what you have in JavaScript and TypeScript, that you can only import the methods that you need, but that's probably at least object-oriented wise, that's not an advantage at all, because you want your methods on your object to be highly cohesive with your object. So please don't do this. And right, yeah. So how should you use it? So imagine Mykola did this all the way right just earlier. You have a monetary value, so you want to use a big decimal, and now that big decimal, you want to multiply it, and you can't. But of course, IntelliJ is great, and already suggested, hey, I can fix this for you with an extension operator overload. And then you build that. But now you have this extension function in your code, and I've literally seen this extension function at 5 different locations in the same code base. It's like, okay, so what then should you do? Well, you can, of course, do something like this. You create an inline class that actually encompasses the actual concept that you're trying to model here, and then put your operator overload in that class. And by this way, you have a centralized location for your concept, and you can put all your operator overloads, your methods in that new concept. And now you have a new cohesive object that makes your code easier to understand and lives in only one location. So whenever you're adding extension methods to externally defined types, ask yourself if maybe what you're doing here is turning that type into a different type of concept that would be better served by actually putting that concept in your code. I know there's problems with this implementation. That's right, so extension functions. They are great, but they can introduce duplication, and often do. They can break encapsulation, as in if you do an extension function that overrides a class, you actually have different behavior purely because of an import, if someone else imports that extension function. So that, I mean, that's also like almost Scala implicit like, right? So that could really hide what's going on with the object. So once again, I would like to stress there, a dedicated object is usually better, is often better. And as such, they really can interfere with object-oriented principles. But of course, so when is it great to use extension methods? When you have like a semantic conversion or functionality of an object that is truly only relevant for the context it lives in, then having a private extension function there it makes total sense. Like the default use case is mapping domain entities to DTOs. Then you just want to have a private extension function on your domain entity in your controller or wherever you're doing the conversion. And that makes total sense. Because that really doesn't belong with that object. That belongs with the transport layer. So if you have logic that you semantically want to add to the object, but doesn't belong, but really belongs to the concept you're living in, then it makes sense. But otherwise, maybe a dedicated object could be a better solution. All right, so any questions about this?
How does it introduce duplication where other scenarios don't?
Yeah.
I mean, if
yep.
Basic,
I
think it's off, but
yeah.
If you have
yeah, you're saying if you introduce the money class, then someone else might still do the big decimal or time somewhere else.
As long as you keep your extension method, like if you're doing something in a class,
yeah,
and you want to, and you're introducing a private extension method for something that you would otherwise code manually, and you do something similar in a different class, how is that different from doing it in line in both classes, or making an internal function in both classes? Why would I do it more often when we have extension functions versus when I don't?
Yeah, so you can make all these mistakes with normal functions as well. That's definitely true. It's just that, at least to me, what I've seen in code bases I've worked on is that extension functions, they really give you this capability to turn an external type into something that is slightly different. because it like locally adds this functionality onto the type. And I'm not saying that if you have these duplicated internal functions that you don't have that problem. I'm just saying that if you do this with external extension methods, then you have a clear code smell, I think, that maybe you need to introduce a new object there. So does that make sense? So it really doesn't indeed introduce more duplication than you would with inline function, but actually it makes the problem of the duplication clearer. So maybe that's actually a benefit.
Well,
but
actually, the fact that it's so nice to read, I can actually see the issue, because it's so nice to read that you don't feel the need to make a separate type as quickly.
Exactly. Yeah, so that's also where I'm gonna come back to later. So any other questions? Right.
It is on, right?
Okay.
Yeah.
Just eat it when you say talk into
exactly. let me read this aloud. From Amir Mohamed Vosso, you mentioned you have too many extensions, lookalike functions, which would be confusing. But what's the difference between that and having similar static methods in Java?
Yeah, it's basically the same thing. You can make all these mistakes with normal function.
Yeah.
It's just, I think what you said is very apt, that the seductiveness of its semantic readability makes it more pronounced with extension function.
Cool, thanks.
Cool questions, so thanks. All right, so yeah, certified danger. I forgot to put the stamp on it. There we go. So let's talk about operator overloading. I just showed you an example where I said, oh yeah, this is awesome, you can do it in the type, but it's not, it's one of these things, yes, powerful, but, and here comes the but. So yeah, here I showed you where I think this is pretty cool. It's because doing math with money makes lots of sense. And yeah, that one, yay. But if you're like me, yeah, the story doesn't quite line up with the slides now and then. So if you're like me, then and you really like math, then at some point, because math is the ultimate abstraction of the universe, right? It's in the end you can express everything in math as long as you ignore enough details. And but that tends to push people like me to think about everything as math equations. And there was this project, yeah, so that makes our mental model of things to be math, because all these details that the math ignores, you've internalized them and by default brought them along in your way of thinking. And operator overloading allows you to express this internalization of these details in your code in a way that hides them completely, which might not be a very good idea if somebody else tries to read your code. So let me tell you a little story. I was working on an application that was responsible for all the goods going into our warehouses and out of them, and was trying to figure out what we paid for those goods. It's surprisingly difficult to figure that out, because we get like people send us goods that we never ordered, and goods drop off wagons left and right, and if it's long in the warehouse, then it's actually worth less, so you have to take that off. It's yeah, surprisingly complex. And but eventually we take boxes, we put a price on them, items, and that means we have stock transactions, goods coming in, going out, moving, getting lost, all kinds. And we have price transactions, like we figure out, or we think that we bought this for this offer, or maybe we bought it for this offer, and maybe we have this kind of rebate on this offer if we sell enough. Stuff like that. So we have both stock transactions and price transactions. And then what we want to know in the end is how much is our total stock worth. So these stock transactions and price transactions turn into stock value transactions. And I explained this story while we were working on this to people, new people joining the teams, to other business owners. I explained it many times, and every time, in the end, resulted into me scribbling something along the lines of this. So you have an X amount of stock transactions and you have a Y amount of price transactions, and that turns into an XY amount of delta V. So you have your delta stock, your delta P, and you sort of cross product that and you put that, you end up with a delta V. So this was the way I thought about this. This was my mental model of that problem. So then this was the first application I was using Kotlin in, and I was so excited when I figured out I can express this problem like this. I was like, yeah, this is exactly how I explain it to everyone. This is how we think about it. This is the solution to my problem. So I put it in there, and I was like, yeah, really proud. Like for a week, I was telling everyone about operator overloading. It's like, it's so cool. It makes your code so expressive. And then, like a month later, an ex-colleague from a previous company who was an amazing software engineer joined our team. And he was looking at this code, and I was like, what the hell is going on here? It's like, so, okay, this is a math equation. So A times B is C, right? That's what you expect when you see this. But what was actually going on is this stock transaction list. That was a complex list of complex objects with references, fallbacks, and the price transactions, same things. And some of these were linked, and some were linked to external systems. And this multiplication it wasn't a multiplication operation. It was you link this, and you look up you look for certain identities. You query other systems for possible relevance, you query the database for possible relevance. So there was a world of things happening here. None of that was in this line. So he had no clue what was going on. He's like, can we please rewrite this? And I was like, hi, you make a valid point. So operator overloading. It's great, it's awesome. It can allow you to do math on things that it makes sense to do math on, but not everything makes sense to express as math. It really works well if you have a number that is countable, that you express with a richer type around that, and as such, because otherwise it will surprise your readers of what is going on. And this is what we had earlier about the extension methods. It's just risky for its seductive elegance. You're like, oh yeah, it's so little characters. So, any questions about operator overloading? No? All right, let's go. Yes, I keep forgetting the stamp. Danger. So let's talk about lambdas with receivers. Nicolas showed them, and I think Nicolas as well, because these are your go-to tool for DSLs, I think, in Kotlin. And I think by now everyone knows what lambdas with receiver are. That you execute the context of your lambda within an externally defined object. And this was one of the locations that I used them. This was some test configuration code where it's a pub/sub adapter, and on production the topics and the queues they're created through an externally defined infrastructure configuration system, but locally against an emulator we had to create them, and we wanted to do this idempotent, so we delete them first and then we create them, but if they're not there then the deletion is fine to fail. So that's what this ignoring not found is about. And you know, originally we had like catches in multiple locations. We're like, this is duplication, I want to get rid of this, and I came up with this solution. But there's a particular interesting thing happening here where you have this extension method that receives a lambda with receiver that is then being called on the body of that extension method that it is being called by. So that basically allows us to put this intermediate method between a function called on the pub/sub admin. And the nice thing about this is that it allows IntelliJ to keep up with us, and it does actually do code completion within the ignoring not found block. But to a reader, you have no guarantee that this function that's passed into the ignoring not found is actually being applied to the object that you're calling ignoring not found on. So when I tried to explain this later to, because pretty much everybody else who read this code was like, yeah, I don't understand how it works, but I understand what it does, so never mind. Which, on the one hand, is okay, because at least they understand what it does. But if somebody else would need to change this, yeah, I would probably just delete this and start over. So, because like fundamentally, what this does is it turns Kotlin into JavaScript. And for JavaScript, it's always this joke that I love. And by now, at least I showed this on JFall, and like 5 people came back to me with, oh, it's this tweet. And it's like, am I that bad at Google? But okay, so I actually have which tweet, and there's multiple, but I didn't put it in the presentation yet. So, but yeah, this is my main gripe with lambdas with receiver, and that mostly boils down to that. Yes, it allows your IDE to do proper code completion, but if you need your IDE to tell you what your code can do, I'm not sure if that's good enough. You know, you won't always have the context of your IDE if you're doing a code review on GitHub or GitLab, or you know, it reduces the expressibility of the code itself. So yeah, that's lambdas with receiver. They're great for DSLs, but they obfuscate context scope, as in you have no guarantee on what object the lambda is actually being called. And as such, I saw a presentation of Fränkel once. I'm not going to try his last name, but you know who I'm talking about, right? And he was saying, like, whenever I've written some code and I think, oh yeah, this is smart, then I delete it. And I think pretty much all code that uses lambda with receiver doesn't pass that test, because you can do nice things with it if you think about it hard enough, and maybe that's not a burden that you want to put on the readers of your code. And as such, it turns Kotlin into JavaScript, and nobody wants that. So, certified danger. Any questions about lambdas with receiver? Yeah?
I actually like your example.
Okay, thank you.
So, no, I mean more like, I don't find it a danger in this specific case. I would be okay with that code.
Yeah, but it's, I think, only because they live so next to each other and they're so private. And it only takes one other person adding like a different private function there to maybe lose that connection. And then maybe someone else refactors it into like, oh yeah, I can use it somewhere else. And now suddenly you've lost all that connection. And so I think it's kind of a slippery slope situation. But yeah. Any others? Cool. Then what are we doing for time? Oh, excellent. So, if you're like me, and you were a teen in the 90s, then you definitely saw I don't want to miss one thing, Armageddon, right? And because this is the story of that asteroid impact, of like, oh, size of Texas, 18 days, we have to fix it now, nuke it, which like on different levels is not very realistic, but it was a great movie. And we were all rooting for Liv and Ben, right? Yeah. So, but what they're doing here is they're throwing nukes at it and they're just blowing it up. And yes, nukes are more powerful, but NASA, being the smart people they are, once you apply all that power, you have no clue what the asteroid is going to do. It might break up, and a significant part would actually reach the Earth faster. Maybe all those different smaller impacts will have much more damage. So they figured out, well, if we do like just a kinetic impactor, basically throw a spacecraft at it that doesn't explode, then we have much more control about what happens to the orbit of the asteroid. And we will be much more certain about the positive impact of that change that we're making. And this is basically how I think it ties all together. It's like there are these extremely powerful features that allow you to have big impact. And but impact, asteroid, anyway. But often it's better to choose the simpler system that has a better defined, easier result. And then we can all easily read your code better and have a better future. And that's it. Thanks. So any generic questions, or are we all rooting for lunch?
I guess lunch it is.
Yeah! Thanks.
Cool. Thanks, everyone. Give another hand to Bart Enkelaar. Yeah. So, we're going to have lunch now for the people at home. Enjoy your lunch as well. When we get back, 12:45, there's going to be 2 talks. On the stage next to us, there's going to be interactive development with Kotlin. And on this side, we're going to talk about architecture, or the right architecture that can help you migrate to Kotlin. Make it easier. All right, enjoy.
Er zijn een paar andere features die er eigenlijk bij zouden moeten.
Hey everyone, welcome back. So in this session, we're going to talk about how the right architecture can help you migrate to Kotlin and make it easier in that way with Nico Krijnen. Enjoy, everyone.
Thank you. Welcome, everybody. So I'm going to talk to you about architectures and how those can help you to migrate to Kotlin. And not just architectures, just a lot of techniques in general. So this talks about migrating. And migrating to Kotlin is not about greenfield projects, right? I'm assuming you're coming from typically a Java code base. And to be clear, this talk is intended to inspire you to try out some of these things. It's not by no means the only way, right, to do this. The beauty of code is that there's endless possibilities, so there's always endless opportunities to learn from each other. So if you have other ideas or ways of doing these or helping migrate to Kotlin, come see me after the talk and let's have a chat. Okay. I am Nico Krijnen. I work at Luminous, and there I try to solve complex problems in simple ways. And you may be wondering what gives me the capacity to talk to you about this subject. So over the last years, I've worked on a fairly large code base, 14-year-old legacy code base, Java, and we were actively modernizing that code base, taking it to the cloud, introducing Kotlin, but in general just trying to improve the quality. And in that way I learned a lot of these things, experienced them firsthand, so I thought it's worth sharing that with you guys. So starting with the question, why would you migrate to Kotlin? And this is a topic on its own, so it's really something for another talk. But I still want to see if we can get 2 highlights. So anyone, what would be your top reason to migrate to Kotlin?
Complexity?
Less complexity. That's always a really good reason. Yeah. Other things?
Better defaults for things like nullability and final.
Yeah, defaults for nullability. So I'd say nullability, for me, on its own would be enough reason, to be honest. I mean, the most common error, and don't take my word for it, I mean, these guys, OverOps, did some research on the error data that they have for the apps that they run, and null pointer is definitely at the top of the causes of exceptions there. And we've all seen them, right? So getting rid of this whole class of errors, I mean, that's really, really worth something, worth putting some effort in. So, another reason. What else could you want Kotlin for? Extension functions. You just saw. You have to use them always, but yeah, maybe. I really like them in the right place. Yeah. Okay. So, I say immutability. Immutability is really, really valuable. Most of our apps are concurrent or parallel, have parallelism in there, and like any web app, typically a backend, there is a lot of concurrency there. So when you have that, there's one thing you want to avoid, and that is shared mutable state. And don't take my word for it. Let Kevin Henny convince you. He has an excellent talk. Look it up. It's about this whole problem with shared state and concurrency. So if you have both shared state and your state is mutable, then you're in that like red zone, right? The letters are red for a reason. So that's the place where you don't want to be. You're in trouble. So you can do 2 things. You can either not have concurrency, right? But that's typically not an option. So the other thing you can do is make your state immutable. And Kotlin as a language really helps you with that, right? All the data structures, they are immutable by default. The way you use the language really makes it easy to work with these immutable structures. And that's very different from your Java code base, right? Where everything is mutable by default. So this, I think, is also a really good reason to start using Kotlin and use it in the right way, right? Use it with those immutable structures. Okay, so how hard can it be to rewrite Kotlin, right? There is this nice thing in ID, and we're on a JetBrains conference, so yeah, that's what's in here. So there's this nice convert Java to Kotlin thing there. So is that a good idea? I mean, just a push of a button, right? That's really tempting. So No. It's tempting, but you'll miss out on all the good stuff, right? This converter, it'll convert your Java code, but it'll take all the immutable data with it. So that's not good. You want this. You want to do it the right way. It also keeps all the null stuff in there, right? You have null state with Kotlin, but you have to write it in the right way. If you just convert your Java code, it's going to have nullable types all over the place. So this is not a good idea. So that means you have to rewrite. Oh boy, we have to rewrite. So first think to yourself, what's the effort? Right? What is the effort of doing this rewrite, and what's the business value? Is it wise? Is it even possible? And again, this is not the scope of this talk because that's a subject, a really big subject. But let's talk about, let's say, a simple microservice, right? And depending on who you ask, there's a lot of definitions for microservices out there. But say the definition is it's micro, it's small. You should be able to rewrite it in 1 week. Otherwise, it's not micro enough, right? So if that's the case, then rewriting a service in 1 week to Kotlin, that's totally doable, right? And with all the benefits you'll get, I'd say it's a no-brainer. Just go for it, right? But many code bases, and I'm pretty sure a lot of you have these, they're not small. They're not that micro that you can rewrite them in 1 week. So what do you do then? So you can't neglect the fact that you have to build new features. And if you're building this whole new Kotlin thing, but you're building features in the old one still, you also have to port those features again. You're just making the problem bigger. So this is definitely not the way to go. Instead, what you want to do is take small steps and keep integrating the things you're doing. So you're rewriting you're slicing up a small piece, you're rewriting that to Kotlin, but you keep it integrated with the whole thing, which means you have to use Java and Kotlin next to each other. And that's actually quite good because Kotlin has excellent interop with Java. So we did this in the project we worked on, and it worked really well. Essentially, we rewrote new features in Kotlin, and then we also rewrote everything that we touched when we made bigger changes. So let's talk about the techniques. So these are some of the techniques that helped me out on the project we worked on. And they help me out to make small steps and also improve the code quality and modernize the whole thing. And to be honest, Kotlin there was not the goal, right? It did really help us to clarify the intent of the code, to communicate, because Kotlin is quite expressive. And you may also be wondering, like, reading these techniques, these are not Kotlin specific, right? You can do these things in any other language, like you can do them in Java or in TypeScript or so, and yes, you can, and you should, right? But Kotlin does, on my experience, Kotlin helps you with some of these, and it's a very good fit in a lot of cases. And I'll show you bit by bit. So I want to talk about hexagonal architecture, but before we do that, we have to make a side step. We're going to go into direction of dependency, because this is something you'll have to understand. So let's take a traditional 3-layer architecture. An architecture like this is not about the 3 layers, to be honest. Right? It's about the direction of dependency. It's about making a restriction on where, what kind of dependencies you can introduce. Right? And here it means that a top-level module can only import stuff from the module below it. Right? It can only depend on something from the module below it. And you cannot import something or cannot depend on something from a module above you. Right? That would violate this architecture. The trick, though, is you can control this. But how do you do that? So let's start with this, like just 2 blocks. It's easier. How do you inverse the dependency? So there's a small trick here. What you do is you keep these modules, but in this case, the logic module, instead of importing something like importing your repository and doing stuff with it, you introduce an interface, and you let your repository or the DB module actually implement that interface. And if you do that, which we'll look at in code, is exactly what will happen, right? So this is the first situation. where you have a small service, so this is a piece of logic, and its importing is depending on a database, and in this case, some API that it needs to call. And it's just calling these APIs, right? It's importing them, it's depending on them. It's actually import them from, in this case, what we call an infra package, so an infrastructure package with these things in there. And we want to get rid of those imports, right? In our business logic, we don't want to have these imports. So we create two interfaces that describe the needs that we have from the outside world. And then on the DB side, on this repository and in this in this SMS service, we implement those interfaces. And as you can see now, the imports are the other way around, right? Our database and our SMS module, they depend on this piece of logic and not the other way around. Okay, so maybe a lot of you already know this trick, but I think it's good to recap just so you're on the same page. So hexagonal. This is also called ports and adapters, or sometimes people call it onion architecture. The naming has some nuances, so it's not exactly the same, but the idea is very similar. And you often see these in combination with domain-driven design concepts. And this diagram is actually a really good diagram of hexagonal architecture, but if you don't know the concepts, it really seems a bit daunting, right? There's all these blocks and things and stuff going on. It looks really complex. The nice thing about it, it's actually not that complex. The real core idea here is really simple. The core idea of hexagonal and onion architecture is you have an inside and you have an outside. And this inside part is where your business logic lives, and the outside world is all the communication with the rest of the world. So your API, your database, your third-party services, all that stuff that you need to communicate with, that's on the outside. And then with hexagonal, the dependencies, which we just talked about, can only go inwards. So your domain model never, like your business logic model, that's part that never has any dependencies on any of these other things. Which probably means that in some places you'll have to use this interface trick, right, to make the dependency go the other way around. That also means your inside, your business logic, it doesn't need to be aware of your web technology, it doesn't need to be aware of your framework, right? It's just pure code, pure code. And that's quite powerful, which we'll see later on. So there's quite some benefits here. So you get more, it's more modular, there's a lot more separation. It allows you to swap implementations of these outside things quite easily. So if you upgrade to a new version of your framework or a new version of your database, you can just create a new implementation for it, and when you're ready, you swap them out, and you're using the new one. And your business logic, if you do it right, doesn't need to change at all. There are some trade-offs, though. So it means that you have to create those abstractions, right? You have to create these interfaces, and it's often quite hard to not leak details of the specific database you're talking to in this abstraction. And obviously, if it's leaking those details, it's harder to swap it out later on. So that can be quite an investment upfront for something you may not ever swap at any time, right? So think about, is it worth it? Do you need, how likely is it that this piece of code is going to change? And do you want to make that investment to make it easy to change later on? Don't add complexity like these abstractions if you don't need them, right? I'll come back to this later on as well. But apart from swapping swapping dependencies, you can also have some other benefits here. So the inside part, which probably should be the most important part of your code base, right? That's really where the code lives that makes your app unique, makes it the app, well, be the app that it is. That part with hexagonal has no dependencies on anything. And that means that part can really focus on the problem you're trying to solve. And it also means that it's really easy to test, that it's really easy to change, and also because it's so isolated, it's really easy to reason about. And all those things help to keep it maintainable, etc. So then how does this architecture help you migrate to Kotlin? And I think the most important part is that this really important part of your code, this logic part, right? This business logic, that is isolated with hexagonal, which means you can test it on its own, and you can write just that part in Kotlin, right? Without affecting much of the other stuff. If you already have this architecture, then that's the most important part, the part where you probably going to make the most changes. So if you rewrite that, you're going to have most value of rewriting it. The rest can all remain just Java, your existing framework, until you're ready to change it, right? Each adapter, so these outside blocks, they're called adapters in hexagonal. Each of those, they can live in their own module. So that means you can swap them to Kotlin, each in their own term, when you're ready for them, right? And I think all this isolation, all this modularity really helps you to do this big rewrite in small steps. So how do you start with something like hexagonal? So this whole thing, this picture you saw at the beginning is quite daunting, right? There's all these things out there. Do you really want to start doing that straight away? I'd say where you really want to start, where the real value is separating that inside and that outside, right? So you create a module or a package for your domain model. You create a module or package for your infra code, like all these outside pieces, and you separate these. You make sure that the dependencies can't go the wrong way by making them two separate modules, and that's already going to give you a lot of value and force you in the right direction. And then once you get used to how that works, then start looking into other stuff about hexagonal and introduce the other concepts as well, bit by bit. So just the inside-outside separation, that's a really great start and it's going to give you a lot of value straight away. Okay, next technique. Vertical slice architecture. And in my experience, this might even be more useful than hexagonal. So back to our traditional three-layer architecture. So vertical slice is pretty much what the name suggests. You take vertical slices over these layers, and you create a slice for every feature in your system. And instead of the usual approach where you have controllers in your API level, and you have some components in your logic and some repos in your DB layer, and they're all like all the repos are in one place and all the controllers are in one place. In this case, all the code for a feature, like your controller, your logic, your DB model, they're all in like a package for that feature. And so you keep essentially the code for all the layers together for that one feature. And that allows each feature, in theory, to have its own architecture. Right? So depending on the simplicity or the complexity of a feature, you can choose an architecture that fits that complexity, that level of complexity, or just keep it really simple. And then you may ask, okay, is it really wise to mix architectures in one system? And I'd say that depends. Consistency in a system is quite important, so I actually wouldn't do this typically. Right? It really depends on how different the features in your system are. Are they really that different that you need this? Just don't mix an architecture in just because you can, right? Don't do that. But it does bring us to more sort of benefits of this architecture. So you get real clear separation, again, of separation of features in this case. And that means that code that naturally belongs together actually is really close together in your code base as well. And that's something we call cohesion. And you may have heard of something related to that, which is low coupling, which is also something you get from this approach. And those things are both good. You have to look it up, but yeah, trust me, they're good. So right, different features don't depend on each other if you do this right. So you hear it depend. This is all about managing dependencies like we saw earlier, right? And a lot of things in software are about managing dependencies. Having each feature isolated from the rest means you can keep the complexity of each individual feature to a minimum. And I'm all about minimizing complexity, so that's a good thing. And it also means you can evolve every feature on its own pace. Right? If one feature is very actively developed and it's growing very rapidly, and to change this architecture, go ahead. If the other features stay behind and you have just some simple CRUD stuff there, it's fine. Just keep them like that. And also means you can introduce more advanced techniques like hexagonal when you need them for that feature and not for the whole system at once. So you can probably see where this is going. So this makes it easy to keep an overview of a feature, right? Because the code is close together, you can see it. It means it's easier to refactor because you can see which pieces touch which other pieces. You can understand where things are being used. And then, obviously, most important, it allows you to take small steps, right? Because everything is isolated from the other parts, and you really minimize the blast radius of the changes you're doing. So this all gives you great confidence to change one slice of your system without breaking any other part, right? And this is really a thing that in big code bases is often something that people fear, right? If I change this thing, what else is going to break somewhere on the other side of this application? And this isolation really helps you prevent that problem. And if you're working on a monolith, this helps you make it more modular. And in turn, if you really need to, you can probably quite easily extract one of these features into its own microservice if you ever see a need for that. So apart from those benefits, which is all good stuff, right? So how does this help you migrate to Kotlin? So having each feature isolated means you can introduce Kotlin to each in turn. And the isolation, again, allows you to use new architectures like hexagonal, one feature at a time. And all these things allow you to take small steps. So next, this is not really an architecture, but it's a technique very valuable. It's called value objects. And you can use this in any type language like Java or Kotlin or TypeScript. So looking at a simple class, what if someone would change the constructor parameter order here? What if they would do this? Well, actually, if they use IntelliJ, and there's a really nice refactor signature tool, it's the best out there. I don't think a lot of people know that or use it. That's really good one. If you use that one, you're all safe. It's no problem. But if you don't, and someone makes this change, then probably all over the place it's going to be IDs passed in as names or names as IDs, and you're going to have very subtle bugs that are really hard to find, and oh man, you don't want those. So what instead? We introduce types, right? You have a type for each value that you have. So instead of using a string or another primitive, you actually wrap that value with a small class, really small, that represents their meaning. And these strong types make it really hard to make mistakes, right? I mean, there's no way if you swap them that your compiler is actually going to complain. You can't compile the code until you fix all the swap places where it was used. So if you don't do this right, you also add a little bit of validation, because typically these value objects they have is not just a string, right? It's a product name, and product name shouldn't be empty, for example. So you add a little bit of validation, and if you do this right, you never have to worry about validating these values anywhere else, right? Instead of having this string and having to know, is this being validated before? Can I use it safely? I don't know. No, you know, when it was constructed, it was validated, and wherever you are now in your code, you can use it. It's safe. Another thing about value objects, they are always immutable. So we already knew why that's good, right? And then a tip from a really great programmer I worked with, Martijn Piets. He said, why don't we handle this translation really on the outer edges of our system? And I'm not talking about like outside of the core in this DB stuff, no, outside of that even, right? So let's look at the JSON serialization we have in our API and in our DB layer. And let's add some serializers that understand these value objects. And then whenever a value comes in, it just translates it from the raw JSON into the value object. And we just use in the controller, we use our value objects. So it means everywhere in our code base, we're only using these value objects. There's no strings anywhere. And it means that the validation is all done on the outside layer, so you can know that it's valid. It also means the translation is only done once, when it enters your system, right? Or when it leaves the system. So you never have to do that conversion all over the place. And I think all these things, they really give you a lot of confidence about what values you're talking about and that they're valid. So how does this help migrate to Kotlin? I mean, this is nice, all this stuff, but we're talking about Kotlin here. Value objects in Kotlin are really easy. It's just a few lines of code typically, and you have a value object. And there's even some stuff recently released that makes it even easier. And again, as I said before, these things you can introduce them really in small steps, right? You can take one place where you have one specific value, and you can change it to that value object, like in the middle of your code, and then you can work your way outwards in small PRs to introduce it in other places until you reach that outer layer, and then that value object's all over your code base. And then you go for the next value object. And you only do this, you don't like introduce all the values objects throughout your whole system at once, right? You do this whenever you create a new feature, or whenever you touch a little piece of code and you think, okay, this really could use a value object here, then you introduce it, right? So you take these small steps. So next technique, encapsulation. So it feels a bit like we're reinventing the wheel in software engineering every few decades. And I think encapsulation is one of these really undervalued techniques. In essence, it comes down to preventing others from using the inner details of your class or your module. And if a user of your code wants to know something, they have to ask you. And you, with your own data, will figure out the answer and give them the answer, but they're not allowed to get to your internals. And the more specific the questions are that are asked from your code, the better. And we'll see why. So let's look at some code. So take the money from example from earlier. What if we expose the inner values or create getters? The raw values will be used, right? Someone will write some code and will do their own calculation with these raw values, and well, what could go wrong? The problem here is that the raw values will be used in a lot of different places. Maybe the same calculation is done in different places, but in different ways. And if you want to change or make a fix, then you have to find all the places, hope you find all of them, and then make sure they're all consistent again. So this is really hard. It makes your code really hard to change. So what if instead you keep the data to yourself, right? What if instead the code has to ask you a question and you give it the answer, right? Then you don't have to expose these internals. You make them private, and you force yourself to solve the problem in the right place. And then what is the right place? That's always something you have to figure out. So always ask yourself some questions. So what question should be asked of an object? Right? Think about that. And then also think, should that object be the one to answer? Right? Does it have the data needed to answer that question? If it's not the owner of the data, then probably you should delegate it to the part that does have ownership of the data. So doing this properly really gives you a lot of benefits. Again, it limits the blast radius because all this stuff is private. You can change it freely. As long as you can answer the same questions, you can change whatever you want. It also allows you to take small steps, right? You have, if you do it right, you create all these small bits of encapsulated code all over your code base. Like following this sort of good old OO principle, the result is that you have like nuggets of encapsulated code all over your code base. A bit like chocolate chips in a cookie. And these characteristics make it really easy to migrate all these small pieces to Kotlin. What we actually did is we introduced a lot of these encapsulated behaviors as Kotlin code, and then we started using them in the rest of the code base. And actually, while writing this new code, we typically did it, as I said, in Kotlin. We also used TDD there to make sure the behavior is correct. And we also did it as pair programming to make sure that we really think about these things correctly. So paying attention to those, and then after the base objects are created, then we introduce them in all the code base in small bits. Okay, to close off, some tips around testing. Having a good test suite is really a big enabler for being able to make small changes. And it also means that you have to have good tests. But what are good tests? So a good test suite gives you confidence that you don't break anything, right? And it gives you that confidence in a timely fashion. So if you find some of these things, and I'll go through them, you have to be ruthless to them. You have to throw them overboard, kick them out, right? Because these things are unacceptable. So flaky tests, they're just noise. Like this test that randomly fails every now and then. You never know, like, did my build fail or not? I was just this random test again. I'll just rerun the build. No, don't rerun the build. Ignore the test for now and create a story on the next sprint to fix it, right? But you disable it straight away because it's just noise. It's getting in the way of you making progress. The other one, slow tests. Having fast feedback is really important if you want to take small steps. So make sure you run your tests in parallel. Spin up multiple environments. We have the cloud now, right? We can spin up a new environment for every commit and have it run the integration tests, and another commit can spin up another environment. You don't have to wait, right? There's no limited capacity. Just go. And these things really help you to not have this sort of slow test hold you down. Bad isolation. Right, one test influencing the other, often seen in combination with flaky tests. So these are just horrible, right? It's really hard to figure out, okay, did my test fail because it's failing, or did another, or it failed because the other test changed some data? So doing this parallel stuff, right, running tests in parallel, is really hard if the tests are influencing each other. So really make sure you isolate your test data and your tests. Create a separate tenant for every test if you can. Make it that tenant creation really cheap so you can do it for every test again and again, those kind of things, right? Or just have proper unit tests, usually pretty fast and isolated. A test with no assertions. Have you seen those? I have, sadly. So when do these pop up? Well, typically when you have someone that introduces code coverage metrics and they think it's really important, right? And then people start writing code so that the code coverage goes up. But you can do that without doing assertions, right? You just execute the path and it'll up your coverage. So that's where I saw these things. But do they add value? No, because they don't tell you when it breaks. So what can you do with these? Exactly, one button, delete. So delete them, just forget about them. If you want that piece covered, just write them again. And then tests that are testing the implementation details of your class. The purpose of tests is to make your code easier to change, right? To make sure that you don't break existing behavior. If your test looks or knows too much about the inner workings of your code, it means you can't change the inner workings of your code, right? Which means you can't change your code. So a test that knows too much is holding you back from what it's supposed to do. So that's really bad, but a lot of tests are written that way. So really be conscious about it. Make sure that your test just looks at the outside interface of your module, and that's the part that it tests, right? That's the part that it talks to. And the inside part should be changeable without the test breaking. So how does Kotlin help with test? And we already saw a nice talk about this. So new code, as you've seen, you can write in Kotlin, you do TDD, you write a nice isolated domain model, use pair programming, all those kind of things, right? And that gives you really good tests typically. And test code, just like production code, should really be very readable. Again, this also came back in the previous talk, right? So don't treat it as, oh, it's just test code. No, test code really has to be readable because it's essentially explaining what your system is supposed to do. And you're going to be really nice to your coworkers and your future self if you make sure that 1 year from now you can still understand what your system is doing, because I'm sure you will have forgotten all the details. So, and in this case, Kotlin really helps with the expressiveness, right? Kotlin is a really expressive language, and as you can see, you can use all sorts of nice things to make your test code really readable. And I think really Kotlin shines in that compared to something like Java. So writing new tests, just go for Kotlin straight away. It's like a no-brainer. And then you can use some DSL stuff there to make it nicer. I say don't take it too far, but a small DSL really helps you express the scenarios. that you're testing for your features. And look into BDD, right? That's all about scenarios and readable stuff, etc. But these DSLs can really bring you a long way there. And the result is extremely readable tests. So let's see. No, I'm not showing code because we don't have time for that. You saw some code in the last talk, because that's really a topic on its own. So what if you have old tests, like an old Java test suite that's testing your API or whatever? You know, it's a real big, slow chunk. Don't throw it away. It's really valuable, especially if it's testing like the outer edges, the API or your facade. It's going to help you, in not breaking existing behavior, right? So don't touch them. Don't rewrite them to Kotlin. Just keep them the way they are. They're testing what you, so that you know that your code's not breaking anything. And then rewrite your core to Kotlin with confidence. And what if you have no tests? Yeah, that happens too often. So yeah, it's a bit cheesy. I can't make a nicer start writing tests. That's the only thing you can do. There's a really good book, actually a well-known book from Michael Feathers. It's called Working Effectively with Legacy Code. And he says legacy code is code without tests. That's his definition. So his advice, again, is just build up tests, start building up tests, build up your confidence, and then start changing your code. But that leads to a nasty paradox. Because as you all know, if you have untested code and you want to write tests for it, you're going to have to change the code. Because untested code is not easy to test, typically. So you can't change the code, because you first have to create tests, but to change the test, or create a test, you have to change the code. So, oh man. But, I mean, luckily we're not the only ones out there with legacy code. There's more people with advice on this. There's a good ebook from Nicolas Carlo. He summarized a lot of advice and techniques on how to change legacy code safely. So definitely look this up, and it's really going to help you out. So recap, we have a number of techniques that help you migrate to Kotlin. And you may be wondering, well, this is not limited to Kotlin. These things can work in any OO language, and that's true. And you should use them. You should use them already in your Java code base, so it makes it easy to migrate to Kotlin later on, right? So these things are really techniques that help you make big changes, like migrating to Kotlin, but make them in small steps. And Kotlin helps you with these techniques, because these techniques are easier when you use Kotlin. And as you may have noticed, there's a recurring theme here, and that's what I'll end with. Take small steps. Thanks. Do we have time for questions? 2 minutes, cool. Any questions?
Yeah, just I guess a question for clarification. The value objects that you mentioned, where should I define those? From what I understand, you meant that they should be part of your domain model, or at least the physical classes that represent it, and then you need that to combine that with the sort of the dependency inversion that you discussed before, so that all of your outer layers can look at them and use that same type. Is that what you meant, or?
Not necessarily. So you don't. The two concepts are separate from each other. You can use value objects without doing hexagonal at all, or you can use value objects. You just put them somewhere where your code can access them, and you're fine. So if you can make a library module out of it. I just put them somewhere. Like if you have this centralized domain, that's a good place to put them, right? Because that's accessible by all of your code base. But yeah, if you need a value object that's just used in a controller, then just put it there, right? Limit the place where it's being accessed, make the scope small as possible. And yeah, that's a good place to put that one. But usually the domain is the place where you put them.
I think that's it then.
Cool.
Thanks, Nico. Thanks a lot. Give it up for Nico once more. Cool. We'll be back in 5 again. For the people in the chat, I saw some questions. I'm going to give you the tablet to Nico, so maybe you can answer those as well. And then we'll see you in 5 again. Cool. Cool, and we're back. So the physical audience is still getting inside, and when I started talking, people actually realized we're going to start with this session with Urs Peter and some early access project Loom versus Kotlin Coroutines. I love a good versus. So have fun, everyone, and enjoy. Questions will be at the end. There'll be plenty of time for that. Go ahead, man.
Cool, excellent. Thank you. Welcome, everyone. Nice to see you from this place, which I haven't had for years. My name is Urs Peter. I call myself a senior software engineer, as you can see, based on my gray hair. I started out with Java, moved on to Scala, and for about 4 years I'm programming exclusively in Kotlin when it comes to backend logic. Besides that, I'm also a, dare to say, passionate trainer. I love to spread the word about Kotlin. And since the beginning of this year, I may call myself a certified JetBrains Kotlin trainer. Okay, it's very nice to meet you, and I would like to take the opportunity to get to know a bit more about your knowledge about this subject. So, first of all, who of you have worked, and with work I mean a bit kind of serious, not only playing around, worked with threads, low-level threads, wait, notify, latches, semaphores, and so on? Okay, not many. Check. Who have worked with reactive toolkits like Reactor, Webflux, RxJava? A little bit more as I can see, but also not still very many. And last, who has worked with coroutines? More or less about the same, about 1/3 I guess. Okay, so I think for the ones that are new to coroutines, let's start out with them because they give us the baseline to actually move to Loom and understand what Loom is offering. And we're not only looking at syntax and the like, but most of all we're looking what kind of problem do coroutines solve. And we go step by step, starting out with an example that really has nothing to do with coroutines. It kind of helps you to make yourself familiar with it because I will use it throughout the presentation, this exact sample in various variations. So what we do here is quite a simple thing. We eventually save a user in a database, and before that we fetch a random avatar, we verify an email, which are all remote network calls. And also, of course, the save action in database will be a remote call. So far, so good. You might think, okay, what's the big deal about that? And like this lazy guy thinking, yeah, why should I ever learn something new? Or something else, because it kind of works. It depicts really the intent of what I want to express. There's no additional abstraction involved, so we're fine to go. The problem arises when you set load on a system like that. In order to understand what's really happening, let's quickly go through this kind of architecture. This is a typical architecture with a Tomcat Chatty container where you have normally a thread pool with about 200 to 300 threads. Whenever a request comes in, a thread is taken from the pool to handle a request. Whenever the thread hits an I/O boundary, the thread blocks, so it doesn't do something else. Once the reply is received, again it does a network call, it blocks. And that's how the things work. And then the request eventually has been processed. So what happens if, for instance, this resource becomes slow? So this remote web service, all of a sudden, because of various reasons, doesn't reply in a timely manner. Then it can happen quite quickly, as we also heard in other presentations, that your thread pool gets exhausted. And when your thread pool gets exhausted, what happens then is that you cannot take on your requests, leading to very dissatisfied users leaving your site, go to your competition, which you really don't want. Besides that, we also can not really leverage parallelism in this programming paradigm, which could also give us some additional speed in case your use case is suitable for parallelism. Okay, so far so good. This problem has kind of been realized quite some time ago, about 10 years, I guess, by now, where they introduced reactive programming to actually solve this problem. So the code that would be rewritten using a reactive toolkit, in this case, Webflux, you might know from Spring, would look like that. So let's look at how this model works. So instead of having a thread pool with 200 threads, we now have a thread pool with only about 1 thread per core. So if you have a quad-core machine, you got 4 threads. So the question is, how can this system be so much faster and better than the example where we had 200 threads? So we get less threads and more speed. How come? Quite simple. So whenever you get a request, a thread is taken from the pool. But when the thread hits an I/O boundary, it doesn't block, it doesn't wait. It just offloads the payload to the network layer, and continues doing something else. So these 4 threads are continuously spinning, spinning, spinning. Whenever you get a reply, callback, then another thread, or the same, doesn't really matter, one of these 4 threads will pick up the work, do something else, hits an I/O boundary when we save it to the database, and the same happens with the reply of the database. The same or another thread will eventually return the response. So if this resource becomes slow, like in the previous case, what is happening? Not much, because the threads do not block, so they can continuously keep on your work. So in that sense, we stay responsive. We maybe cannot serve a decent answer to the user, but we can serve an answer to the user, maybe it takes a bit longer. We are not unresponsive. Besides that, these kind of programming models also leverage parallelism. So if you have this business case where parallelism is a good match, then we also can use that and speed up our request handling. So we definitely end up with quite some happy users using this model. So far, so good. So as we've seen, this is the code you have to write, and if everything would be fine and dandy, we could stop now, go home, and go to another session. But apparently, there is a caveat, right? So what you have to do in order to achieve what we just seen before is that you have to introduce some abstraction. And not only an abstraction that is in one corner of your code base, it's an abstraction that will dominate your whole code base. And that's logical because these abstractions are libraries, and libraries only come with abstractions. It's no language feature. So this is the kind of buy-in we do when we embrace this kind of model. And this has quite some limiting aspects. So first of all, as you can see, we are all of a sudden dealing with SAP flat map do finally. Normally you have a try finally, right? All of a sudden we have a do finally, so why is it needed? Because normal language constructs like if, else, throwing exceptions and so on simply don't work with this model. Which resulted in these reactive toolkits kind of re-implementing these kind of low-level semantics. And the problem is, one toolkit is not the other, so if you choose another one, you actually relearn the whole thing. Besides, and I think this is really the worst of all, your business intent is really getting lost. So what is happening in this code, which is relevant for your business, for your boss in that sense, you really have to figure out what's going on. There is some, oh yeah, here I see there is, oh yeah, there is the random avatar, the verify, and then, oh yeah, here to save the user. So you really have to pick out what's relevant for your code. And for maintainability, that's a big issue. And even worse, it is really easy to shoot yourself in the foot with these models because there's so many things you have to be aware of. You can quite easily block things, but then your performance will even degrade, even though you had the goal to actually improve performance. So these are the issues when you use reactive toolkits. And we shouldn't forget one thing, which is quite important to know. Why did we all do that? And I just changed the resolution of my slide to something else and back, but apparently the revert didn't work very well. But what I want to say here, which is very relevant, why did we do all this? For actually 2 reasons. 2 reasons, maybe a third, but for now 2. Only because we wanted non-blocking I/O and a little bit of parallelism. Because we wanted these 2 things, we sold our soul to this framework, letting us dominate and pollute our whole application framework. So, as a summary, reactive toolkits, they solve the problem with better resources, responsiveness, resilience, and so on, but they come at a very high price. So in other words, accidental complexity. And of course the question is there a better answer? And yes, there is a better answer. And guess what? These are coroutines. That's actually the pill that should help you answering this problem in a way effective way. So now we're actually at the stage where you can look at coroutines and you probably see that the benefit they give based on what kind of burden you have if you choose reactive toolkit. Which you don't see if you start right away with coroutines, right? Because then you think, okay, you need this contrast, I guess, to understand their value. So the code we have here, as you can see, looks a bit more like the code we had in the beginning, right? The blocking code of the sleeping programmer, which is very evident, which is, again, pure in my eyes, because it depicts what's really relevant. We have normal method signatures, no additional abstraction involved. And this is how you would call this code. So I think this code your boss could read and understand. And that's always a perfect sign that apparently it's code that is maintainable. Besides that, we also can use something like async and await, which allows us to kind of in parallel set out two tasks. Here, random avatar, verify email, concurrently, in parallel. And then continue working once these calls have returned value. So this is actually what coroutines give us. Coroutines allow us to express logic sequentially. And now comes the really cool thing about coroutines, is that the asynchrony is figured out by Kotlin itself. That's quite amazing, because you think now this stuff is blocking. It's not. It's nicely asynchronously executed. So you get some sort of best of both worlds. You write simple signatures, but underneath it behaves as effective as you would have reactive code. Of course, you won't get all this for totally free, right? So there are some things you have to know about, and we will look at them, that you also maybe take home some knowledge about coroutines as an addition as what we heard this morning about coroutines. So we heard probably about, seen these suspend functions. We will look at them in a minute. But first of all, what are coroutines? What's also a bit explained. I think it's good to also see them in contrast with, first of all, processes. On a operating system, we have processes like the Java process when you start up an application. Don't have many of them. Then you normally have kernel threads. So these are the threads that really get a time slice of the CPU and then execute something on it. And on top, you would have coroutines. And coroutines are lightweight threads. So you can have 2.4 million per gigabyte, whereas in the threading case, you can have about 4,000 per gigabyte memory. So it's quite significant. And a coroutine in that sense needs to be executed by a thread. On the GVM, we only have threads. So eventually, a thread needs to do the work. But it's not pinned to a thread. So also within the life cycle of a coroutine, several threads can take part. A bit like the reactive example I explained a minute ago. So now let's actually move from threads to coroutine and then kind of figure out what kind of benefits we have. So this is a simple example where we use the thread builder of Kotlin. It's a nice builder that actually does new thread runnable in.start. That's what you get when you call thread. And here we do a kind of bad thing. We do sleep. And as you might know, sleep isn't that great because it blocks. And whenever a thread is blocked, it can do something else. And it's an expensive resource, so we wasted a resource for 1 second. This is what we do here in action. The coroutine example looks more or less like that. First of all, you cannot create coroutine just as you create threads. So there is no new coroutine and then you have a coroutine. You need a builder for that. In the example we use here, we use run blocking. That's the builder we use. And as you maybe might guess, there is the word blocking in it, right? And maybe this is kind of hint of telling you, hey, are you aware you're blocking, man? So in that sense, don't use this in production code. These snippets are here because you can run them in the main method, and then it works. But in production codes, don't use them. Really don't. Because I know many people do. That's why I say it. There's always another way around it. But okay, for these snippets, we need to start somewhere, and run blocking kind of bridges the thread world with the coroutine world. And there are better ways to do that, but then it wouldn't run in the main method. So we have this builder. From this builder, we actually now launch a coroutine. And launch is really the same thing like a thread. It's some sort of spins up an asynchronous process. This is what's happening here. And then we encounter actually the first beautiful thing about coroutines, which is delay. And delay doesn't block, but delay suspends and resumes. Which means that when delay is called, the coroutine handling this code is kind of parked. And then after 1 second, something is scheduled. After the second has passed, it will resume and continues working. So, what is the difference between these two snippets? What we do here is we create 1 million threads and we create 1 million coroutines. And if you paid close attention, if the lunch tip hasn't been too heavy on you, I think you can imagine what happens, but I really want to show you because I think it's good to see. So here we have the example with the many threads. We create 1 million threads. let's run it. Ready to roll, and boom, we get out of memory. That's not very surprising because I have 2 GB of memory, 4,000 threads fit in 1 GB of memory, so after 8,000 threads, this whole thing blows to pieces. Then let's look at the Coroutine example, that's this one. And I made it a bit more fancy with nice counters and so on, that we see what is more or less going on. So 1 million has been created quite quickly, and after 3 seconds, so then they wait all 2 seconds, and after 3 seconds this whole thing has been processed. Nothing has blown, as if just nothing has happened. It processed a million asynchronous, it spun a million asynchronous processes that did what they did. So in other words, this blows quite quickly, and this just continues spinning. Let's take a closer look at suspend functions, because I think it helps to understand how this whole thing is working. Whenever you mark a method with suspend, what you actually do is you give this method a capability to be suspended and resumed at a later time. This is actually the capability you gain. When you look what is compiled, is the code you see here. Actually, an additional parameter is compiled in, which is called a continuation. And continuation is a fancy word for actually a very simple callback interface. And callbacks actually have always the same interface. They have a value for the good case and a value for the bad case. So the T and an exception. So under the hood, it's just plain old callbacks, but abstracted away in such a way that you don't feel it. And what Kotlin does actually in the code it eventually compiles is that whenever such a coroutine is suspended and then resumed, it has some state machine where it knows, okay, I've been left off here, this is where I've continued, this is the state that it belongs to it, and then I continue. So the problem we had with interactive toolkits with all these map, flatback, and so on is just solved on a language level. So let's look a bit closer what kind of ingredients we get, because then for Loom this kind of helps. Because there are some really corner cases involved with it. So we have actually, these are the builder methods, and they have 2 parameters. The first one is the coroutine context. As you see, you get a default context. That's why I didn't define it in the example I saw. I said run blocking, and then it was good. But yeah, the context can have a variety of things. And one thing is very important to know is that you need a dispatcher. And eventually, a coroutine needs to be run with a thread. So you need some sort of thread pool. And by default, you get the default thread pool, which has as many threads as you have cores. And you can also have other things like state that is bound to the coroutine, exception handler, and so on. So the second one is actually the coroutine scope we look at, and this gives us something tremendously cool and powerful, which is structured concurrency. But first look at what structured concurrency not. And this we see in the thread example. So in the thread example, if we want to join certain asynchronous operation, we need to do this manually. This is what you do here with calling join. The problem with join is that, guess what? It blocks again. So in these 5 lines of code, we again wasted a lot of resources. So the first thread that waits for a second, but the second now also waits for 1 second because the first one hasn't finished. So we actually introduced 2 times a blocking operation. In coroutines, this is really solved tremendously beautiful, and I think this method signature above is probably the most fancy you've seen today, maybe. At least for me, it was when I saw it for the first time, thinking, okay, what is this? So this is this function literal retriever, lambda retriever, as we've seen in the type-safe builder example, but then it's a kind of suspend one that needs to be in this suspend universe. And this coroutine scope is a tremendously cool object because it actually manages the life cycle of a coroutine and also coordinates the completion of coroutines that could be infinitely nested. This is actually what the scope gives us. And with the scope, we can do structured concurrency. So when I say run blocking, I get this actually refers to the scope. This is what this function literal with retriever give you. This would then be some sort of root scope, and coroutine scope I actually call on the root scope. That's where I create this coroutine scope. And this coroutine scope I would introduce if I want to say that this block needs to terminate first, no matter how many asynchronous processes I spawn within this block. But I want this code to finish first before I proceed. So this is actually how you get clear defined structured behavior with asynchronous processes. So this is what's happening. We call coroutine scope, which has a new scope, which is a parent. Then on the parent scope we call launch. Here we really spin up the new process, which is a child scope. And as said, scopes, parent scopes coordinate the completion of child scopes, and this is actually how we then get what we want. First, started is printed, then after 1 second is printed, and eventually done is printed. And nicely, in a beautifully structured way, and important most of all, it's not blocking. Okay, so now you might think, that's wonderful, this coroutine, it's pure, it's good, it takes away quite some nasty stuff for me, but the world out there isn't as beautiful as this coroutine. So if I have this reactive framework of this future, completable future, whatever, how do these two things interact? Probably would be a nightmare if you had some different asynchronous primitives in your application, a bit coroutine, a bit futures, and somehow it works or doesn't work. Okay? And also about this, they thought very carefully. So what we have is a very simple means to kind of lift existing reactive code into coroutines. Example we have here. So this is the example we would use for this random avatar method, where we use the web client. I don't know if somebody's used it. That's the asynchronous, powerful tool you have in Spring Boot reactor to make asynchronous method calls, which returns a mono. And then again, we go with the mono and the mono all the way. In order to turn this into a reasonable method signature, the only thing you have to do is you have to make this method suspend. And second, use one of the many provided extension methods that converts this mono into a suspended method. That's all you have to do. And then, literally, the mono abstraction has disappeared. So this code still lives on the reactor abstraction, because there's nothing wrong with the reactor abstraction, right? It performs beautifully. It's just the programming model that is so horrible. But lifting it into coroutines, we get the best of both worlds. We get a manageable programming model, which also performs in a very effective manner. And this would be, for instance, the controller. This really all works in Spring Boot. Beneath it's all reactor, but on top it's just like normal code you write. And the beautiful thing on top of that is that the general language constructs like if, else, throw an exception, try, catch, no matter whether synchronous or asynchronous, just works out of the box. So yeah, I think it's really beautiful. We use this stuff also in production, and it also really works great. It's easy to maintain. Also for less experienced programmers, it's just really the perfect way to go. What we haven't talked about is another abstraction you cannot solve with coroutines. This is the one where you have a sequence of asynchronously computed values, reactive streams. There you need an abstraction. Kotlin offers this one, which is flow, comparable to Flux in Reactor, flowable in RX Java. And the nice thing about this one is that it's part of the standard library. So once you learn flow, you learn it once and you can use it no matter which reactive toolkit you use. And also flow can be nicely adapted to all these different reactive frameworks. So to recap coroutines, because then I think it's time to move on to the meat of the presentation, which is Loom. We have lightweight threads. We have the way to write synchronous logic, which is executed asynchronously. We have structured concurrency, allowing us to orchestrate many asynchronous processes in a very understandable and maintainable way. We have interop with these reactive frameworks. And is it non-intrusive? Okay, you probably might guess it. It is intrusive. Because we have to suspend, we need a coroutine scope in order to make all things work. So it's, in that sense, intrusive that when you start out with a blocking method and then you call a suspend method, it's not going to work because a normal method doesn't have this context. Yes? Definitely, definitely. That's correct. So, calling from a blocking context a suspend method, this is what people do. They use run blocking. This is not what you should do, right? Because then you still block a thread. This is not what we want. So this is not going to work. What works is that you start out with a coroutine scope and then have other suspend functions calling suspend functions. That works. You can call a blocking method from suspend function, but not from blocking suspend function. In that sense, yes, it is intrusive. Okay. So, but as a bottom line, coroutines really offer you hassle-free concurrency, really. And I've experienced it myself. It's a tremendous difference in comparison to the reactive toolkits. Of course, Java wants that too. Now I think my whole animation is gone, doesn't matter, and this comes in the form of Project Loom. What is Project Loom? This we'll look at in a minute. And the good thing is that now we have actually our checklist to see what needs to be there in this Loom to kind of make it comparable with coroutines. Project Loom was started around 2018. 2017, Kotlin really got traction. I don't know whether Kotlin also was some kind of incubator to make Loom more active. Its motivation is to create high throughput, lightweight concurrency for the GVM. Its status is still experimental after 3 years, and it will, I guess, stay still so. The examples I'll show you today are the ones that are part of GDK 17. It's already part of GDK 18 now. Probably won't be finally released in 18, it will 19 or 20. But 80 doesn't work in IntelliJ, so, and already changed again some features. So in that sense, it has no official release date. I asked JetBrains, hey guys, what happens when Blooms comes? What is the route? They say, no comment, because there is no official release date, we don't comment. So certain things I show you a bit interpretation on my side, but I think it's good to envision what happens and how this could impact us, at least when we have to make decision now, knowing that this will eventually arrive. So it's work in progress. However, the core design is kind of stabilized. This is what I see in the last year, maybe. Okay, how does it work? Loom. This is the operating system. You have CPUs, you have kernel threads. We've seen that these kernel threads are expensive. They cost about 4,000 or 1 gigabyte for 4,000. And the Java model currently, actually since the beginning, more or less, binds its threads more or less directly to a kernel thread. It's not more or less, it really binds a thread directly to a kernel thread. In Loom, they introduce a new concept called virtual threads. First they called them green threads, fibers, all these terms have come along. Now it's virtual threads. Maybe tomorrow it's something else, but I think they will stick to virtual threads. What a virtual thread? It's actually exactly the same like coroutines, conceptually. So you have these lightweight threads, you can spin as many as you want, so millions at least per gigabyte. And yeah, in the end, a kernel thread needs to execute them, right? And they had this construct of carrier threads, as they call them, and these are threads you cannot access. This is kind of hidden for you. You just deal with virtual threads, and that they're executed by a real thread, that's not your concern. Besides that, we still have normal threads, because sometimes you need to have CPU-bound work, where you just want to be as close as possible to a kernel thread, then you would use a kernel thread. But for all this I/O stuff, these virtual threads are really great. So how do they look like? And this is Kotlin code. So all the Kotlin code that was possible with virtual thread, I show you, and some code is not possible. And I hope you won't be too shocked. You see this Java code. So this is the thread example, which prints thread. And this is the virtual thread example, which prints virtual thread. So, can you see the difference? Hey, there is no difference, because virtual thread literally extends from thread, but it gives thread different semantics. Okay. That's what I thought first time. So let's look at the difference. We had the coroutine example on top. Below we have the virtual thread example. Let's see if this performs a bit better compared to the normal thread example. So this is the start virtual thread. Let's hit the button. Make it a bit more readable. And see, 1 million is created quite quickly, but then, takes quite some time to process them. So, apparently gets the job done. It took about 12 seconds, whereas the coroutine example took 3 seconds. So, I think Loom still has some work to do there. But it works, kind of, right? We can now spin many threads. So lightweight threads we can tick. The thing that is really cool about Loom is that they did something very ingenious. They rewrote actually the blocking I/O clause. So whenever a virtual thread hits a blocking I/O operation, they kind of automatically switch to a new I/O operation, which works asynchronously. So they do exactly the same like with coroutines. They suspend the call and then they resume once your network has replied. And this they did actually for all kind of blocking constructs within the GVM. So also some certain I/O classes that are blocking, Java with concurrence, the locks, for instance. So now all these old-fashioned, for instance, REST template, all these blocking constructs we used years ago, all of a sudden perform as well as these reactive beasts like web clients, which actually makes them obsolete. And you get again these pure signatures, so you get back a real image, but beneath it performs as well as the reactive counterpart. I think so this is really cool. So how does it work? Actually same like the reactive example, except that you don't have a thread pool at all, because you can spin as many virtual threads as you want. And the behavior is the same as we said, virtual thread hits I/O, then suspends, once reply comes back, another carrier thread will pick the virtual thread in continuous processing, and so on and so on. And the result is exactly the same in terms of resilience like the reactive stack. So if something becomes slow, we still can take on requests because we can have so many of these virtual threads. So also parallelism we can leverage. Everybody happy peppy. Yeah. So the point is that you think it's blocking, but in fact it's not. It's an I/O. Okay, let's look at how they implemented structured concurrency. I have some minutes left. So this is the sample we saw before in Kotlin. This is how it looks like in Java. Java has a problem because Loom doesn't introduce new language features. Loom gives new semantics to an existing construct called thread. So in order to make something structured, they needed an existing construct to put it in. So they were looking, where could it put it in? Okay, hey, we have this try with resource block. Maybe there we can put it in. That's what they did. So they kind of re-abused try with resource block to make this section execute before the next. So no matter how many asynchronous processes spawn with this executor service, this is how they implemented structured concurrency. So coroutine scope is same like try with resources. When you have async await, we've seen in Kotlin, you have this async, then you get back a deferred as it's called. You can call await in it, but in Kotlin it doesn't block. In Java, they haven't introduced a new construct. So all of a sudden, these nasty 1.7 futures, which had this blocking.get method, all of a sudden, good again to call. Because, yeah, you think it blocks, but it doesn't, because it's a virtual thread. Okay, so actually all these reactive constructs that have a blocking method, the ones you shouldn't have been called before, in mono it's block, in coroutine, in completed future it's join, in future it's get, is all of a sudden good again to call as long as you are in a virtual thread context. Yeah, let's talk about exception propagation. In Kotlin this just works as you expect. In the virtual thread example, it works when you do a get, then you would get back the exception. However, if an asynchronous process throws an exception without returning something, your exception just vanishes in limbo. Whereas in the coroutine case, you also could do a try catch around an asynchronous computation. So there it's not really perfectly implemented. So you get some sort of structured concurrency, but not to the full 100%. So kind of. How about interrupt? So there's not really interrupt, right? Because Java still needs these reactive frameworks when you do, for instance, things like async and await. It just gives actually a new dimension to existing reactive frameworks. So all the blocking methods are kind of okay to call again. This is actually what it does. And
yeah, I really kind of feel sorry for the poor souls who are confronted with that, because this can get very, very confusing. So look at this example. One is good and one is bad. I know it's a bit a lot of code just to get it in your face, but I help you a little bit. So what you do is we create 3 calls with the REST template, blocking network calls. The first example is fine, the second is not. Why? In the first example, we use this virtual thread. In the second example, we use a normal thread, new fixed thread pool, so an old-fashioned kernel-bound thread. And when we call in the second example .get, we block a thread again. How you explain to someone who hasn't really worked with thread that this is working this way? Good luck. So same syntax, different semantics. So we see lightweight thread, that's fine. In terms of this synchronous expression, Loom, I think, really is better than Coroutines. Non-intrusiveness, Loom is definitely better. Sturdy concurrency is better again in Coroutines. And in terms of interop, Coroutines is way better because Java doesn't really have interop. So this is not the conclusion of my talk, because what will eventually happen is this. It's Loom with Kotlin, right? And the question is, how do we end up? And I think this is going to be really a wonderful future. And why is that? Because we can assume that coroutines probably need a makeover, right? So as they work now, they probably won't function. So maybe suspend keyword might disappear, I'm guessing here, but it doesn't make sense when a virtual thread to have this kind of intrusive context. Not necessary anymore. But we most probably get these beautiful builders again, which allow us to create these word threads, to have the scope nicely working as you would expect. So we might get beautiful builders that make this virtual thread as manageable as with coroutines, with the benefit that they are non-intrusive, as long as it's virtual thread. I think that would be really great. Flow will stay because we need such a construct. Maybe also some changes there because Flow has also some suspend methods. They probably call differently. So all in all, I think the Kotlin, the impact for Kotlin, for you as a user, I think for the design team it will be a big impact to make this all work. But for us as a user, the impact I think is not very big, very large. For Java with Loom, I think for 70 to 90% of application there is also an impact, as long as you don't interact with threads directly or use a reactive toolkit. So if you just use these normal Spring Boot applications that are all blocking today, you kind of get a boost automatically. However, if you're using threads or reactive toolkit, then we get this confusion we saw before. So depending on whether you're in a virtual thread context or a normal thread, you really have to behave totally different. How you make this understand, developers already have a hard time to understand all these reactive constructs. I think it's really going to be an issue. And so at least the asynchronous processing of these reactive toolkits just you can throw away. So if you're sold your soul to this reactor, then yeah, I think your soul is kind of lost. So to round up, we had some insights today how this Loom works. Think, how does it impact the decisions we make today? The decision tree I use is as follows. So you really have to ask yourself, do I need this high throughput resiliency like in React applications? Do I really need it? Or is it just enough if I can spin up another container and it will also perform good enough? And if you don't need it, then I would say, just stick to your blocking model. It's fine, because eventually Loom arrives, you get the boost yourself. If you really need, if you have a business case that you need this robust, resilient, and so on model, then I would say, choose for coroutines, not for the reactive stack, because you get, first of all, a way more manageable programming model. Coroutines are almost the same like normal code, except you have a bit suspend functions. And when Loom arrives, you probably only have to reduce or remove the suspend keyword. Maybe there's even a converter in IntelliJ which says, okay, convert to Loom. I can imagine they're going to build this. And then your application just perfectly works in harmony with virtual threads. So this would be my advice. So to round up, if you're a developer like him sleeping, I think it's a good time just to continue on sleeping and wake up over maybe 2 or 3 years and the world has become a better place. Okay, thank you.
Nice job, man. Well done. So for our physical audience, we're going to have a choice, actually. You can either go have a break, and we'll be back at 2:45, or next door, we're going to have a talk on how Kotlin makes Lombok obsolete. So your decision. Seats are limited there, so first come, first serve. And for our audience back home, we'll be back at 2:45. Thanks, guys. See you in a bit. And we're back. Welcome back, everyone. Sit down, get comfy. We're going to do our last round of talks, starting off with some functional programming in Kotlin. And we're going to explore some arrows, or arrow. It's just a singular arrow, with Ties van de Ven. He's asked me to save the questions for last. So we'll get to those at the end. Enjoy. Have fun.
Thank you very much. Yeah, good afternoon, everyone, and welcome to my talk about functional programming in Arrow, or in Kotlin using the Arrow framework. So first, a little bit about me. My name is Ties van de Ven, and I'm a software engineer working for a company called J-Driven. And I've been doing professional software engineering for about 13 years or so, and I'm actually quite proud to call myself a software engineer, because I'm really passionate about the engineering part of software engineering. And with that, I mean, I love the high level concepts, high level abstractions, general reasoning about code, and just the whole problem solving aspect of it. And because I'm very passionate about this topic, I love to talk about it. So you guys may think that I'm here as a service towards you, but instead, you're providing me a service because I just get to talk about my favorite subject for 40 minutes, and it's kind of rude to interrupt. So on that note, my friends and family and such would like to thank you for finally getting a break from all this. So I wasn't always an engineer. In the beginning of my career, I was working on this big monolithic application. And with a big monolithic application, you have to think about something that's 10 years old, over 1 million lines of code, currently about 1.5 million lines of code, and still gets features added every day. And most of the time I was working on this, I was working on solving and creating new bugs. And when you start fixing bugs for quite some time, you slowly start to get a certain hate against these kind of bugs. And you see certain patterns, as in, hey, this bug is basically the same thing I solved last week, just a slightly different context. So I try to find ways to how can I reduce the amount of bugs in my code? How can I change my software coding style to make sure that these bugs won't happen anymore? So I started doing this, and slowly, over time, I rediscovered a few things, like immutability and such. Back then, I didn't know that was an actual thing. I just tried different stuff, and some stuff worked, some stuff didn't. So when years later, when I finally started reading into functional programming, I realized I could have saved myself for like 3 years of time by just reading up to this, because I discovered basically the same stuff. So it's important to note, I came to functional programming not from an academic point of view, because it's a very academic subject. So I'm not great at the math aspect of it, although I'm still learning that, and it's actually quite interesting. I come to functional programming from a solution point of view. I needed a solution for my problems, and functional programming was giving the solution to me. So if there's anything after this talk you want to remember, try to look into functional programming. It will definitely make you a better programmer. So what will we talk about today? We're going to do a little bit of functional programming theory. We're going to talk about monads, specifically the item monad, how it would look like if you use it in a real-world application, and we're going to finish with some optics. If you now think, hey, that kind of looks familiar because we had the same topic earlier this morning. Yeah, there will be some overlap. Just use this as an opportunity to boast to the person next to you on how good you know this stuff already. Okay, so let's talk about functional programming. And to start with, let's ask the question, what exactly is functional programming? And this is a very difficult question to answer. There are some official definitions, but every functional program you ask will give you a slightly different answer. So my answer to this question, functional programming is a story about love. It's about loving your compiler. Because as a functional programmer, we try to make as many runtime exceptions and turn them into compile time exceptions. So once the code actually compiles, you're basically guaranteed to know that stuff will just work. So that also means you have to write a lot less tests, because your compiler already makes sure these things can never go wrong anyway. It's about loving your team members by writing explicit code. For example, if you use the immutability pattern, state changes suddenly become really explicit. You instantly know state change has happened, instead of some setter way down the function scope that's ruining your day. It's about loving your cake, and a bit more about that later. And of course, about loving your functions, because it's functional programming. So let's talk about functions. And specifically, let's talk about function signatures, because it's actually arguably one of the more important things of a function. So what is a function signature? A signature is derived from the input and the output of a function. So if you take a function foo here, it takes a string and produces an int, which means its function signature is given a string, produce an int. Or if we abstract it even more, basically given an A, produce a B. And if you now think, yeah, that's basically true for any function, that is true until we need to do something with error handling. Because suddenly, if your function can go wrong, it has an extra return type. It either returns the correct thing, or something else needs to happen. It needs to return an error state. So what is in that sense error? We reach an invalid state. We now need to short circuit. We need to stop executing code from now on until we either manage to recover or we crash the current program or thread. So how does Kotlin solve this issue? Kotlin has runtime exceptions, and we have the nullability system. So let's take a bit of a look how those things work. We have here a divide function that takes two doubles and produces a double. So the signature is given to doubles, produce a double. Since the second operator cannot be 0, we do some checks for that, and we throw in this case a runtime exception. When I said the function signature is given to doubles, produce a double, this is actually a lie. What the function actually does is, given to doubles, I might produce a double, or I kill your current thread. Which, if you think about it in that way, is actually quite a horrible thing to do. And the worst part is, the only way for you to know this as a developer is by reading the bit of documentation I added on top of the function. Now, I'm sure all of you read the documentation of any function used before actually using it. But I'm sure you have some team member somewhere that doesn't always read all the documentation, if there's documentation at all, because in a lot of cases, this is not documented at all, and this is hopefully catched by your tests, or else this is a nasty runtime surprise. So runtime exceptions are actually quite a nasty thing, but they do have one advantage. Once something actually goes wrong, we know exactly where it went wrong and what went wrong. Since we get a nice stack trace, and it also has a nice message that we couldn't divide by 0. So if it went wrong, we actually at least know why it went wrong. If you now compare this to the Kotlin's nullability system, suddenly the function is also a lot shorter. But now the signature is given to doubles, produce a double question mark. And this is where Kotlin's nullability system comes in. Because null in Kotlin means something very different than null in Java. Because in Java, it's basically an any type. Whilst in Kotlin, something being nullable is there in the type system. And the question mark says it might return something that is nullable. And this is a very powerful thing, because Kotlin will not let you operate on a nullable value. So instead, we need to use operators like operator, which says, if the previous value was non-null, then execute this function on it. And we can keep on chaining the happy path until we finally reach the point where, hey, if anything went wrong previously, we use the else operator and just use this default value instead. And this is a good thing, because we can now keep thinking in the happy flow and only need to deal with the exception all the way at the end. But it does have a bit of a problem. Something went wrong now, but we don't know why. So on one side, we have runtime exceptions, which we don't know, they can occur, but when they do occur, at least we know what happened. And on the other side, we have the nullability system, where we do know something can go wrong, we just don't know what goes wrong. And I want both. I want to have my cake and eat it too. I want both error context, and I want error as a return type. And because I had this problem, I did some Googling, and that's where I finally found the Arrow framework. So what is the Arrow framework? It's a functional programming library for Kotlin, where the good news is it's on the heavy development, so they're continuously adding more features, improving stuff. The bad news is it's under heavy development. As in the 1.0 release was September this year, that's only a few days ago. And because everything is under heavy development, the changes they make are arguably good, but code samples from January don't compile anymore. And there have been places in the documentation that says // to do. So actually coming up with some examples here, that took a lot more effort than I previously expected. But I imagine now there's a 1.0 release, things will stabilize a bit more in the future. And the stuff that's there is still production ready. So what does Arrow offer us? It has some monads, it has a few improvements to coroutines, some objects, and some metaprogramming where you're actually writing compiler plugins. So today we only have time for some monads and some optics. I really wanted to include some metaprogramming, but after finally getting it working after a few hours, then I read that they're completely revamping it and it's going to be released next month. So maybe that's a talk for next time. So let's talk about monads, and specifically the Aigner monad. And when I mention monads, that a lot of people find that's a scary word. But it really depends if you come from a problem solution perspective and first an academic perspective. Because you have the monad paradox, when you truly understand the monad, you can no longer explain it. But you guys are lucky, because I actually don't know what a monad is, and therefore I can explain it to you. So a monad is very different from the Mavi stuff and from the problem solution side. So from a problem solution side, a monad is nothing more than a wrapper you put around the return value. Because a function cannot right now return a correct thing or cannot return the correct thing at all, but you still want to return something. An example for that, we just saw in a previous talk that mentioned the future, that's also a monad. It cannot return a function now, a value now, so instead I'll return a wrapper that takes care of that stuff. So a monad, it's just a wrapper around the return value, and that's it. So let's talk about the Aigner monad. The Aigner monad has two generics. There's a generic on the left side and a generic on the right side. Where the generic on the left side contains the type of the error context, the stuff we missed with the nullability system. And on the right side, it's a generic of the actual type you're interested in. Where the convention is the right type is right. This right is right, that's the happy flow. If you're now thinking, what is this for kind of weird naming convention? You're not alone in this, but to be fair, it's kind of hard to find a naming convention that works in all scenarios. So they picked this is default, we just have to live with it. So you have the left and the right, and right is right. It's also important to see how the Aigner is actually implemented, because it's using a sealed class, which means it has only two possible implementations. It's either an instance of left or an instance of right. Therefore, it can never be both. So while the Aigner has two generics, you never actually get an Aigner object. You get an instance of right or an instance of left. So if we now look at our divide function, if you would rewrite it using an Aigner, we will see that the function signature is now given two doubles. I either return an instance of left containing a string that says what went wrong, or I return an instance of right containing the actual double we're interested in. And we can just create this instance like this. Or if we're a bit more lazy, and since Kotlin has extension functions, we can just call .left or .right on it, because they made extension functions for everything here. Or if we want to be even more lazy, we can just replace this whole thing with the Aigner.catch, which just catches any exception that gets thrown and turns it into an instance of Aigner.left. If we now think, well, that throwable on the left, I want to actually go back to our string, well, that's perfectly possible, because we can just call a map_left function, where we transform the left side into whatever we say it needs to be transformed in. In this case, we can just supply the string again, turning our function signature again into given two doubles, return a string with either a left contains string or a right containing a double. If we can map the left side, we can also, of course, map the right side, where we can turn, in this case, our double into a string. It's important here to know that the map left only gets executed, the function you supply it with only gets executed if it's an actual instance of either.left. Otherwise, this operation just gets ignored. Same with the map, it only gets executed if it's an instance of either.right. So this is where your happy flow goes. This way, if anything went wrong within your entire chain, you don't have to worry, the rest of the code won't get executed, won't waste any CPU cycles. So now we have an either, but you can't actually use an either in stuff. At some point, you actually need to go back to a value. So what does that look like? Don't worry, we're gonna go from the top to bottom here. First, we're gonna get our either from our divide. So although the type is either string double, it's actually an instance of either an instance of right containing a double or an instance of left containing a string. One strategy is to completely ignore the left side and just call or null, which means if it was an instance of right, you would just get the double. Otherwise, if it was an instance of left, you get null. Or else is another thing, if it's an instance of left, just give this default value, or if it was an instance of right, give me the correct value back. But this is actually not a really good use case for an either, since we have the error context for a reason. So let's see how we would use that. And because it's a sealed class, we can pattern match over it. And because it has only 2 instances, this when covers all of those cases. So we can first check if it's an instance of either.left, in which case the Kotlin compiler is nice enough to automatically cast my either to an instance of either.left. So my either.value is in this case of type string. Otherwise, we can check if it's an instance of either.right. Again, the Kotlin compiler casts my either here to an instance of either.right, which means that my either.value is now an instance of double. So we can do things like ×2 on it here. And lastly, we have a get or handle, which tries to transform the left value into the type of the right. So try to recover from being a left. In this case, we have a string, so it's going to be quite hard to return to change that into a correct double. So in this case, I can just use it to log an error and return 0. And the nice thing about either is they compose really nicely, in a way that you're actually quite already familiar with. Because if you think back at our Kotlin nullability system, it's actually very similar. So we have our divide function, which returns an either, or at the bottom, using the nullability system. We can now continue on doing the happy flow on it. In this case, I use a flat map because the map operation actually wraps the result into a new either, and that would mean we would get an instance of right containing an instance of right containing 2. The only difference is with flat map, it doesn't do the additional wrapping. So the short is, if your function returns an either, use flat map, otherwise use map. And in the end, we're going back to a value. So if you can use the Kotlin nullability system, now you can also use monads. It's that simple. Monads are actually not that hard from the problem-solving perspective. Also, if we're seeing this code, we're now completely ignoring the left side. And if we're doing that, I would also suggest don't use an either here. If you don't do anything with the error context anyway, just use the inbuilt Kotlin nullability system. Because I don't want to give you a tool now, get you all excited, to transform all your code using eithers, and just not using them. That would be a bit of a waste. So now we know what an either is. Let's see how this would work in a real-life application. So I made a bit of a pseudo Spring Boot-ish application. It's just for the example. And we're going to start with a very naive implementation and slowly see how eithers would improve this. So we can start by defining a few repositories where to get data. In this case, you have a repository that can get a speaker, a repository that can get a conference, and a repository where you can store a booking, which is booking a speaker for a conference. Very simple, you don't have to think too much about it. And that one will return a long, which is the booking ID. So our service would look something like this. First we get a speaker, Then we get a conference from a conference repository, we create a booking, and we store the booking. And we need a controller which gets the booking from the service and just return HTTP 200. Why is this a naive application? A lot of stuff can go wrong here. What if a speaker isn't found? What if a conference isn't found? What if my database connection dropped? What if a web service isn't available? A lot of stuff can go wrong here, and yet this perfectly compiles. One thing we could do to mitigate that a bit is, of course, just put a try-catch on it. And we have to make sure our repositories throw a not found exception in case something is not found. Otherwise, we have catch just a general throwable and solve it that way. But I kinda don't really like this approach, and I'm gonna show you why. So, how can IDES help us improve upon this? Well, before we start dealing with the right stuff, let's first create the left value of IDE. And I would suggest using a sealed class for this. So we can define a class bad state and give it 2 members in this case. Either something is not found or something is a bad state with exception. And it can only be one of those 2 in this case. So now we have our left value. We now need to do some magic and rewrite all repositories that now return IDEs containing a left value of bad state, which is either not found or a bad state with exception that saves the exception. And on the right side, whatever it was returning in the first place. I'm going to skip the service for a minute and go straight to the control. This is a lot of code. So let's go through it slowly. First, we're going to create a booking. So out of the service, we get an IDE that's either an instance of left containing a bad state or an instance of right containing a long, containing the booking ID. Because it's IDE is a sealed class, we pattern match over it. If everything went correctly and it's an instance of IDE.right, we can just do the old behavior, return a HTTP 200 OK. If, however, it's an instance of IDE.left, because we use a sealed class as a left side, we can now pattern match again over the left side. So we can decide if it was a not found, we send back a 404, and otherwise we can just lock the exception and send back a 500. And now you may think this actually looks quite similar to the try-catch. What did we actually achieve here? Well, to be fair, quite a lot. Because first of all, now because we get an IDE back and we need to return it to a value before we can actually do something with it, before we can actually return it, we are now forced by the compiler to deal with it. So we can't be naive and expect it to be right. We have to make a conscious decision to what happens if something fails. Not only that, because we have a left sealed class for the left value, if we would now add, for example, a duplicate booking to it, in the try-catch world, you don't know this exception got added until someone remembered that was the case. There's no warning for that whatsoever. But the nice thing about pattern matching using when, our code would no longer compile anymore if an extra class is added to the sealed class. You're forced to add it to this when statement. So if any rules change later on, you're forced to think to deal with it. And this might not look much, but actually quite recently, a few days ago, we did a change on a very small service where we converted exceptions into an IDE, and we actually did found a few spots where we forgot to do certain error handling. So it's a very easy mistake to make, and I just love it when I don't have to think about all this stuff, my compiler just does it for me. But although this is really awesome, the actual service becomes a bit more ugly. Because what happens here is, first, we need to get our speaker, but this is an IDE. Then we need to get our conference, but this is an IDE. And to make our actual booking, we don't need IDEs, we need values. So we need to do some quite ugly flat map magic to get the values out of those IDEs, and then store it in the booking. And you can see that it's already not very readable, but the bigger this business logic comes, the more unreadable this becomes. So there's a bit of a dilemma. on one side, I want all the compiler safety that IDLEs give me, and on the other side, I want to have readable, preferably imperative code. So I want to have my cake and eat it too. Luckily, Arrow can help us with this. And this is my favorite feature in Arrow, the monad comprehension. So what does it look like? We can just add this block with an IDLE. If we now, within this block, have an IDLE, in this case, I'll just create one, we can now call .bind on it, which means if it was an instance of write, get the value out of it, and in this case, put it in a variable write value. But if it was an instance of left, it would immediately return from this function. So the next line only gets executed if the previous statement went good. So we're back to only having to think into the happy flow. And it will automatically immediately return. It would immediately short circuit if anything went wrong. And we can return in the end. You may notice, however, our function is suddenly suspended. That's because Arrow uses coroutine magic to make all this short circuiting happen. If you're now thinking, yeah, I don't want to put suspend in all my functions, no problem, just use idle.eager. And all that stuff gets taken care of you. So if we now use this, what would that do to our service? Oh, very simple. Now we just get an idle.eager, get our speaker from our speaker repository, call.bind. If everything went correct, this line would get executed. Get our conference, call.bind. We can now just create a booking and store a booking. So we're back to our nice, readable, imperative code, while still on the water doing all this complex flat mapping stuff, but we don't have to think about this stuff anymore. So this is why it's my favorite feature, and I can just add business lines of code and just call.bind on it, and all my error handling still gets fixed, and it's compiler safe, which I think is pretty awesome. So what did we learn? Thanks to IDLEs, we can get compile time safety, and thanks to the IDLE comprehension, we can still do our old days imperative code programming. So that was all about IDLEs. Kotlin of Arrow also has something other cool to offer, which is called optics. So immutability is a really good pattern, and I talk a lot about it. I don't have time to explain all the benefits of immutability, so I kind of assume you'll want to write immutable applications. And Kotlin actually supports this very well with the Kotlin data class. So there is one problem with it, however. To see that, let's first create some data classes. So you can create a person data class, a city data class, and a street, where a person has a city, and a city has a street, and everything has a name. What if we now want to change the name of the person? Well, in Java, this would be a hassle. You have to create a whole new person object, supply all the parameters and such. Luckily, we have a better language here. We have Kotlin, and we have a data class, so we have a nice copy method. And because we have named arguments, we can just supply it with whatever value needs to be changed. So we can just do a person.copy and supply the new name. And now new person is a copy of the previous person. It just has a new name. This works perfectly fine here. But what if we want to change the street name? Then it starts looking something like this, where we need to get person.copy, change the city property. First, we need to get the city property again from person, so we need person.city.copy, get the street property, then we need to get the person.city.street.copy, and then finally, we can set the street name. So the copy method works really well if you have just a data class. But once we have a deeply nested domain model, this actually doesn't work anymore. If only there was a solution for this. Because I want to have immutability, and I want to have ease of state transitions. So I want to have my cake and eat it too. Thanks to our optics, we can actually do this, because it provides a lens and a traversal. So what is a lens? A lens is an object that's made to look at a certain property of a different object, and looked only at that particular property. So if we take back our person, we can create, for example, a lens that goes from person to the city property of that person. So we create a lens, we create a getter for it, where we get the property we're interested in. And we have a setter, where we can set the property, change the value of that property. So now we have a lens that goes from person to city, and we can use this lens to get the city property from the person, or to modify the city property of a person. Again, this is actually not that interesting, because we could have just used the copy constructor here instead. The power, however, comes when we start creating more lenses. For example, if we also create a lens for the street property, so a lens from city to street, and if we create a lens from the street to the street name, suddenly we can compose these lenses. So we're creating a lens that goes from person to city, from city to street, and from street to street name. So now we have a lens that goes all the way from person to the street name property. And now we can use this lens to instantly change the street name of a person in a deeply nested data structure. If you're now thinking, that actually sounds really cool, but let's be honest, having to write all these lenses is basically more work than actually writing all those copy methods, then you will be completely correct. If you have to do all this work, why bother? Luckily, Arrow can generate this stuff for you. If you had an add optics annotation before your data class, it has to be a data class, it doesn't work on normal classes, unfortunately, and you supply a companion object, Arrow will go through all the properties of the data class and make a lens for that property and put it into the companion object. So if you want to change the street name of a person now, we only have to do this. We can call the person object, get the city lens, go to street, go to name, and now instantly modify our street name property without actually having to write any lenses ourselves. So if you're dealing with deeply nested data structures and having trouble with mutation, this is actually quite a cool thing to use. But only if those are in data classes, unfortunately. Sometimes you just don't want to just change a property in an object. Sometimes a object can also contain a list, and you want to do some deeply nested changes to that list. That's where we have a traversal, where if we have a person object, a new person object, which has a name and another list of persons, of siblings, we can just now create a new object person, Bob, and he has siblings bro and sis. So what if we want to change all the names of all the siblings of this person? Let's first create some lenses. So we create a lens that goes from person to siblings, and we create a lens that goes from from a person to name. Now we can start composing again, and within our composition, we can now add a traversal. So we're creating a lens that goes from person to siblings, then from siblings to a traversal over all those siblings, and from then to name. And now in one operation, we can change the names of all our siblings. So if we have lists in deeply nested data structures, we can easily use lenses and compose those lenses to modify all that. If you think, I don't want to modify all my siblings, I just want to modify the first one, we can also just do it by index. So it's exactly the same thing, but instead of traversal, we now use an index. Or we want to change every odd index sibling, we can also just use a filtered index where you can supply a method that selects the index. So what did we learn about optics? Lenses are objects that look at a certain property. We can compose these lenses to create really powerful lenses that can look into properties that are really deeply nested into data structures, and Arrow can generate all this stuff for you so you don't have to. So in the end, I think we can conclude that thanks to Arrow, we can have both a context and an error type as a return type. We can have both compiler support for all our error states and readable code thanks to our IDLE comprehension. And we can have immutability and ease of change. So I think we can safely say that thanks to Arrow, we can have our cake and ED2. Thank you so much for your attention. I've been Ties van der Ven. If you have any questions, feel free to send me anything on those things. I never post anything on Twitter, but I'll answer questions. Or I'm here now, just come talk to me live so I can talk even more about this stuff. So thank you very much.
Any questions now from the audience? We have about 5 minutes. Oh, there's 2, 3, and ahead of someone we haven't heard yet.
Thanks. Yeah, I found this very interesting. I have one question. Since you mentioned you did use it in production, what's your experience with debuggability? Because it adds a lot of things. Is it still nice to like debuggability in sense of actual debugger that you attach? Or
First of all, in practice, I didn't need to debug that much because that's basically the reason I use this. My compiler protects me from things going wrong. Yeah, I could just use debug pointers everywhere.
But it's not, because I mean some of these libraries, you have so many layers of stuff in your stack frames that it gets a bit annoying to step through. That's what I mean.
Yeah, in this case, I did it. I can't even remember if it was more difficult or not. So it might have been slightly more difficult, but just not so much that I got nightmares from it.
Yeah, thanks a lot.
So does the tooling support for the either monad help you not forget to call .bind? Because I feel like that would be something that I would forget frequently.
Yeah, in a way, yeah, if we go quite far back to that example. Yeah, if you don't call .bind, like if you look at my either here, so now I have an either that I don't call .bind on. If you look at the type of the either, it's an either there. So if you actually want to use the value that's in it, you're forced to call .bind, or else you should just have an either here. So in that sense, you cannot forget to call .bind.
All right, gotcha. Thanks.
Yeah, how do you stay so skinny when you have all that cake?
Unrelated stress.
Yeah, I have a bit maybe a nasty one because I've done this stuff a lot with Scala, where this is very common, and you have even more advanced constructs to deal with it. What I had with Scala is, for instance, when it comes to monad transformers. So you have not only either, but you have another box in a box, which is a different kind of box. So for instance, you have a future, and the future has an either, and then you have to unpack the future. The future has again an either, you have to unpack the either, and then things start to get quite nasty. And as long as it stays in a box, that's fine. But when you start to mix boxes, then things go worse. You have any experience with it, Kotlin? Have you made a bit more advanced examples like that?
Slightly. Arrow offers a few more monads. One of them is validated, and that one just happens to work quite well with either. But that's a bit, basically for us, it's the same problems as in Scala. It's hard to use things like optionals in between. If you start mixing monads, then stuff gets weird. But like an either does have a to-option method, and the arrow optional has a to-either method. So if you mix them, that's going to be difficult, but they do offer methods to transform between the different things. But yeah, if exactly the same as Scala, monad transformers as such make things very, very complicated.
So as long as you stay in arrow, then you're actually fine. They have all these transformations there, but when you
start
to
this
mix,
won't work with a monad from another library, no.
Okay, cool, thanks.
Cool. I think that's it with regards to time then. Thank you so much. Give it up for Ties again. Cool. Our next talk is going to dive into some real-world examples. Not that these have not been real-world, but it's more of a story, and I love storytelling. It's about Greenfield inspiring early-on project, so that's going to be a lot of fun. We'll be back in 5. Good. And we're back. I think most people are still coming back in. Yeah, 5 minutes is very quick to go to the toilet and do all that jazz. But we're already back with Joost Heijkoop and his real-world Kotlin experience. Have fun, man. Enjoy.
It works.
Is
Nice.
the screen sharing?
Yeah, should be.
Yeah, there it is. Go ahead.
Well, hello everyone. There's a lots of people. I haven't seen that many people in one room in a very long while. Wow. Hello. Yes. I'm gonna explain a lot about my experience, and I hope you can share in this experience. This is me. I'm Joost. I'm a passionate software craftsman. I develop mostly JVM and browser stuff, and I'm an independent consultant and contractor. I also, up to I think 2 years ago, were a very passionate organizer for Kotlin and Scala meetups here in Amsterdam. And well, you can reach me on this address. First, I have some assumptions about you. I hope you can have this sort of base knowledge, and if not so, please ask me to explain some of the stuff, but I can't explain all of it because we don't have that much time. I will tell you where my experience is from, and then I will show you the different technologies we've used with together with Kotlin, and show you examples of how we used it and the stuff that's the fun stuff we had with it, and the gotchas we encountered. So, my assumptions is that you have a basic understanding of a Java backend life, or so you have some development experience with the Java ecosystem and developing stuff in this ecosystem. I think it sort of also applies if you have Android experience, then you are also in the Java ecosystem. And yeah, I also assume you have some familiarity with the Kotlin syntax. So if you have any questions there, please ask, but I can't explain too much. So, I boldly claim I have a lot of experience with Kotlin. This experience is from my current contract where I work for bol.com, where I joined 2 years ago in a very ambitious project that wanted to replace or actually insource a piece of software they have been using for 10 years now. And there was an end of life on the environment this software ran in. So it either needed to be rebuilt by the third party that supplied this, or some guy within bol.com said, like, we can also do this ourselves. So we started out with a proof of concept to show that we can do it ourselves. And that sort of grew into more. Yeah, there's a key part of this is that we're insourcing a very important part of bol.com. And we have a very strict deadline that the other software stops working at a certain deadline. But apart from that, it's a greenfield project where we just go. Yeah, given the current situation, all of it was remote in the beginning. Everything, like we sit in a video conference all day, and we emulate sort of office experience there. And we got to see each other after a couple of months in real life, and well, it sort of went up and down given the situation. We started out with 6 people. These 6 people were a couple of developers and some business analysts, and this quickly grew into 20 and even 40 people now. And this is a project of a lot of seniors who are very passionate about building the best thing for bol.com. And yeah, this has been a very nice experience, nice culture to live in and to build in. We've been using a lot of technologies. Here I have a list of all the different technologies we are using, and I probably have forgotten half of them. There's many more technologies we have been using and I've had experience with. And I will go through some of them at a time and show examples of how this works out for us. So to start, Bol.com is a Spring company. Everything is, well, most of it of software development is built in Kotlin in Spring. And the good thing about Spring is it has a very nice interop with Kotlin. It has a special DSL, special syntax and helpers which are completely invisible if you are developing in Java, and they suddenly appear if you switch to Kotlin. And that makes for a very nice experience. We are using Webflux, but we're not using the full DSL for routing and all the other stuff, but we're just using plain old Spring kind of things with the annotations and components everywhere. And it just works. And that's very nice. Where it just works has some side notes. So far, the Kotlin has been a lot of fun. It's not perfect, but it's a lot of fun, and I have a lot of experience. I gained a lot of experience, and I think I've really enjoyed it. Within Bol.com, there's also a lot of experience with Spring and Kotlin, and this is also a very nice environment to operate in. They have their own homegrown parent project, which gives you a lot of batteries included stuff, where you can just start a new project and it works in their environment, it works in their cloud environment, and you don't have to think about all the details. The only thing with their framework is that it works on Maven, and my experience with Maven is it is tremendously slow to compile stuff in there. So that annoys me from time to time. Let's take an example here. This is how easy it is to start a Kotlin project with Spring. In the middle, I can actually use my clicker. We have the main function and an annotation on a random class, and we start our application. That's all we need to start, and then we can start building REST controllers, like is shown on the right, on the bottom right, and we can start building a web server. So not a lot of boilerplate to start out with, not a lot of rituals. You just get going, and you're happy, and you can start delivering business value. My biggest love of Kotlin is the extension functions. I have tried sort of extension functions in different languages. The top one is Kotlin. The middle one is how you would do it in Java, where, well, it is not really possible. So you get static functions everywhere. And the bottom one is the one which is in Scala. And actually, the one in Kotlin is the least friction. It's so easy to use. It has made me happy, and I've used and abused it everywhere. So yeah. And I can just create whatever I want. I can do higher order functions. They all are first-class citizens in Kotlin, and happily do my thing, and don't get caught up in all the language rituals you have to do to make something work. More function love. You can do weird things as storing a function in a variable. You can create operators, sort of, with words, or if you use the magic names, you can actually do operator overloading and do infix operators. And a surprise that came up was that you can call something list with a capital L, and then you get a iterator or sequence kind of thing, and do stuff with it. It's all kind of nice things you can discover in Kotlin, which some of your colleagues are just doing, and then you go like, oh, you can do this too. That's very nice. And but yeah, Kotlin can also have weird syntax. The bottom object extends my interface is how you create an anonymous class, which has surprised all of my colleagues every time they encounter it for the first time. It's weird, but it makes sense if you know how Kotlin is built. There's a lot of nice help in Kotlin. On the left, you can see how I embrace the nullability and use the special question mark dot operator and a let and a Elvis operator to actually just fold like I used to do with an option in Scala. And I use this pattern a lot, and it makes it so much easier than doing if checks and stuff like that. And on the right, we have a random example of the library functions that make creating data much easier. And the data classes, of course. Yeah, one of the things that sort of was not so nice is when. Like when is a much better switch, but it sort of supports some of the things you expect to do with pattern matching, which it sort of emulates. And you can do when with the subject, and then you can match against it, and then it works. But then you can't do the extraction you can do elsewhere. So in the middle example, I'm trying to extract my tree, which is a data class, which I should be able to extract in the match part of my when, and that doesn't work. Okay, I'm used to doing this from Scala, and it makes a lot of sense to be able to do it in here, but yeah, the first time you try, going, oh, that doesn't work. Okay, sure. And then you have the bottom version where because the when sort of has no keyword for each of the cases, you either operate on a subject and you can only do one test, or you can do a combination of tests, but you can't use a subject, and then you need to use the name again and again. Well, given how Kotlin is built, I would expect to be able to use it, like here. That would have made a lot more sense. Yeah, there are other quirks in Kotlin where if your last parameter of your functions happens to be a higher order parameter, a function, then suddenly the syntax changes. Like I write a lot of functions which take more than one function as an argument, and then the last one has different syntax. And then if I want to pass a function reference, then suddenly the syntax reverses again. And yeah, this is one of these things that it makes sense that they tried it like this, but it gives very awkward conversions back and forth when you're refactoring code. But yeah, it can be nice to be able to write sort of control structure like syntax. Sorry. There are nice gotchas in the Kotlin syntax. Kotlin actually transpiles to Java bytecode, so it inherits some of the things you know from Java, but it also can be very confusing. This is an example of where I make an inheritance tree, and actually, luckily, IntelliJ warns you about this, but I got this question a while back where one says, okay, I created this parent thing, it takes a parameter in the constructor, and then in the construction init I print the value, and then I override it, and I do the same there in the construction of the child. I also do the same thing. How come that the first print line gives a value and the second one gives null as an answer? Then this happens to because Kotlin translates property access to a get method, and even though it looks like test at the top is in scope of the constructor, it is actually not. The constructor, the test you write there is translated to the get test, which is a member on the class which is not initialized yet because we're in the constructor. So this gets all kind of weird stuff going on. So sometimes the Java translation stuff leaks out. But yeah, there are quirks. Every language has their quirks, but it mostly is a very nice language to work with. In Spring, we of course want persistence. Most applications have state, so you want persistence. And we started out with Hibernate, but quickly switched to Kotlin Exposed, which is a persistence framework built for Kotlin. So it's much more idiomatic Kotlin to work with, and makes it much more natural to continue the functional thinking, the data oriented thinking you get used to in Kotlin. We used it with Postgres. I think everyone knows Postgres and uses Postgres if they are in some kind of environment. And we use Flyway to make it very easy to just build up our state. Yeah, so that all worked fine, but the Kotlin Expose is a very young library. It has weird DSL syntax where you get confused quite a lot, where you get the feeling like, okay, this is actually not a 1.0 and absolutely not a 2.0 version of this framework. And it's probably could have been done better given you have experience with how you actually use it. And the documentation for it is quite scarce. It is a new framework. There are not a lot of Stack Overflow questions and answers on this. The documentation itself is very sparse, and they introduce new features which are not in the documentation examples yet. But yeah, in the end we figured it out, and it worked quite well for us. We've been quite happy. So let's take an example here. Here on the left, I create my small table with my Flyway script, and then on the right, I create this syntax where we create a table, then create a repository where we used the table, and then you get confusing stuff like I'm going to do a where clause on my table, and I need to use the word select, which is really confusing at first. And then you need to select columns. And then you use something called a just slice, and if you start doing inner queries and joins, then suddenly you need to use aliases because the framework gets confused which column needs to be mapped to which part of the data. So yeah, I have experience with very fancy frameworks like Slick in Scala, which took a while to get sort of right, but these kind of things they figured out by now. So yeah, it would have been nice if they could have built on this experience instead of having to like reinvent the wheel again. And apparently nobody has noticed that the query returns an iterator. Everyone just maps over it, which in Kotlin is a library function which turns the iterator into a concrete list. So suddenly all your results are pulled into memory. So be mindful that you can actually also stream data from the database. On the bottom you see the toDomain function. This is a pattern we have, I think, invented at our project, where we always have the result row which you get back from a query extension function which just converts it to our domain object, where you can read it and then and then can use it, which has worked quite well for us. Only the alias thing is weird because it tries to abuse the array notation to access stuff, and then you do array notation into a thing which then does array notation in another thing, and then if you would make alias optional, then you have no clue how to do this without building big if-else structures. So yeah, weird syntax. So let's go to the next part of our stack. If you do a web framework on Webflogs, of course you're very mindful, you need to be reactive and don't block on stuff. So you have two big significant options in Spring. You can either go for the Project Reactor stuff, which is like homegrown by Spring, where you use monos and fluxes. Or you can go for coroutines, which Spring also happily supports. Our team started out with a lot of senior developers, but with not a lot of experience with Kotlin. So they actually felt more at home with the Project Reactor stuff than with the coroutines. So we started out with using that. But yeah, Project Reactor is sort of the Mona thing that you get confronted with all the boilerplates. You need to be able to operate on these kind of things where you lift these kind of effects into the types. And you need to learn new DSL. You need to know what map means. You need to know what flat map means. And also they have some weird behaviors. Later, in newer sub-projects we had, we were building a microservice environment, so we started extracting a lot of services. In newer services, we started looking for, into coroutines, and it turns out it gives you very nice code. But yeah, somehow some people are scared of it. So you need to have a good argument about this and make a lot of people happy so that they know the coroutines are very nice to work with. Both have very weird gotchas and well, even though Kotlin promises to have full interop with Java, some stuff doesn't work, and you need to figure out how to work around this. Why did I put in cannot block on main thread? Ah, that was a nice one. Right. This is not a gotcha, but a nice thing actually. The Spring framework or the Reactor framework, it warns you if you try to block on a main thread, because, well, that's one of the framework's threads. You don't want to block it. And it just happily says, hey, you're trying to block on a main thread. This is not allowed. So that's very nice. And that sort of catches the gotcha where you didn't allocate a new thread pool for blocking work. But the other thing is that you can't block on the main thread. So as soon as you're in an environment where you can't return a mono or a flux, you're stuck. You can't break it. And then you need to sort of figure out, you need to actually allocate it on a different thread pool before it works. So here I have an example of, I did my nice work in Flux. I wrote I had a list, turned it into a Flux, and then I flat mapped some work in it, which is also a reactive function which calls out to some server somewhere. And then I just flat map it, and it works. And for the mono example, where I just get one value, it's more simpler. But I need to learn this new syntax. I need to learn flat map and map. Once you have learned that this just works. You can do everything you want. If you go to coroutines, then the first thing is you try to translate it, and then I go like, okay, I don't have a flux, so I can keep my list. I don't have to translate it, and I'm going to flat map work in there, and I just add some suspend keywords, and then the compiler says no. It refuses to accept this because flat map is part of the standard library of Kotlin, which is like old school kind of without any coroutine stuff. And the function I'm trying to shove in there is not a normal, regular lambda, but it's a suspend lambda. And then it turns out I fall back to writing a for loop to get through this problem, because I can't somehow inject a coroutine scope in there. I haven't found a way to work around this. I just had to fall back down to basic for loops here to get this to work. The mono example at the bottom is very easy now. It's just string interpolate the value into the string, and then add the magic suspend keyword to the function, and then voila, compiler is happy. And I think this makes a much more legible code in general, but sometimes, yeah, you do have to work around that. Coroutines don't always interact with other existing library stuff. Yeah, at bol.com they have been very hard trying to transition from a data center to a cloud environment. When we were starting there, we really just we started in the beginning of the transition, and we looked at the cloud environment and it didn't work. So we started out in a data center, and we started out with a 1 month proof of concept. So we had no room to just go fiddle and try and wait for them to finish whatever they were doing. So we built a monolithic application which was prepared for splitting out into multiple services by using the submodules from Maven, and having each of the modules communicate through REST or through messaging. And this for us proved out to be a very good strategy, because as soon as the cloud environment became ready for different kind of things. We could start split out the work. Like we had some part which didn't need persistence, and the persistence wasn't ready yet, but we could already start operating services. And this was for us a very good strategy, and it worked quite well. And yeah, Bol.com also provides a lot of extra tools for us to happily use the cloud environment without really caring about provisioning and getting stuff communicating and punching a hole through firewalls and connecting up networks and stuff like that. So that worked out quite well, and I think it's a good approach. If you start a new project and you're doing proof of concept, just build the monolith, but keep in mind that it needs to be modular, and then you can build like crazy. After a while, we figured out we wanted to do GraphQL for our front end. We built all kind of services that were happily communicating through REST and messaging, and at a certain point it was like, yeah, we need humans to operate on this system, and we started adding a new service, which then exposed a front end, and tried to figure out how to use GraphQL. And to do the GraphQL, we actually looked at 3 different libraries, the Netflix one, the Xebia one, and the Apure-based one. And we eventually settled on the Xebia one because it was most Kotlin-like, and it fit our needs at most. Like the Netflix one is much more Java-like, and is actually schema first. And we wanted to have code first and generate the schema. And the Xebia one allows for both. And the Xebia one has very nice Kotlin support. It's actually built, well, it has Kotlin in the name, so it was built for Kotlin. And then we also tried the Apure-based one, which looked very nice, but seemed dead. There was no activity on their GitHub page for, I think, half a year when we started out, and looking back, it has been dead for 2 years now. So that was a very good choice to do. Yeah, and I can fully recommend this GraphQL library. It interacts sort of nicely with Spring. I think it works better with what is it? Arrow? No, Kotor. Sorry, the other one, Kotor. All the examples are written as though you're going to do the Kotor version, but it actually you need to configure like a small thing in Spring, and then it just works. And then you can happily use all your annotations, all your components, and instead of having to force the functional DSL kind of thing approach they have in Kotor into Spring. And it just generates schema code, and actually on the client side we use Apollo in the browser, which then happily reads in the schema again and generates all kinds of TypeScript magic, and we are fully type safe. The one thing I have with GraphQL in general is that it has no knowledge of generics. This is a complete pain if you try to serialize a map. Like, you need to create your own map-like thing for everything you come up with, and there's a lot of generic things, like we have a lot of paginated results, so we have a paginated object, and it no work. But yeah, apart from that, GraphQL in Spring and Kotlin is a very good mix. Yeah, I show you in the center, I show you how you write a query. You say, I have a component, this is my query, it extends the query thing, and that makes the Spring magic pick it up. And you give it a function. You can make a suspend function because this is fully Kotlin aware. And you need to return this magic thing called the data fetcher, which can either hold a data or an error or both. If a sub-part of your tree fails, and it just works. It generates a schema for you where it really looks like a schema. You can't really see it on the top right, but here we have the GraphQL playground, which is available to most GraphQL projects. We can just go query the language, it shows you the schema, it does syntax completion for you, and that's a very nice experience. And on the bottom right, you see the weird syntax the function helper function I generated to created to be able to translate from our generic object to a specialized version of a class, where I can give it the constructor to a class. And then at the bottom you see I have my data, which was a page. I turn it into a paginator through my nice extension function I created. I give it the constructor for my specialized page thingy, which then loses all the generic information. And I feed it a function to actually also change my domain class per element in the list to a response object. And here you can see how Kotlin shines. It can solve most of your weird problems with just a bit of extension function magic. Very, very nice. Yeah, and the last part, I don't know if you're interested in this, so I didn't include examples here, but we worked with TypeScript, React, and material design in the front end. And oh, she caught me off guard. And here TypeScript shines too, with using GraphQL, type safety, and you can just happily go along, develop, and the compiler just shouts at you if you do something wrong, which is very nice. And the only thing about TypeScript is it is so much more complex than a Kotlin would be. I argue it's way more complex than Scala is, and some people find Scala complex already. And me knowing Scala, I can happily program in it, but some of my colleagues are surprised by the things you can do, and think you write sort of a token soup if you use some more advanced constructs from TypeScript. So here you have to really be mindful, don't overdo it, because people get confused quite easily. And also, it is very, very hard to debug errors. Kotlin compiler can also give some weird compile errors, but the TypeScript compiler is way worse. I actually didn't want to include the example, but I think I can show it again because I have some time left. At the bottom right, you see this is a compile error. This reminds me of when I was doing Scala in 2007, when the Scala compiler generated these kind of errors. Nowadays, it just tells you what's wrong instead of going like, yeah, somewhere in my parsing something went wrong. So yeah, that was fun, and we used React because we're functional programmers, and React is way more natural to functional programmers than the other stuff. And we have some very simple, it's called Toussaint library for state management, and that interacts nicely with the rest, and we're happy. The only downside of TypeScript is it's not just complex. The compiler also thinks it's complex because it's very slow. It's way slower than the other stuff. So it was a summarizing. It's a very nice place to work at bol.com. In this kind of greenfield project, this environment has been a great experience for me learning Kotlin. Because before this project, I played around with Kotlin. I had like these toy projects. I actually taught Kotlin to a lot of people at the meetups, but I never had this really good experience of how, what kind of friction you would encounter if you built like real world, really big projects. It has been a great experience. I've learned a lot of new cool technologies. I've learned to work with Spring again, which I hadn't been doing for 10 years or so. And in the end, everything is a compromise. The Kotlin has been a very good enabler, but it has its downsides. I wouldn't pick anything else at this point. And the GraphQL thing was also sort of compromised. The Kotlin exposed is also sort of a compromise. But it's the best thing we could find, and I think it is way better than most other options we considered. I like the culture and the support I get with there. So any questions about bol.com or the technologies we used and the assumptions and conclusions I had about them? Do we need to give you a mic?
Yep.
I was wondering.
Flimsy.
Okay. I was wondering, you chose for Expose because you didn't choose for Hibernate. What were the reasons why you chose Expose? That's for one. And second, could you then name two really benefits you had choosing for Expose and maybe also two drawbacks compared to Hibernate? I'm kind of curious. I mean, I know Hibernate's a lot of black magic, but did it really get so much better? I would like to know a bit more about it.
Yeah, so we chose Kotlin Exposed over Hibernate because Hibernate doesn't map well on a relational database. We dropped down to writing plain SQL instantly, and then you get the choice, like, do we just use JDBC then? And then we went like, no, but we're doing Kotlin. People have nice stuff for this, and I can't remember which we tried, but we tried several different approaches. Also have like this. Who is it? Verbatim? No. My Batis kind of thing, where that maps way more on record-based thinking on the database. But yeah, Kotlin Expose is a way more elegant way in Kotlin to have this record-based thinking, and build with this, and just use functions on it instead of you having to like write your own strings and concatenate them together. You have actually sort of builders for generating your queries. That was, I think, the biggest reason we chose it, because it just maps onto the database and it allows for more builder kind experience, which you might know from my Batis. Okay.
No other questions then?
Oh, I have a question to you.
Go ahead.
Are you all already doing Kotlin now, or did I convince you somehow? Do you want to do more Kotlin? Or do you all go like, oh, the guy's insane, I'm going to do Couture, the weird guy?
Let's see some hands for who's already doing Kotlin. And let's see some hands for who wants to do more. Those can be the same hands, yeah, obviously. Yeah.
Well, they were less enthusiastic than the first then, so I think half of you are experiencing some of the frictions then. And so what do you feel? Do you agree that Spring and Kotlin would be a nice thing to just get stuff done, or?
We can have a chat with that in the break that's coming up.
Yeah.
So at 4:45, we're gonna have the last talk of the evening. Did we save the best for last? I don't know, but you'll find out in a bit. So we'll see you then. Cheers. Thank you. Yeah, and we're back. Welcome back, everyone. So, the last talk of the day, Sebastian Aigner. Certainly, how do you say that? Last but not least, exactly. Because we're going to talk about keeping Kotlin fun. Enjoy, everyone.
All right. Hi, everyone. Yeah, I'm Sebastian. Really great to be here in person again after a while, honestly. Let's do a little bit of expectation management in the beginning here. We've all heard a lot of really exciting things today. I think everyone's taking something home that maybe they'll be able to apply maybe during their day job. Don't put that expectation on my talk, because I really don't care on whether you can apply the things I'm going to talk about. I'm more about the fact that I want to kind of inspire you a little bit to rediscover or keep the joy in programming and do that with Kotlin. So before we kind of dive in, yeah, this is me. You may have seen my profile picture next to some Kotlin release posts, or maybe on the Kotlin YouTube channel. I do a bunch of different things as a developer advocate for Kotlin at JetBrains. If you haven't seen me there, please do take a look at our channels. I think our media managers are going to be very happy if I mention those. youtube.com/Kotlin. As a developer advocate, I'm kind of on a bit of a special mission, and that is generally that I want to help people learn in general, right? And people have different motivations to learn, and people have different ways that they can learn. Whoops, yeah, okay. I guess we'll just start with that then. And so one of the things that I obviously do a couple of days is I ask myself, how do we learn? Because, well, we write materials, right, for people. We want to figure out what drives people to learn. And again, there's all these theories, right? If I actually knew how people learned in general, I would probably not be doing developer advocacy. I'd be, I don't know, revolutionizing our education system. But there's one little hypothesis that I usually work with, and that is that generally when people engage with a topic on some kind of level, when they connect to it, they solidify the knowledge that they get, and especially if they enjoy what they're doing, if things are presented in an interesting context, then maybe they'll remember them a little bit better. So this is not going to be your typical tech talk. I'm not going to tell you what kind of architectural patterns you're going to use next. I just want to give you a little bit of an inspiration. I want to take you through a couple of projects that I built when I couldn't sleep late at night. They're completely random. They don't have anything to do with each other. But the one big thing that they all have in common is that I did the thing that you would expect from a keynote, and that is I extracted lessons out of them. And I made sure that these lessons are generic enough that you can apply them, but specific enough that you still believe that they actually have something to do with what I say, right? So I've split those into two different types. We have the technical lessons, which maybe are a little bit more applicable, and then the motivational ones, which are a little bit more of the fortune cookie variety, which maybe just kind of help you motivate yourself if you're feeling down. So moving on, we can just kind of start with my first project that I want to talk about today. It's called Bullgen. It's very, very dear to my heart because it was born out of a story of frustration. So let's turn back the time to an era where people still came together, for example, for hackathons to build cool and interesting projects. Specifically, this was at the very start when I was actually still in university, and there was thousands of students all coming together in big halls and working on interesting problems, and then presenting solutions to some sponsor companies about how they can revolutionize some kind of industry, right? So, and that always happens in a really short period of time, right? So you always need to kind of figure out what you spend your time on. So this is a picture of us being very frustrated and also being very caffeinated. The frustration came from a very simple point, and that is that we noticed over time, we were a team, 5 people, we always kind of went to these things together, and that is that people kept spending more and more time on flushing out the presentation instead of working on actual functioning prototypes of what they were doing. And this was like, we had this real hacker like attitude of like, if I can't show it off, I'm not gonna talk about it unless it's like the last couple of slides of like future work. But you had all these people spending 48 hours like polishing their slide decks and winning prizes. And that got us a little bit frustrated. So we applied the engineering approach to this. I'm like, well, if we have a problem, we can probably figure out a solution. And the idea was just, how far can we actually just remove the human from the presentation process? And kind of figure out a way to maybe achieve the same thing that these other folks are doing, just without actually spending the time of polishing a slide deck. Obviously, that's a best effort type thing. So what was born was our project called BullGen. If anyone wants to venture what the name is about, feel free to. We called it an innovative generation-based knowledge enrichment using crowd-chained machine learning. Makes absolutely no sense, but had enough buzzwords to apparently attract the attention of a couple of people, which is great fun, and is honestly, it didn't really stick out all that much from all the other submissions that we had. If you had blockchain-based brake energy, like recycling for trains, there was very strange things happening. So we were in good company. And the whole idea, essentially, for this thing was the following. Let's just generate a slide deck automatically without us actually building anything. And let's also just make up the whole project from the start, right? So completely conjuring up something out of nothing. We set up this like really basic structure of how we wanted to build things. Just like a regular presentation, you have like a big topic or a theme, and then you just have a bunch of different generators that all pull information from different sources or generate stuff from different sources to kind of create a final presentation. And all we did at the end was we generated a Reveal.js presentation because, well, you could just export some HTML, you get a slide deck. Now, of course, you need to do some things. One of the classics is, of course, you just find a list of things that you want to talk about. You put those into an actual Kotlin connection, and you call .random on it, and you would be surprised how coherent that sometimes even sounds in the context of other business presentations. The trick we did was we actually went around our university to the different chairs that were all doing innovation management and such. We just looked at the posters and kind of picked out a couple sentences. Of course, there's a bunch of different ways that you can approach all these kind of things, especially if you have, for example, names and stuff. You can mangle a lot of the input that you get. And this is actually one of the first smaller technical lessons. If you want to get a leg over some of your colleagues when it comes to understanding Kotlin, just actually read more of the suggestions than you might actually use, because all of a sudden you might understand that on a string, you can do all kinds of weird things that might help you down the line, that might help you write more idiomatic code. That's just a little side note. So, especially fun was, our team didn't really know Kotlin, but because it was kind of Java-like, everyone kind of got started pretty quickly, and everybody had a bunch of fun with this as well, just kind of experimenting for the first time, because they're always very like small, self-contained things that you build when you just play around with a bunch of text, right? So, we did want to step it up a little bit, and one of our colleagues who was a data scientist actually suggested using Markov chains, right? So if you're not familiar with Markov chains, at least in the context that we were using them, they're essentially like a machine learning light where you give it a corpus of words, and then it can generate words that kind of sound similar to that. There's a library called Markov NameGen, which I believe is implemented in Hexe, but there's also an implementation for the same thing in Kotlin, and it can do a lot of like just fun things. So, for example, here it is fed with cooking utensils, with a corpus of cooking utensils, and then just dreams up new utensils, right? So, you have a blowtor or a measure rinder or a chin opener. That doesn't sound too good. Yeah, so it can just generate these kind of things. And then when you just kind of put all of this together, you end up with like a really cheap way to just generate some kind of slide decks. And you'll find that these things, if you think about them, they make scarily a lot of sense. So we just had show text. That's an amalgamation of the top 100 startups we had on Crunchbase, fed through that generator. Then we just pick three different topics. So we have general merchandise stores, platforms, and e-markets, which will then be fed as like an input to all the other generators that follow afterwards. And then you go through the slides. So we have an initial motivation slide, which again, it picks up one of the topics. We're going to be disrupting general merchandise stores. And then it picks out different topics, right? Because the general merchandise store industry is really struggling with organically grown complexity. Yeah, that sounds about right. And too many middlemen. Who doesn't have that problem? We also introduced fun little clip art in there, so that you always have a couple of graphics in there. Never too fancy, just so that it's really believable. Again, this isn't GPT-3 or nothing. That's literally just a template, like a string template, but it still worked well enough. We, of course, wanted to completely overdo it. So we started pulling random LaTeX formulas into our presentation, which have absolutely nothing to do with anything. But you can just find these on the web, and you just list random and just render one of them in there. And when someone's standing on the stage and they're talking with a lot of passion, you'll find that people, they're not going to read. You're not reading this right now. Because it doesn't matter. You're just listening to what I have to say. So it's a perfectly fine backdrop. Yeah, and it really does make it look like we actually knew what we were talking about. And, we combined a bunch of different APIs. We pulled in, we played around with image search providers. There's motivational quote providers where you can also just give a search term to it. We also wanted primary sources, so we pulled in archive, which has all the pre-published papers and published papers. We had a general opinion section, which pulled in the Twitter API, and essentially we just browsed a bunch of awesome lists. So, for example, there's the public API lists on GitHub, and you can just find a bunch of really cool sources for doing this kind of thing. So, to actually dive a little bit deeper into how you then actually do this in Kotlin, because we want to take away a little bit of a technical lesson. We combined what I call the trio, the triple dream team, whatever you want to call it, and that is Ktor, Coroutines, and Kotlin X serialization. Hey, they all start with K. That's anyway. So we have in this example, you can see how you can get a fully type-safe way of pulling something from an external API, right? In the first 3 lines, all you're doing is you're instantiating a new HTTP client and tell it to use Kotlin X serialization, which is a reflectionless serialization library for Kotlin. Then you just define a DTO, some kind of data model, annotated with @serializable, and then you use the client.get extension function with a generic parameter paper, and you'll have your API kind of ready. And as you can see, that's a suspend function, so that integrates nicely with everything you've seen today about coroutines. So, and again, by the way, note that I really love this. You can look at this code, and it's actually readable from a size-wise. And a lot of other languages have the problem that you need to either split it or you need to omit things. Here, you can just put it on a slide. Kotlin is kind of concise. And at the end of the day, that generates a suggested reading slide. So yeah, maybe if you want to kind of follow up with things. We hit the rate limit a couple times, but nobody noticed. So that's why you have a couple of unnamed papers, because I don't know, something was wrong, but yeah, really nobody cared. Now here's the central question. How do you present a project like this? Well, I mean, obviously there's only one way, right? It's you generate a presentation and you go in front of the crowd and you play PowerPoint karaoke. and you present your project that doesn't exist. So we only submitted to the creative track because we didn't want to interfere with the other folks who were working on a specific task that was given by a company sponsor. But a couple of these sponsors were still looking into that creative track when we were presenting this. So we stood there and we presented the presentation. And to our confusion, they were really excited about the thing we presented, which was really worrying to us. One of them straight up asked us how long it would take us to get to market, which again, for a product that makes no sense and is completely I'm not sure if that says more about our industry or if that says more about our project. Anyway, the other reaction we got was after we told them that was auto-generated. That was not so, not quite so excited, but honestly, we would say it was completely worth it. We briefly contemplated, before going off stage, telling them, later today you're going to see one more presentation that's generated using our algorithm, see if you can spot it. But we didn't want to do that to another team, because I feel like that would have been maybe a little bit too mean. Yeah. Okay, so from that project we can take a couple of lessons, maybe. The technical lesson is just try some new stuff. Use a couple of APIs that maybe you haven't even used before. There's so many data sets out there that you can just do like exciting stuff with, that it's really worth just kind of having a look at it. If you have someone on your team who has a background in a specific field who can teach you something about a new algorithm, about a new approach, about a new way of modeling things, try to absorb that knowledge because it might help you the next time. And vice versa. Take the time and actually teach others. Again, we had people learning Kotlin for the first time during that hackathon, and we still managed to be productive. So, might be something exciting as well. Yeah, on the motivational side, I think sometimes you just gotta do something else for a bit. If you don't feel like doing the thing that might be the most productive right now, it might be good taking a step back, changing your outlook on things, and still kind of approaching problems from a different angle. Because if you want to be creative and you want to have a creative outlet, that doesn't necessarily mean that you have to find the fastest algorithm for something or you need to solve the world's problems. It's perfectly fine to sometimes also just do something that you think is fun. And ideally, you don't do that alone, but you do that with other people because that's how at least I stay motivated. From there, we're going to move on to another project. And this one's gonna be Titular and Code Quiz. So this is gonna be two projects that, again, I just kind of built at some point during the last couple of years, essentially because, well, we used to have this kind of board game round with a couple of folks, and well, you know, the whole pandemic hit and stuff, and we wanted to continue playing something online. And, you know, there are these kind of party games, but at some point we figured, we might as well just try and maybe build one of these party games ourselves. Because, you know, software engineer, you're like, weekend project, no problem. 2 days, maximum. I obviously also wanted to do a little bit about with Kotlin for the web, which I think is also something that's quite exciting and doesn't maybe get as much recognition in the spotlight as it could. So I sat down and at some point I built just a little bit of a game, which is nothing special. It pulls strange images from some subreddits. It prompts everybody using a web interface to write a funny caption for the image. And then after everyone has submitted their suggestion, people get to vote. That's actually not completely trivial to implement because there's a lot of state management going on and also a bunch of concurrent processes because everyone's kind of voting and maybe you're doing like WebSockets. We'll talk about that in a second. But the cool thing was this was like a really small project and I had nothing to lose in this because it was like completely clean room, green field type project. So that is also why I set myself the challenge to be, I want to have this 100% Kotlin. No JavaScript in there either. Should be 100% Kotlin. We'll talk about how that is structured in just a little bit. But as luck would have it, after putting that project to the side for a couple of months, we had this great thing, which is our JetBrains hackathon, where we came up with this idea of saying, hey, we want something how we can engage with people when conferences happen again, and also during live streams, all these kind of things. And we wanted to have these kind of code quizzes for people, right? So that you can just have some kind of engagement, because, yeah. And if you're kind of paying attention here, you might see already some parallels that maybe a quiz app, and that thing probably shares a little bit of an architecture. So the result of our hackathon back then was Code Quiz, which really is just this trivial thing where you can present a snippet of code, which is also a runnable code block, and then people can dial in using their phones and submit their answers, and then at the end of like a 20 question segment, you get a leaderboard of the best people, and you can hand out some prizes. But the cool thing is that this was essentially, to a certain degree, recycling of just a project that I had built late at night. So while we completely rebuilt it from scratch, I already at least had an idea of how I wanted to architect everything. And the architecture for this wasn't exactly crazy. You did have, but it was completely Kotlin. So you did have a game server that was completely written in Kotlin JVM together with Ktor, which did the whole state management. Then you had a game client, which was written in Kotlin JS using the Kotlin React framework. We'll look at a little snippet about that in a second as well. And then we'll essentially just have one big cable, which is a WebSocket, and over that we just exchange game messages, which have certain different types. So you just have a start game event, vote, join lobby, send question, all these kind of things. And yeah, so you just kind of communicate all of this. And the way that this is implemented, again, I'm a Ktor fan. That's also the framework we built, so I might be a little bit biased. But one of the great things is that, for example, WebSockets, which are kind of like for real-time communication, mesh really nicely with the idea of coroutines. Because as you can see here, so in this example, I'm opening a WebSocket, and this is just a very simple echo server, which just iterates over that socket using a for loop. And for every incoming frame, it just sends back the same frame with like you said. And this just, so that just halts, that just suspends after each iteration. But again, you kind of write code that looks sequential, even though you can react on events that literally come from an external source. And again, I think it's just so cool that this is like 10 lines of code. And then, of course, the fun part is because Ktor is not just a server framework, but it's also a client framework. You have an API that looks pretty much exactly the same on the client. So once again, you can just have, you can just instantiate a client here, and you can once again just use a for loop to iterate over things and exchange or change your state, for example, automatically. And of course, then you want to connect this somehow to UI paradigms that are kind of modern and declarative. And for that, we picked React. So there's a small snippet here for the React DSL for Kotlin, which defines a functional component which doesn't take a couple of props. But if you've done React in TypeScript, for example, this snippet might look very similar, except for the fact that button uses the weird curly braces. That's because that's a DSL. One of them that we've already seen this morning, and one of them that we'll see a little bit later as well. But the cool thing is, again, so this is code that I can compile to JavaScript and that can run in your browser, but it just looks like the code that you can already write. Like nothing about this is special. We're actually taking this one step further, so we recently introduced Compose for web, which if you're an Android developer and you've done Jetpack Compose on Android, you literally can now use those same APIs on the web as well. So even if you haven't done React, there's a lot of just knowledge reuse that can happen there, which I personally think is pretty exciting. So the astute viewer will have noticed that one of the things I've mentioned before was that we have one WebSocket and we send a bunch of different messages over that. And that's actually not that trivial of a problem generally because you're introducing something that is essentially polymorphic serialization, right? You have a whole tree of objects and you want to serialize them somehow and then make sure that on the other side you actually deserialize them into the correct subtype again. And that is something that you will literally find me talk about. I somehow managed to put this into every single one of my presentations. No matter the topic, I somehow always end up with Kotlin X serialization and polymorphic serialization because I think it's the coolest feature ever. Because Kotlin X serialization can't just do this. You can just mark a sealed class as serializable, and you can mark the subclasses as serializable, and that just works. There's no hidden when statements that you need to do, or you don't need to have some kind of weird string tags that you need to manually manage. That just works, and that especially works well if both your client and your server are both in Kotlin, because then they literally use the same serialization schema. And that just, it still to this day blows my mind. I just like that. The way it does that, by the way, is not all that crazy. It literally just adds a type field to your serialized properties. But again, when you have, when both your client and your server use the exact same serialization library, it's really easy to just kind of keep everything in sync and put a whole object hierarchy over a single socket forwards and backwards, and it just works out of the box, which I think is really, really cool. Yeah, there's a really good article actually on the documentation for this as well, and they really also talk about the thing which usually people ask after this, which is, but isn't this a security issue? Because everyone always says that generally that's kind of problematic, but the folks behind this who are smarter and have spent more time on this than me actually discuss very nicely in this article why polymorphic serialization, or the way that Kotlin implements it, is not an issue. Kind of summarizing, I would say that having this multi-platform approach of literally saying we'll write code for the server side, we'll write code for the browser, we'll reuse the same libraries and the same data models, was really instrumental for us to actually get something out of the door in 48 hours. And I would really say that Kotlin was it was a lucky pick here, and I don't really say that because I'm a Kotlin developer advocate. It just really happened to be something that really empowered us in this context. Yeah, again, the one big thing I think that is interesting here is, first of all, if you already have competence in Kotlin, this allows you to bring your whole knowledge through the whole stack. People can develop a feature from beginning to end, including the web interface, essentially from scratch, all in the same language. And that also kind of allowed us to really build things quickly. And again, after merging things, if you're 2 hours out from a deadline, it's really nice to know that the compiler makes sure that your data model on the server and the client are the same thing, and you're not going to stand on stage and things are going to explode. If you've been to KotlinConf, you actually have seen this in practice. That's one of that's the project that we've built for KotlinConf 2019. So yeah, Anton Kix, who does the Kotlin Puzzlers talk, used Code Quiz. And we also raffled off a bunch of stuff during the actual conference, much to the happiness of all the visitors. We had a great turnout. Did I think that the stuff that I did beforehand would have really kind of blown up like this? No, I didn't build this so that it would be used by 100 people. It just happened to, and it was just kind of exciting. So the technical lesson is, if you haven't checked it out yet, give Kotlin multi-platform a try. You might find it actually kind of exciting and new. It's a fun little toy. Including new libraries. If you haven't done Ktor or Ktor clients, might be worth checking out. If you haven't done Kotlin X serialization, there's a lot of power waiting there for you to be unlocked as well. On the motivational side, I think it's really good if you take the things you build and you also put them out there, because you might benefit from that, but your colleagues also might. So if you have something that's fun, build it, share it, have fun with it. All right, next project's gonna be nice and colorful. We're gonna talk about Twimoji, amazing. So I'm not sure if you've seen it during the slide deck, but there's a lot of emojis in my slides. That's just the way that I do illustrations, because I don't really have an alternative. They just work really well for this. I use Twitter's Twimojis because these are Creative Commons licensed. I'm sure this counts as attribution, by the way. Yeah, but they also just have this nice, this basic vector style. The only problem is that I also wanted to use these during web development, and there wasn't really a good way to implement or to use these kind of emojis in your web development. All the libraries they had were kind of outdated, so, well, what does one do? One builds a library. In this case, it was just a very simple generator that generates like 3,000 CSS classes based on the SVG files that Twimoji provides you. And honestly, if you think about that, that's a trivial task. You just have some kind of human-readable names that somehow map to Unicode code points, and then all you do is, well, you see if that Unicode symbol has a Twimoji reference, and you filter all that, and then you just generate something from a template, and you get a big text file. It's really like, it's like 3 operations. But this is one of those situations where, again, if it's a side project, you can absolutely over-engineer this, or you can look at this very hard and figure out the fact that, this is actually quite inefficient because you're downloading a lot of SVG files here. So actually figuring out the fact that maybe you want to use a head request instead of a get request might be useful. And I've actually not seen so many people really make use of some of the other verbs that we have out there, especially head seems to sometimes be a little bit outside of the spotlight. Again, this is it's a static generator that runs once every few months. So it doesn't matter whether it runs for 3 minutes or 3 seconds, but it's bragging rights, so I'm gonna do it this way. What's actually more interesting about all of this is that, well, with emojis, you're suddenly starting to work with Unicode. And if you've ever done this, you probably know where I'm going next with this. Because this is where things are starting to get really funky. So this is one emoji, this encoding. But this encoding is actually, if you look closely at the Unicode code points, it's 4 emojis joined together with what's called a zero-width joiner. So the emoji that this actually represents is this family emoji. And so if you ever had a strange implementation of a chat client and you had one of these emojis, it would sometimes happen that if you hit the backspace key, you would delete individual family members from the emoji, which is kind of strange. And if you dive into this, you find a lot of interesting just tidbits of how this stuff has historically grown. For example, the fact that a snowman, by default, it always comes with snow. You have to explicitly specify snowman without snow if you just want the basic snowman. I had no idea. And what I had even less of an idea of is that a tweet like this, it invites so many people to start discussing Unicode in your mentions because people are really passionate about this stuff, which is it's honestly really exciting. And you learn about the fact that this is comes from some Japanese Unicode code pages, which was there for such a long time. And I mean, that's just kind of fun. It's just kind of cool out of nowhere. You also kind of learn about the things that aren't yet in the Unicode standard, and you find interesting emojis. I unfortunately saw that recently, the mild panic emoji. I'm not sure if you've ever seen that one before. That unfortunately got declined, but hey, maybe it's coming back at some point. It's just so interesting diving into all of these things. You You also find out about emojis that shouldn't exist, that are in a completely different code page because, well, technically the Shibuya 109 building isn't an international symbol, but it's supported by the Japanese locale, so now it needs to be supported everywhere, and it gets really odd. So yeah. But interestingly enough, this was one of my most popular projects because apparently other people also face issues with using emojis, so that actually got me 73 stars and 18 forks. I'm not sure how to feel about the 18 forks because I did not receive any contributions. But there was actually one person who essentially modified this to use a different set of emojis, so there's at least one fork out there that's semi-actively maintained, which I think is exciting. But again, 73 stars. Oh, that fills you with dopamine. When you that's a good feeling. The trick, by the way, is add a pull request to the official Twimoji repository and just replace the other deprecated thing, and then people will actually find your project. So that's SEO 101 right there. It also was the basis for more, so I wanted to at some point build some kind of emoji picker, which I then built with Jetpack Compose for, or I should say now, Compose for Desktop, which is our UI framework which builds native user interfaces with Kotlin. That's a very big topic, and I'm already in my last 10 minutes, so we're going to skip over this. But it was just one of the first things that I built because, well, I already had a data set. It had images, text. You could have cool filtering lists. And you could figure out that all JDKs have a broken implementation of the clipboard on macOS. That was kind of fun. So, summarizing here, sometimes it might make sense to really learn the tools that are at your disposal, even if that means reading the Unicode standard, or even if that means just figuring out what HTTP verb you actually want, and not the one you think you want. Yeah. If you can avoid it, maybe don't do Unicode. And again, it was just something that I built for myself, but then I figured, hey, someone else might use it. And it seems some people use it. I know at least of one website that has these 3,000 unminified CSS classes embedded in their source code now, so that's good. Okay, last project in I don't know how many minutes. Thermal Kotlin. So I have this very bad habit of, like, it's 3 a.m. and I go on like Amazon and I go to like the electronics section and I go to like Arduino and Raspberry Pi and I just buy things because I have this idea that, well, if I have the electronics with me, if inspiration strikes, then at least I can immediately build something. Otherwise I have an idea and then like 2 weeks later when the parts arrive, I just don't care about it anymore. So one of the things that I built was this little Internet of Things printer, which essentially, well, it's like a receipt printer, and that prints out images. And there's a lot of like takeaways and learnings that you can have there, which I unfortunately can't go into due to time constraints. One of the most interesting parts, however, is the idea of dithering, which is you have a grayscale or a colored image, but you have an output that has to be literally just black or white images, not grayscale. Because, well, you can either have a dot or you can have no dot. There's a bunch of different algorithms that can all help you do this. They all look different. And this was just a really cool situation where it, once again, you could kind of show off how in Kotlin you can take the example code that they have on Wikipedia and you can like translate that almost one by one and not really expand on the length of it. And you just learn this magic spell and all of a sudden you can turn an image into a black and white representation and you can see it come out of the printer on your desktop, which I think is really, really exciting. One of the other things was this thing supported rich text. So of course, at the very least after this day today, your natural reaction should be, we should build a DSL for this, right? And we actually have one of the big DSLs that Nicolas failed to mention is our HTML DSL, which looks a little bit like this. Again, it's nothing really crazy, but the whole idea was, well, maybe we want to have something similar for our thermal printer so that we can also use rich text nicely from Kotlin. So this is just kind of the stand-in of like, well, you probably have some kind of control sequences, and you need to do a bunch of things. But once you've kind of realized, again, this general structure, it becomes much easier to actually emulate what's going on if you kind of look at the code and try to understand what parts are what kind of Kotlin constructs, right? Because you do have this code, and I love turning on the inlay hints because then you get the idea that once again this is nothing more than a fancy builder pattern where you have some kind of rich text objects and then you kind of compose those together using those lambdas with receivers that we've seen beforehand. You can actually use lambdas like I did here, just don't do it because mind the Unicode. Just stay with ASCII. But yeah, you can write out the whole implementation here. We can kick out this one so you can actually read it because that was just a duplication. But again, you've already seen this today. You end up with a situation where you have a string builder. You have some kind of function to append actual text. You have other functions that allow you to kind of stack multiple of these lambdas inside each other, which is, in this case, for example, the bold function, which takes another rich text builder. And then you just have one kind of entry point, which is your rich text function that just builds all the children and then turns that thing into a string. So I really just kind of came up with this idea at that time because I understood the implementation using Kotlin X HTML. But just kind of combining different things and seeing how they fit together is kind of always really a payoff. It might take a little while until it actually clicks, but when it does, I think it's really worth it. If tech toys and like little trinkets help you learn and help you stay motivated, then I would argue they are a great investment. I certainly won't stop buying them, and I will keep building strange little things at night, even if it means running a JavaScript interpreter on like a little thing. I don't know. We'll see what comes next. So just use that late night shopping impulse for good. All right, that was pretty much everything. I'm almost out of time, so I'm gonna wrap up with just a couple of points, and I'm just gonna read these out because essentially, if you work on strange problems, that means you probably make more creative solutions which you can reuse. You can always make mistakes. That's a part of learning. You can make bad decisions, but make them on a small scale and in a self-contained context. Make sure you do everything you can to keep having fun, because things are exhausting and you might want to do something else, but if you stick with it, it might pay off. Really build things that don't matter, because sometimes just questioning things means learning. Alan J. Perlis, one of the big computer scientists and winner of the Turing Prize, also said it's really important that we keep fun in computing, and that's something that only you can do for yourself. So embrace your ideas, make sure you solidify your knowledge by engaging with it, and remember all the things and enjoy them. That's it. Thank you so much. Not sure if there's questions about this.
Who has any questions? No questions?
Sounds good. You all deserve a beer now.
Exactly. They'll probably ask you some on the way in a bit. So yeah, thanks for sticking with us, guys. This has been the Kotlin Dev Day. For the audience here, there will be snacks and some beer behind you. However, we will have to kick you out at 6 due to regulations. It will be a kick with love, though. So sorry about that. You've been an amazing crowd. There's one little plug that I'm going to do right now. If you're still hungry for Kotlin and all things related to coding, we have a podcast. It's called the Beyond Coding Podcast. You can find it on your favorite podcast platforms, as well as youtube.com/beyondcoding. The episode that came out yesterday was with Urs, and it's about the power of Kotlin. Other than that, let's do a big round of applause for our speakers and the people that made this happen. And I hope you'll enjoy the rest of your evening. Thank you.